Today's class is around the history of blockchains, basically an equivalent class of what happened yesterday in AI. These are the topics, these are the link to the slides. Without any further ado, let's get right into it. We'll kick things off with the timeline of when blockchains as a concept was introduced. Why was it introduced? What are the key events that have happened over the years and where we are at right now? Kick things off with the global financial crisis back in 2008. I think you guys have seen this movie. If you haven't, you should watch it. It's a nice movie, especially if you tend to join a Goldman or a JP Morgan or D Shaw eventually. Fairly common, sort of a movie that is showed / people see. It basically covers what happened in 2008. Maybe your parents know what happened. Maybe you do as well. You might have faced some level of financial crunch, because maybe not government employees, but everyone other than that, at least the private sector back then felt a financial crunch because directly from the US, there were basically a bunch of banks went down, which means Goldman Sachs, JP Morgan, Lehman Brothers, which were, not just banks in terms of what you and I used to transact, but banks that did a bunch of, HNI trading, investment banking, ended up taking a few wrong bets, because of which there was a global financial meltdown. A bunch of these banks ended up going bankrupt, and by the end, the government bailed them out, which basically means the government used the taxpayer money to pay their debts, and by the end, the banks were fine, other than one or two banks that went down. Everyone else was fine, which led to a little bit of discussion around why does the government tend to decide which bank goes down, which bank doesn't. There's actually another movie, which I'm forgetting the name of now. It's something similar only, just ChatGPT, another movie around the financial crisis. This is the second one that's really good, which basically covers what was happening in the government, what was happening inside the banks, and how the final decision was made of bailing out the banks. This led to a few people, or one person, God knows which of the two, called Satoshi Nakamoto, releasing a Bitcoin white paper and releasing a new technology called blockchain. What does blockchain mean? Why was Bitcoin the very first blockchain? Is something we'll understand soon enough. But a white paper came out, and a bunch of people started to run Bitcoin miners all around the world. There was no value to Bitcoin back then. You could buy it for someone, 10,000 Bitcoin for $4. Most of the Bitcoin was distributed for free to developers if you were doing anything in the Bitcoin ecosystem. And no one was really buying or selling this until 2013, 2014. In 2010, someone basically bought pizza for 10,000 Bitcoin just to see if there is any utility. Will actually someone take Bitcoin in lieu of a pizza? And then in 2015, Ethereum launched. 2018, Solana was founded. 2020, Solana mainnet launched. It's called mainnet beta, but it's mainnet now. 2020, COVID-19 hit, and there was a lot of money printing that happened in the US. This was, probably after a long time that people saw not hyperinflation, but extreme inflation, because a lot of money being printed and given out to the citizens of the US. I think it was $600 per citizen. These were called stimulus checks that helped people in the US, during the bad time of COVID. But what that led to was everything becoming very expensive, which is the common question of why can't the government just print money and give everyone 20 CR so all of us can be rich? And the answer there is, if the government does do that, everything will become expensive, and 20 CR will be worth 200 rupees or whatever, 2 lakh rupees as it is today, which is why it doesn't make sense to just print infinite money and give it to people. There was some NFT DeFi cycles that happened in the middle, and the thing that happened last year, there were a few things that happened. Primarily, I think Hyperliquid is the most technically challenging, or a cool thing that came out. Lighter is another thing that came right after. There was very big trading around meme coins. Trump launched their own meme coin called the Trump coin. Then his wife launched another one called the Melinda coin. And they, if the president of the US, which is arguably the most powerful person in the world, does this, it gives some signal or some legitimacy to cryptocurrencies in general. In the end, it didn't really work out as well as people would have hoped for. Trump coin is probably down 90% than its peak. Same is true for like most other meme coins. Technically, I think last year there was a bunch of things that happened at the Solana runtime. A new, not exactly consensus algorithm, but a few extra things came out in Solana specifically at the validator level. Other than that, Hyperliquid and Lighter, which are new separate blockchains, ended up coming last year, and Hyperliquid climbed up to, I think, top 10. in CoinMarketCap. That's pretty much it. That's a high level timeline of what happened when happened. There are of course a bunch of events that I have skipped, but high level, this is where we're at, and this is probably not the first two, but Hyperliquid, Solana, Lighter is probably what we should focus on in this complete bootcamp. But today's class is fairly simple. It's understanding what is a blockchain in the first place. Hopefully this gives an idea of why it was introduced. The reason it was introduced was because people thought that the government controls most currencies, which is not great. And we see this in our day-to-days. The price of INR compared to US dollar is going up. US dollar is highly inflated. The price of gold is going up really quickly, which are all some signs of people losing trust in the currency. We'll talk a little bit more about that in the next slide. That's a high level of what blockchains try to solve, letting people or countries create currencies that no one controls, or at least the government or the RBI doesn't control. It's still up in the air if that will actually eventually become true, or come to fruition. Countries are actually using a blockchain, an open ledger for currencies. There are a bunch of good things and bad things about it. The good things would be corruption sort of goes away. That's one. Tax evasion goes away because everything is public. Everyone can verify if money goes from point A to point B. Why is it going? Right now, we do a bunch of cash transactions and people evade taxes. There's a lot of black white that happens in properties. We can all, if done in a trustless way on a ledger that's publicly available, then all of these shady things would sort of go down, which is probably another reason why this will not happen for a long time. All right. We'll start off with problem with currencies. I shared a few of these already. The biggest one is the government gets to decide when to print, what to print, who to give, and our day-to-day sort of dictated based on that. If the government today decides the salary of every government employee will, let's say, 10x, then all government employees will of course become very rich, but we will also become poor. Everyone else who's not a government employee will become poor because inflation will increase because there's more money in circulation. When this happens, even though it doesn't feel like it, we are actually, our money is losing power, which might seem like a small thing, but over time, over the years, it becomes a very big thing. A good example of this is when we were doing the same class last year, INR US dollar was at 83.74. In the last 1 year, it's climbed up to 90.87. So that's almost, it's like 10%. Indian currency is getting weaker at 10% every year, or at least in the last 1 year, on an already fairly inflated currency US dollar. So and it might feel, I don't know, some people are fairly dumb when they say, "Arey, मेरे को तो US dollar में salary मिलती है. I get paid $2,000 a month. That means now I'll get paid more because I was getting 1.6 lakhs until last year, and now I'll start to get 1.8 lakhs. But hopefully it is clear that most of our money, yours and mine, is in INR. हम लोग बैंक में पैसा रखते हैं. We keep money in the bank, and we're actually owning less and less US dollars over the day. If my net worth was 100k US dollars until last year, now it is 90k US dollars because the INR has sort of gone weaker compared to the US dollar. This is not a good thing. It is not like you're receiving more money now because पहले $1,000 आते थे. It's more. In the end, if your net worth is in INR, then there's a problem. If your net worth is in US dollars, then it doesn't change anything for you. The government / RBI decides when to mint, where to use the newly minted supply, if there is a need for stimulus checks, if there is a bank to bail out. There are, of course, good reasons to bail out banks, at least back in the day. But again, why do they get to decide it? Why was there no public? If they would have asked the public hates banks generally. At least in the US, if you tell someone you're a Goldman employee, you're not treated the best. And hence, if there was a public vote, they would have probably said no. That would have been even worse because then, banks wouldn't function, and, you and I would have had other problems of, not having a banking app to pay with. So it sort of made sense to bail them out. But again, the government shouldn't decide. This is the thesis behind, starting a new currency. The other big problem, which again, you and I don't see because we weren't alive when this happened, was back in the day, there was no concept of currencies. People would barter to begin with. If I had a cat, if I had a cow that could, produce milk, and you had a farm that would produce maize, I would give you some milk in lieu of the maize, and that's how the world functioned. There was no concept of a currency, but eventually, gold, for some reason, now God knows what that reason is. There are some properties of gold that probably makes it, a good currency, or made it a good currency back in the day. But gold became the primary medium of transfer. If I want to buy something from you and you want to buy something from me, I would just put a price on my milk. I would just say my milk is worth $20, 20 gold coins or 20 grams of gold. Someone can give me 20 grams of gold, I will give them milk. The same is true for maize. So there was sort of this concept of currency, because bartering is really hard. You might not have what the other person needs, and hence, a barter system doesn't really scale. Gold sort of scales, but it's still an open question as to why people chose gold. Why not silver? Why not mud? Why not this thing that I have over here? And generally, there are good reasons for it. We'll talk through some of these reasons, but gold was the standard for people to buy and sell something. 50, 60 years ago, the US government created the US dollar and said, we are just creating this as a sort of a something that's completely backed by gold. Abhi aap gold use karte ho. You use gold to, give someone 20 grams of gold, they give you milk. Give us gold, we will give you currencies. Give us gold, we will give you currencies. Currencies ko use karo. Currencies are, you can divide them down really small. They're easy to verify compared to gold. So start to use the currencies, and whenever you want, you return us back the currencies, we will return you back the gold. It was known that gold is a good standard. People have their trust in gold. People realize / think because it glitters. Maybe that's the reason. There are a bunch of other reasons, but because it glitters, let's say, this is a good thing that I want to keep. This is what will hold value, kalko. And this is what I use to buy my daily groceries. The US government said, we will create this thing called a currency, and this currency will always be backed by gold, which means if you give us $100, we'll give you 100 grams of gold. If you give us 100 grams of gold, we'll give you back your $100, so on and so forth. You can always convert one to the other. Around the 1980s, 1990s, they realized they can just print a lot of money and, issue a lot of debt. And hence, this backing sort of went away, which is where the problem came. The other very big problem is, as long as it is backed by something that people actually hold trust in, it is fine. But once this backing sort of goes away, then you've just given someone too much power to create a currency that everyone thinks has value. But you and I depend our livelihood on this currency that someone can control. And it's fairly shady how over the years this backing silently went away, and currencies became independent of the underlying asset. There was a time until currencies were backed by gold. You could always take X dollars to the government. You could give X dollars to the government and they would return you 10 grams of gold. That no longer holds true, which is another reason as to why currencies might be bad, and there is a need for something that cannot be blocked, that cannot be stopped by governments, and that's not controlled by a single person. That lets us do currency exchange. The next question that comes is, why is gold a good store of value? And notice the price of gold has 2x in the last 1 year, which is again a problematic sidetrack that we can talk through. The reason gold is a good store of value, again, is 1 years of trust that people have just seen it go up in time. People have just seen people like to hold gold, even though gold is technically a really bad asset. It doesn't grow 5%, 10% every year. But when I say grow, I mean your 10 grams of gold doesn't become 11 grams of gold. It doesn't reproduce. But that's not true for real estate. If you buy a building, you can actually get a 5%, 10%, 2% yield. So your building is actually generating some revenue for you. That is not true for gold. So if you really look at it, gold shouldn't be a great asset. Gold, real estate should be a better asset because it has some real use case. But over the years, gold has become a good store of value. People consider gold as a good store of value because across history and economics, it has several qualities that have helped its purchasing power over the years, or purchasing power sustain over the years. Some of these reasons are scarcity and limited supply. This is one of the bigger reasons. For a fact that gold is scarce, and it's a very predictable rate at which it grows. Gold banta kaise hai? It's mined from the ground, from some limited places, and you can predict it will not be mined more than 3-4% of its supply every year. So no one will become extremely rich mining a lot of gold from the ground and inflate the price of not inflate the price, whatever, cause inflation by decreasing the price of gold. ऐसा नहीं होगा कल किसी के पास बहुत ज़्यादा आ जाए. Durability, it doesn't really rust. This is probably another big reason. It doesn't decay. So if you have a gold coin from 200 years ago, it would look the same as it looked 200 years ago. Universal acceptance, again, God knows why, but in every country, people understand gold. You can buy and sell gold in every country out there. Intrinsic demand. This is probably a smaller point, very popular point probably in India because of jewelry. But I would say silver is probably used a little bit more in electronics compared to others. It has some use cases, even though I don't think the use cases justify its price. It's everything else that sort of justifies the price of gold. Inflation hedge. Again, historically, people have seen that if inflation is increasing, if currencies are going down, buying either land or gold lets you beat that inflation, or at least cover that inflation. If for some reason India today has 200% inflation, that means everything is becoming thrice as expensive tomorrow. Gold will probably also go up 3x in the next 1 year. And lastly, independence from governments. You can move across countries. Of course, it's a little hard to move gold across countries, but technically you could do it and sell the same thing in different places. It's a little more inefficient. The price that you might get here might be a little different from the price that you might get in Dubai. But at the same time, it's not like it will lose its value if you move from one country to another. All right. This leads to a very nice question, which is, if we know for a fact gold is and has been a store of value for years, why can't we create a digital version of it now that we have the internet? In the last 20 years, the internet came, we all have devices, we all have phones, we all understand how to transact online. Why do we not have something that mimics gold, has probably the properties of gold, but at the same time is digital? I mean, one good example could be, it would be nice if we can have a digital version of gold, which basically means I have, some 20 grams of gold on my phone that I can use for my day-to-day transactions. And then, whenever I want, those grams can be converted to real gold, vice versa. That might be one good, way to digitize gold. But then came another called Bitcoin, which the primary, premise initially was that this is digital gold, which basically means it is something that as long as people think is valuable, as long as people adopt as a store of value or a currency, then it follows a lot of properties that gold does. It is not a physical thing, it does not sparkle, it cannot be used in jewelry, but you can predict how quickly it will be mined. It is a digital product, so you can send someone Bitcoin from your phone and you don't need to physically carry gold. So it's sort of, as long as people understand / feel that Bitcoin is a good store of value, just like people today feel gold is a good store of value, this might become a new type of currency that is not governed by a single person, and it's very clearly written how new Bitcoin gets created. New gold, you might get lucky with some land where, a lot of gold is present and you'll be able to mine it. So it's highly unpredictable who gets to mine new gold. But in case of Bitcoin, it's very predictable who will mine new Bitcoins, how much will they mine over the years, how much can this inflate in the next 10, 20, 30, 40 years. Gold is hard and inconvenient to carry, very hard to tell the purity of gold without getting it checked from a jeweler. And markets are inefficient, which means whenever you try to sell it, if you've ever tried buying or selling, they take some 2-3% cut when you're selling, and they take some 5% making charges when you're buying. So it's like not very, but slightly more inefficient. Like 3%, 4% is too much for every transaction if you consider it to be a currency. So if it takes that much impact at buy and sell, it's probably a very inefficient thing. Compared to a digital asset, wouldn't it be nice if something digital holds the same properties as gold? When I say properties, I just mean the rate at which it is mined and how it is mined, and it's not controlled by a single entity. Where the price discovery was better than gold, by which I mean, you can buy it and sell it anywhere all around the world for almost the same price. Purity could be judged digitally, where it could be easy to create global marketplaces rather than localized gold shops. And this is where the Bitcoin white paper was introduced. You might have a bunch of questions at this point around if this makes sense, or is this a little too doomsday-ish? So happy to answer some of those before we get into slightly more computer science, core computer science topics, before we come back to how BTC or the Bitcoin blockchain works. So if you have any questions until this point, I'm all ears, and after that I am going to get into some CS specific high level topics that hopefully a bunch of you already know. Why are cryptocurrencies so volatile even Bitcoin compared to something like gold? Well, I mean, honestly, volatility in even gold seems a little too shaky right now. in silver, it's probably even worse. In the last 6 months, it's twice. So I wouldn't necessarily, it's all supply demand, right? Since it's a speculative asset, a lot of times driven by FOMO. That's why the price goes up and down very quickly. Sometimes, during COVID, it felt like currencies would just lose value, tomorrow. Balaji had a tweet that Bitcoin would go to $1 million in the next 1 month and currencies are going to die. It did not end up happening. But it is during these, I don't think the movie is called Inside Job. I think it's something else. I'll find it by the end of the class. It was, because at some time, I don't know, there's like very bad death spirals that happen both in the upward direction and downward direction. When I say death spirals, I mean 20 people, a lot of people bought a new coin and, Trump, for example, came and, there was, in a single night, it went from a few cents to $90. Some people made 100x, 1000x, purely based on FOMO. Kitni jaldi wo cheez aayi, people are buying, and then eventually, reality sets in, ke probably intrinsically doesn't have any value, so it went down. In the end, it's very hard to quantify which one of these coins has intrinsic values. There is some reason to hold Bitcoin, Ethereum, Solana. I can get to what that reason is. But other than that, it's very hard to quantify its purpose kya hai. It's very hard to quantify that for gold also. But the price is purely supply demand, and a lot of times death spirals happen in both the directions. In the other direction, what happens is if some very big whale sold a lot of Bitcoin, the price drops a lot. Let's say 5% in 20 seconds. And then what happens is a bunch of people have taken leverage positions and they all get liquidated. So they auto sell their positions, so it falls even further. And that's why you see very big volatile spikes. How can we even trust Bitcoin? Because I see the Bitcoin price fluctuating a lot compared to gold. So the thing is, when you say Bitcoin, I am buying Bitcoin. It's like very, ये कैसे समझाऊँ? आपके पास कल भी 50 Bitcoin थे, आपके पास आज भी 50 Bitcoin है. You don't, like the Bitcoin maxis would not say, oh shit, I had $20,000 worth of Bitcoin yesterday and today I have only $10,000 worth of Bitcoin. What they will say is, because they sort of believe the other currency shouldn't exist. It's very dumb to do that because they can't use Bitcoin to buy milk today. So it's a dumb argument to make कि मेरे पास तो कल भी 50 Bitcoin थे, आज भी 50 Bitcoin है. In the end, today everything is priced based on the US dollar. In India, based on another currency, INR. And hence you do need to spend on a day-to-day basis on these currencies. So there is a dumb argument to make कि the other currency is just dead, or at least in my mind is dead. And I had 50 Bitcoin yesterday, I had 50 Bitcoin today. Coming back to your question, how can we trust Bitcoin? So trust Bitcoin is very different from price of Bitcoin. As long as you understand कि यार Bitcoin का purpose ये है. मुझे तो ऐसे currency hold करनी है. मुझे लगता है currencies die कर जाएंगी. I feel INR, US dollar are going to die eventually. It has happened in a few countries. If you've seen Venezuela or Argentina, I think one of these two, there was hyperinflation. मतलब everything was getting priced 3x, 4x every day. Sorry, हर दूसरे दिन prices were doubling or something like that. When currencies lose value at that rate, Turkey में अभी कुछ हो रहा है. Turkey currency, let's see. So these things what you see in the last 5 years, Turkey price compared to INR has gone from 10 rupees. एक टर्की का लीरा लेने के लिए हमें 10 रुपए लगाने पड़ते थे. Now we only have to spend 2 rupees. What does that tell you? We can go to Turkey and live like kings compared to 5 years ago. 5 साल पहले तक, if I had to go for which I might have to, a hair transplant, I would have had to spend $10,000. Today, I only have to spend $2,000. So when this is happening in a country, probably might be safer to just hold Bitcoin. So this is what the expectation is. Not just Bitcoin, any asset, gold. But if you compare the last 5 years, it went from 26,000 to 86,000. And the other currency went down 5x compared to INR. Even worse compared to US dollars, right? So, and Turkey is like not a small country. Like you and I have heard of it. We go there for vacations. People go there for hair transplant. It's a very known country. वहाँ की currency के साथ ऐसा हो गया. So if you know for a fact it is going to, the other asset is going to outperform currencies, it makes sense to buy it, irrespective of कितना बढ़ा कितना घटा. Over the long run, the premise of these Bitcoin maxis or crypto people is कि currencies खत्म ही हो जाएंगी, इस तरीके की inflation होगी. This is the kind of inflation that will happen in various currencies. So you have to own assets. What can those assets be? Gold खरीद लो, real estate खरीद लो, gold, real estate, or this new thing called cryptocurrencies, which is basically trying to be कि यार अगले 10 साल में, 20 साल में, the next 10 to 20 years, people will transact using these new currencies and no one will believe कि US dollar is a good store of value because no one knows where US dollar is going and who is printing it, so on and so forth. थोड़ा समझ आया? there are a lot of other upsides that come with, currencies that are open and people can look at their supply and how it is being transacted from one place to another. As I said, corruption ho gaya, black money ho gaya, all those things will also come. But hopefully that answers your question. Okay, how Bitcoin actually would think about it. I totally get how you would think about it. Yesterday I bought it from, for 100K and today it's worth 90K. I've technically lost 10K. But the premise is in the next 20 years, that's true for that. That argument holds true for gold or anything else. Of course, it's not as volatile. But the premise is 20 years it wouldn't exist only currencies, and hence it makes sense. All right. I think that covers. Could not understand the inflation part. You said if I earn in US dollars, even though US dollar price increase, not good. Why? Like how rupee price is increasing in conversion to dollars. Oh, okay. I make 1,000 inflation part. You said about if you earn in US dollars, until last year you were getting 83,000. You make $1,000 a month. That's what your salary is. Until last year you made 83,000 rupees. Today you make 90,000 rupees. You got a 7,000 rupees increment in the last 1 year, even though you didn't get an official increment and your price went up. So you might feel rich. Let's say this doubled. Let's say this became 180. Your salary became 1,80,000. Your salary became 1,80,000 in 1 year purely because the price of INR to US dollar went up. Do you think that's a good thing or a bad thing? You are saying it's a good thing. I'm now receiving 1,80,000. That is only a good thing if you are receiving the money and immediately dumping it into assets or immediately buying back US dollar from it. Because if INR grows this week compared to US dollar, then everything will become twice as expensive. The land that you're purchasing, the food that you're buying, everything will become expensive and expensive because let's say India buys maize from the US or we buy petrol from some country. When we buy it in US dollars. So us maize ko India lane ka price is still $20. And now that $20 doesn't translate to 160 rupees or 1,600 rupees, it translates to 1,300 rupees. So everything will become expensive. Your net US dollar net worth will go down. If you have 2 CR net worth today and your salary went up, whatever, from 1 lakh to 2 lakh because US dollar to INR conversion doubled, Indian rupee weakened in the last 1 year, your salary went up, sure. But the bank money that you had, 2 CR, is now only worth, it's not worth 200,000 US dollars, it's now worth 100,000 US dollars. And unfortunately, US is the global currency, jiske basis pe a lot of prices are dictated. If your country's currency is growing weaker, that's why I said we can go to Turkey and now we can buy everything for very cheap. Hair transplant bahut sasta ho jayega. But that doesn't happen. Hair transplants will become more expensive. And the people from that country that were holding that specific Lyra currency will be screwed. So hopefully that answers why if your country's currency is weakening compared to US dollars and your salary is in US dollars, that doesn't necessarily mean you're now richer. That just means your net worth went down by a lot, but sure, your monthly paycheck is still pegged to the dollars. So your monthly paycheck is still stable in reality and your net worth has actually gone down. Do you understand the problem with currencies? The purpose is not to make you a cynic, but know for a fact that currencies will die eventually. And God knows when that will happen. And they're a very new concept, 50 years old. Piछle 50 साल में use dollar आया है. We have become accustomed to using it, and internet is very fast. So God knows, when a new currency becomes, and it's like already happening in countries. It's not like and to gold को इसको तो और भी lot of do you understand? Is the question yes or no? Everyone understands everything until this point. The premise of blockchains, what are they trying to solve? Currencies primarily. Now there are a lot of scammy use cases on top of them that we can talk through. But the technology was primarily built to solve for currencies and money, because the hope was that currencies are going to die eventually. People will lose trust in government issued currencies, and that usually happens when the price of gold is going up. That basically means people with a lot of money, which is technically banks, are buying a lot of gold. That's the only way price of gold can go up by so much in a year. Historically, it doesn't happen this much. I think this 2x happened like some 20-30 years ago when also there was hyperinflation. So this 2x of gold happening in a year can only happen if very big whales are losing trust in US dollar and hedging by buying gold. It's not you and I who are buying gold and the price of gold is going up because India mein jewelry bahut zyada ab. There are a lot of weddings happening in India. That's not the reason. The reason is a lot of bigger whale money is moving to gold, which is why the price of gold is going up by so much. Irrespective of what your mother says, who might be Shadi season hai, so that's why price of Diwali is there, or 100x is there. These things can't affect gold by this much, or the price of gold by this much. Moving to some computer science topics that hopefully should just be foundational. Actually, before I reach here, just to understand the crowd, how many of us already know the answers to these questions? Read through some of these questions, just to see, how many of the people are from the existing cohorts, already know a bunch of these things. Which, if you are using Bitcoin, or if you have used Ethereum or Solana, some of the questions that you might get. If you don't understand the question, or if you don't know the answer, then select no. Otherwise, select yes. A few questions are. Why would a person start a new cryptocurrency miner? Why should I start a miner today? What reward do I exactly get? How do I get the reward? How do forks get resolved? What are forks in a blockchain? Can transactions be reversed in a blockchain? If they can be reversed, what is the solution around it? Because if I pay someone 2 BTC and he gives me some gold, and then the transaction reverse, then I have my 2 BTC back. I also have his gold. That's a problem. Can a miner move money from one random address to another? I mean, of course the answer is no. But how that happens computationally, or mathematically, do you already know the answers to these questions? Are these easy questions? Have you already seen these questions before and explored their answers? Yes or no? Just to get a sense of how many of us understand blockchains already. Okay, so 85% say no, and 15% say yes. That's a 20-80 now. 21-80, that's good. 22-78, cool. I get a decent idea. I think for 22%, all of this should also be fairly easy. And all of these topics are not generally covered in full stack. You don't need a bunch of these cryptography, not cryptocurrency, but cryptography concepts. In general, full stacky stuff. But if you're a CS student, you've probably done them. So we'll kick things off with bits and bytes. All of these have nothing to do with Bitcoin or cryptocurrencies. They are CS topics that predate the creation of Bitcoin, and some things you should probably generally know irrespective of crypto. We'll kick things off with bits and bytes. Some of you might already know this. For everyone else, if you have a computer that looks like a Mac machine, the Mac machine actually has a few components in it. There is something called RAM, or random access memory. There is something called SSD, where you store your data. You might have 256 GB SSD, or 512 GB SSD, and RAM you usually have 8 GB, 16 GB. It's a little more expensive to buy RAM compared to SSD, because RAM is much faster to what RAM is and what SSDs will come to, but it's basically memory. If I'm storing a video in my computer, it gets stored over here. So if I have a 1 GB video on my machine, that 1 GB video is stored in this, some part of this 256 GB SSD. If I have a game that's 20 GB, so that 20 GB game is also stored over here. When I run that game, or when I run that video, then that video sort of gets loaded over here, some portion of it. When I'm playing a game, the visualization that I'm seeing as I'm moving aage piche, and something is happening, then some part of this game, some program of this game sort of moves to the RAM, and that is your program in execution. Jab aap program ko run karte ho, even if you run something like node index.js, or go run, or your cargo run. If you're running a Rust program, a JavaScript program, you're opening the browser, then some part of your RAM is being occupied by these programs. If some of these programs is extremely memory heavy, for example, let's say you have a program that converts video from MP4 to AVI, and the program is written a little unoptimally, such that it loads the full video in memory first yahan pe, and then converts it to a different format, then that program might not run. It might run out of memory, because that specific program might need to take this, let's say 10 GB video or 20 GB video, and load that here in RAM. But since you only have 8 GB of RAM, you'll see a out of memory error over here or something like that. So these are the high level components. Then there's the CPU, there's the GPU, so on and so forth. These are the high level components of your machine. But hopefully you understand these components are physical things, right? It's some board. If you've seen a motherboard, if you've seen a RAM, it looks like some spiky thing, which effectively only stores two states. It has, when we say 8 GB or when we say 16 GB, What we mean is that there are a lot of small switches on this RAM. And these switches can have one of two states. They can either be on or they can be off. That means this switch can either be a 1 or this switch can either be a 0. This switch can either be a 1 or it can be a 0. These physical hardware things that you put on your RAM that exist inside your MacBook are basically a bunch of small transistors, a bunch of small switches that can have one of two states, on or off, 0 or 1. When I am running a game where a lot of visualization is happening, there's a person moving in 3D, what is happening is RAM में बहुत सारा data चलना चाहिए. Where is this person standing? Let's say I start a GTA game on my Mac machine. So on my display, I'm seeing, whatever, a tree over here and then a person, slightly fat and dysmorphed person. This person might be standing at, whatever, X20, Y30, Z200 in that specific physical space. So these numbers need to be stored in this, RAM in the form of zeros and ones, because your RAM doesn't understand 20. It doesn't understand physical space when there is a tree over here. It only understands 0, 1. So you have to figure out how to store this number 2 in this RAM in the form of zeros and ones, 30 in the RAM in the form of zeros and ones, so on and so forth. This is called the binary representation of just a number for now. Even strings ho gayi, booleans ho gaye, whatever data types you might have seen in JavaScript, Golang, Java, Rust, are all eventually converted to what's called a binary format. Why binary? 0, 1. There are only two states it can have. And let's start off with numbers, but even strings, even the trees over here are basically a bunch of points, right? A 3D tree is nothing but a bunch of points and how they're connected. It's a bunch of triangles. If you connect a bunch of triangles, you can see a 3-dimensional tree, right? All of these are just numbers or strings or, things that you and I can read. For example, my name is Harkirat Singh, a string like this, need to be converted into zeros and ones. How they get converted is based on, certain what are called encodings. I repeat, certain encodings. आप encode कर रहे हो 20 को in form of some zeros and ones, 30 को in the form of some zeros and ones. My name is Harkirat ko in the form of some zeros and ones. This conversion we need to understand. Okay, what are these various encoding formats? How can you encode a number to a binary to a number, a string to a binary back to a string? That's what we need to understand in this section. Why? Because eventually when we do cryptography or cryptocurrencies, we will need a bunch of these, converting strings to bytes or numbers to bytes, bytes to numbers, so on and so forth, especially when we are writing smart contracts or dealing with public and private keys. तो हमें ये थोड़ा सा समझना पड़ेगा कि how encodings work and how data is actually stored in your RAM, because how it is stored in your RAM is how it is stored in various miners also all around the world. When I say miner, I mean a Bitcoin miner किसी ने अगर चालू कर रखा है. That's how you send data to them through bytes and bits, and they sort of respond, let's say, in also bytes and bits. So what do we need to understand? To kick things off, we need to understand what are bits and bytes. Then we'll understand how data is encoded to bits and how bits are converted back to data. What is a bit? A bit is the smallest unit of data in a computer that can have one of two values, 0 or 1. Think of it like a light switch that can either go on or go off. Any data on your machine, any MP4 file that's stored on the SSD is stored in the form of binary or zeros and ones. What is a byte? A byte is a group of 8 bits. 8 bits को एक साथ लोगे, उसको एक byte बुलाया जाता है. Why 8? Just a random number some person chose, and today that is why we have 256 GB and not 300 GB RAM. Because unfortunately we deal in terms of bytes, and bytes are a multiple of 2 and not a multiple of 10. It would have been nice if it would have been a multiple of 10. If a byte was a multiple of 10, it isn't. 8 bits equal to 1 byte, and hence we have 256 GB, 512 GB, and not round numbers like 500, 250, so on and so forth. A byte is a group of 8 bits. It's a standard unit of data used to represent a single character in memory. It is the standard unit of data used to represent a single character in memory. A, B, C, D. If you want to store A, the character, finally in memory, can you store it in a single bit? A bit can only have two states, 0 or 1. If you want to store a boolean in memory, it can be either 0 or 1. It can be stored in a bit. If you want to store a boolean in memory, something that can only have a state of true or false, then yes, you can say if this specific switch is off, that means it is false. If it is on, then it is true, something like this. But can you store a character A, B, C, something like this in 1 bit? Unfortunately not. And the standard encodings that exist, ASCII, UTF-8, store it in 1 byte, 3 bytes, 4 bytes. We'll come to what that is, but that's the general idea behind the conversion between bits and bytes. You can store data in 1 bit. You can only store either 0 or 1. But if you have a byte, that means if you have 4, 5, 6, 7, 8. If you have 8 bits, you can actually store a lot more data in it. How, we will see very soon. We first need to understand binary conversion before we understand how much data you can store in a byte. But what is a byte? So it's a combination of 8 bits. Okay. First conversion that we need to understand is the conversion of numbers to decimal. I hope some of you already know this, but if you take any number, let's say 100, it can be converted into a bunch of zeros and ones, and the way it is done is slightly more mathematical, but hopefully very digestible. So let's start with a few examples. If I want to store 0 in binary, its binary representation is actually 0. If I want to store 1 in binary, its binary representation is 1. If I want to store 2 in memory, its binary representation is 1, 0. If I want to store 3 in memory, its binary representation is 1, 1. Can you guess what the binary representation of 4 would be? It's 1, 0, 0. Of 5 would be, it's 1, 0, 1. Of 6 would be, it's 1, 1, 0. From pattern matching, you can probably understand what is happening, how I went from 0 to 1, 1 to 2, 2 to 3. But mathematically also, the binary representation basically is, okay, take the last bit over here, 0, multiply it by 2 to the power 0. Plus take the second last bit over here, 1, and multiply it by 2 to the power 1. And take the third last bit over here, 1, and multiply it by 2 to the power 2. 0 into 2 to the power 0, 1 into 2 to the power 1, 1 into 2 to the power 2 is equal to 6. That is how you convert decimal to binary, binary to decimal. How do you convert a number from decimal to binary? By somehow, reaching this formula. Now there are ways how you can reach this formula. Very laggy video. Very laggy video, guys. We take a small pause. Now it's okay, someone said. We wait for a bit. 1 minute breather. Hello, hello. Mic testing. Mic testing. Are we good now? Yes or no? Alrighty. I will proceed. Mikey, call me again if it becomes problematic. What I was saying was, to convert a number to binary, there is a formula. Like hopefully some of you have, this is a common lead code question that you will find, which is given a number where a equal to whatever, something like this. How do you convert it to binary? The way it is done is slightly mathematical. You take the number, let's say the number is 301, you modulo it with the 2, and whatever you get is the last bit, which is 1. Then you divide the number by 2 and then take its floor, so it becomes 150. Then you take a modulo with 2 again, and that's 0. So that's going to be the pre-final bit, and then you divide it by 2 again, so that's 75. You take a modulo with the 2, and that becomes 1, so that's going to be the third last bit. Then you divide it by 2, that becomes 37. You modulo it by 2, it's again 1, so the fourth bit is going to be 1, so on and so forth. There's a very standard, if you think of it a little, you'll understand. Hopefully converting binary to number is easy. Take the last bit, multiplied by 2 to the power 0. Take the second last bit, multiply it by 2 to the power 1. Take the third last bit, multiply it by 2 to the power 2. Take the fourth last bit 0, multiply it by 2 to the power 3. Take this bit, multiply it by 2 to the power 4. That's how you convert a given binary number to decimal. Decimal to binary कैसे होता है? You take a modulo with 2, that's the last bit. You divide it by 2. Take the floor. For example, dividing 301 by 2 is going to be 155.5. You take its floor, that's 150. You again take a remainder with 2, it's 0. That's the second last bit, so on and so forth. That's how you convert every decimal number to binary, binary number to decimal. So if it's just numbers we are dealing with, if every program out there was just numbers, then this is how you would, store data finally in your RAM in the form of zeros and ones. You'd probably decide a specific size कि यार हमारे केस में numbers can only be as big as 2 raised to the power 32. If you've ever solved C++ में DSA problems, you might know the concept of long. You might know कि ints are 32 bit and longs are 64 bits. So if you've done comparative programming, then probably you've dealt with longs. And generally when you store numbers, they're either stored in the form of 32 bits or in the form of 64 bits. 32 bits is, basically means you can store a number from minus 10 to the power 9 to somewhere around, 10 to the power 9. And 64 bits means you can store a number somewhere around minus 10 to the power 18 to plus 10 to the power 18. That's a high level. Maybe there are, some nuances on how numbers are stored, how negative numbers are stored. The last bit in a 32-bit number, the last bit represents, if it's 0, it means it's a positive number. If it's 1, it means it's a negative number or something like that. So if you've ever, क्या होता है C++? There are two ways you can create ints, and one int is only positive. I forgot what it is called in C++. Someone can refresh my memory. All competitive programming people already know this. But there is a way to only create positive numbers in C++. What is it called? Signed numbers. Yeah, signed and unsigned numbers. So if you want to store a lot of positive numbers in C++, then you write some unsigned int a. Now this can be much longer because now you're only storing positive numbers. So all the bytes that you have 32 bits. All 32 bits can now store more about the number. The last bit can also store 0 or 1. Versus if it is a signed integer, then the last bit stores whether it's a negative number or the positive number, and everything else stores the normal binary representation. इसमें भी ऐसा होता है कि what does 1 0 0 0 0 0 and 0 0 0 0 0 mean? A negative 0 and a positive 0 are the same thing, right? So that is why negative side पे एक extra हो जाता है, वो minus 1 बन जाता है, positive side पे plus 1 बन जाता है. One of these two happens, and that is why if you have an unsigned int, that's like a normal int in C++, it can go from minus some number x minus 1 up to x. So negative side पे एक number कम होता है या whatever, plus 1, because you take one of these two numbers as the last number over here. तो negative में आप थोड़ा ज़्यादा store कर सकते हो या positive में आप थोड़ा ज़्यादा store कर सकते हो. But generally numbers कितने bits के होते हैं? In most languages they are 32 bits. Generally when you are storing a number over here, you are taking 32 of these bits or 4 bytes and storing a number, irrespective of if it's a very small number. For example, 20 is a very small number. 20 की binary representation would be something like this, 11000, I think. But it's stored like this in 32 bits with a lot of zeros and then 11000. Same is true for 300, 400, 500. When you're storing integers, most languages take 32 bits and then store an integer. If you use long in C++, then you take 64 bits and store an integer. Hopefully that tells you how numbers are stored in the form of bits and bytes in computers. Let's do a poll. Do we understand bits and bytes and how numbers are stored in the machine eventually in the in your RAM, in your SSD? And how do you convert a decimal to binary, binary to decimal? There are a bunch of converters that you can use. Decimal to binary converter. You can just go over here and try to convert a decimal number to binary, binary to decimal. If you don't want to do the math, or there's a lead code question, you can code it yourself. Seems like most people understand. But if you do want, select a number, and this is the binary representation of this number. And then if I take a much smaller number, 33, then this is the binary representation of 33, and this is how it's written. Okay, 33 with to the base 10, which is like a decimal representation, is equivalent to 100001 in the second base, or as a binary representation. Next question: How do you store strings? If I want to write something like my name is Harkirat, how is this stored in the form of binary? And what is the binary representation of M, for example? What is the binary representation of Y? What is the binary representation of space? So on and so forth. So here come the concept of various types of encodings. There are not just English characters. Agar sirf English characters hote, if all we had to store was A to Z, and then A to capital Z, let's say, and some special characters like this, let me see, some special characters, and then of course numbers from 1 to 0 to 9. In the end यही store करना होता. Then we could have said something like this कि यार अगर string store हो रही है तो the binary representation of A is going to be 0, B is going to be 1, C is going to be 2, D is going to be 3, E is going to be 4. करते करते capital A is going to be 27, capital B is going to be 28. करते करते 0 is going to be whatever 54, and then 1 is going to be 55, and then करते करते question mark is going to be some 64, 65, so on and so forth. We can write our own language representation कह लो कि यार A's binary representation is going to be this, B's binary representation is going to be this. You might ask, Harkirat, how do we know कि ये number है या फिर string है फिर? How do I know if something that is stored in RAM over here, if it is a number or if it is a string? So what happens is, in actuality, in memory, the type is also stored somewhere here. Here the next thing is going to be a number or a string or whatever. A boolean to nahi, but you get the idea. The type is also stored in a bit, or let's say 2 bits or 4 bits, and then the actual thing is stored right after. Whenever you're encoding and decoding, serializing and deserializing to bytes, based on your हमारा तरीका ये है, मान लो कि I have written my own language compiler कि यार मेरी language में तो एक ही representation ये है. I have written my own encoding. I'm going to call it Harkirat encoding. मेरी language में the only alphabets that are supported are A to Z, capital A to capital Z, 0 to 9, and some special characters. So in my language, this is how I'm going to encode 0, A, B, C, D, and then this is how I'm going to encode 1, 0, 2, 3, 4, 5, 6, 7, like that. But of course, there are standards that already exist for characters. Ki how should H be represented in binary? How should A be represented in binary? You might have already heard of ASCII or UTF-8. There are 2 ways you can encode strings, but there are actually many encodings that exist. इनको क्या बुलाया जाता है? These are called encodings. This is Harkirat encoding. In my encoding, A represents the 0th byte, B represents the 1th byte, so on and so forth. But in more standard encodings like UTF-8 or ASCII, A represents something, B represents something. So let's look at some of these encodings. Bytes are cool but highly unreadable. Imagine telling someone my name is 0011010, something like that. It's easier to encode data so that it becomes more human readable. Some common encodings include ASCII, hex, base 64 and base 58. Even UTF-8 is a popular one. ASCII, hex, base 64, base 58 and UTF-8. Let's understand all of these. Let's start off with ASCII. ये सबसे कॉमन वाली है जो आपको और मेरे को समझ आती है. Whenever you are writing English, if I open my network tab over here and if I write where A equal to Harkirat, then the encoding in which it is stored is ASCII. तो इसमें कुछ होता है A.to char to string, I forgot. There is like a function you can call to see कि ये एक्चुअल में बाइनरी में कैसे रिप्रेजेंटेड है. टू सी व्हाट इज द H की बाइनरी रिप्रेजेंटेशन क्या है, B की बाइनरी रिप्रेजेंटेशन क्या है, व्हाट इज दैट नंबर दैट ट्रांसलेट्स टू दिस. ये थोड़ा कंफ्यूजिंग हुआ होगा, माय बैड. व्हाट आई मेंट हियर वाज दिस 01 11 100 101 110 so on and so forth. In my Harkirat encoding, A will be represented as 0, B will be represented as 1, C will be represented as 01, D will be represented as 11, E will be represented as 110, so on and so forth. In ASCII, one character is 7 bits. तो ASCII वालों ने कह दिया कि यार हम ASCII वाले हैं, we support a few characters, for example A to Z, capital A to capital Z, and bunch of these special characters, and then every number from 0 to 9. a bunch of other extra, characters, and each one of our characters will hold up 7 bits. Will take 7 bits. So 4, 5, 6, 7. So 0, 0, 0, 0, 0, 0, 0 would represent something. Let's say, it represents A. Let's say. And then 0, 0, 0, 0, 0, 0, 1 would represent something, so on and so forth. In actuality, it looks something like this. In ASCII, exclamation is 33, whatever the binary representation of 33 is. Double quotes is 34, hashtag is 35, 0 is 48, 1 is 49, capital A is 65, capital B is 66, small a is 97, small b is 98, so on and so forth. So what would the binary representation of small b be in ASCII? B की होगी whatever is the binary representation of 98, which is 98 की क्या होगी? Again we can use the formula. It will be something like end में 0 होगा, उससे पहले 1949 1 होगा, उससे पहले 24 0 होगा, उससे पहले 12 0 होगा, उससे पहले 6 0 होगा, उससे पहले 3 1 होगा, उससे पहले 1, something like this. I think this might be right. तो 1 2 3 4 5 6 7. This might actually be wrong also, I don't know. But just convert 98 to binary. That is the binary representation of an ASCII B character. आपको जिंदगी में कभी भी कुछ बाइट्स मिली, राइट? Whenever you are talking to a machine via HTTP also, whenever you are transferring your data, a text message also on the other side, your friend go you send hi there, you're actually sending them a bunch of bytes only. You're sending them a bunch of zeros and 1. And then eventually Facebook का messenger interface understands कि यार I need to convert these zeros and ones back to ASCII, and that is why your friend sees hi there. What you send to your friend looks something like this. What you send to your friend when you say hi there, what leaves your machine and goes through a bunch of wires and gets read by the other machine's CPU and put in RAM is something like this. ASCII is the most popular, encoding in which websites are written, which is why it gets decoded to something like hi there. But if you don't use ASCII, if you use something like hex, then it might get, decoded to something like this. Of course, us humans understand alphabets, we understand the English language, which is why ASCII is the popular, medium in which these bytes are decoded back to. Hopefully, ASCII is clear. Here is some Node.js code to convert binary to ASCII. If you don't understand coding JavaScript right now, I'm not going to go too deep into this. But if you do understand coding, I think most of you know JavaScript. I've written a function, bytes to ASCII. It takes a byte array as an input, and it just calls from char character on that byte, from char code on that byte, and dot join will just convert the array to a string. By the end, these bytes will get converted to something like hello, because this is the binary representation of hello in ASCII. In UTF-8, it might be something else. In hex, it might be something else. In ASCII, if you take these bytes and decode them to ASCII, it represents hello, which you and I can understand, you and I can read. It's unfortunately very hard for us to read this. We cannot tell ये hello लिखा है unless we go to the ASCII table and start to match. कि यार 72 किसका था? अच्छा 72 was uppercase H. ठीक है, तो the first one over here represents H. 101 किसका था? I go over here and try to see. 101 is okay, it's E. So I can do this one by one करके match, or I can write a program for it that will take these bytes, convert them to hello, and output hello on the screen. You can use convert bytes to ASCII. You can convert ASCII to bytes as well. If you have a string called hello, you can call this function which calls ASCII string dot char code at I. ये थोड़ा गलत क्यों लग रहा है मुझे? At I. Oh हाँ, नहीं, this is fine. ASCII string dot char code at I would return for this thing 72, for this thing 101, so on and so forth. And then finally you create an array out of it and return it. If you log it, you will see hello key binary representation in ASCII is this. This when converted to ASCII in human readable string format converts to hello. तो ये सबको समझ आ गया ASCII encoding. There's also something extra called uint8 arrays in JavaScript. Let's not go there, but something sort of important to deal with eventually, and how bytes are actually stored in JavaScript, or bytes should be stored in JavaScript. But before we get there, do we understand ASCII? Let me relaunch the poll. Okay, most people understand. I'm going to speed this up then. ASCII is one way you can store bytes or showcase bytes to users, makes sense for human readable messages, but there are other encodings as well. For example, hex. In case of hex, if you are given a bunch of bytes, you take them in chunks of 4. So the first 4 bytes can either represent 0 or represent a number as big as 15. If you take 4 bytes, so the smallest number that 4 bytes can represent in binary is 0, 0, 0, 0. If you do the math, this is 0. The second biggest number they can represent is 0, 0, 0, 1, which is 1. And the biggest number they can represent is 1, 1, 1, 1, which is 15. So the binary, the hex representation says, here if the first 4 bytes are 0, then in hex they will also be 0. In case of ASCII, there was something else. In case of ASCII, 93 was not 93, it was backslash. 91 was not 91, it was ye. But in case of hex, if you take 4 bytes and they become decimal 0, they remain 0. If they become decimal 1, they remain 1. If it is a decimal 9 number, then it appears as 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 appear as such. If it's 12 in if it's 10 in decimal, then it appears as, I think some of you might already know this, A. If it is 11, then it appears as B. If it is 12, then it appears as C. If it is 13, then D. 14, then E. And 15, which is the maximum it can be, then F. So the character set for hex is 0 to 9 and A, B, C, D, E, F. That's it. अगर आप एक बाइट एरे को, if you're converting a bit array or byte array to hexadecimal or hex, then the final output can look something like this. It cannot have Z in it. It cannot have Y in it. It will not have P in it. It will only have either 0 to 9 or A to F. That is just the hexadecimal encoding. हरकीरत फायदा क्या है इसका? What is the point of this? When it is not human readable, there are many encodings that exist based on, whatever 4 bits को ले रहे हैं या 8 bits को ले रहे हैं या फिर 3 bytes को ले रहे हैं, which could translate to multiple characters. If you want to, whatever, compress तो नहीं हो रहा data in this case, but an encoding that only takes 4 bytes at a time, hexadecimal is a popular one. And in case of hexadecimal, unfortunately, the final output will always be non-human readable. It will always look something like this. 0, it might have some numbers, it might have A, B, D, F, E. It will not have anything else. It will never have O, it will never have P, so on and so forth. That's hexadecimal. So we have covered ASCII, we have covered hexadecimal. There are more. There is UTF-8, there is base 64, there is base 58. एक बार जल्दी से इनको भी देख लेते हैं, but there are just various encodings. Some of these encodings we will see as we create private keys, public keys, so on and so forth. The next one is base 64. It's very close to hexadecimal. In case of hexadecimal, you take 4 bits at a time. In case of base 64, you take 6 bits at a time. So what is the सबसे छोटा number that will exist? 0. What is the biggest number that can exist if you have 6 bits? It is 64. So it of course has 64 characters. Hexadecimal, I'm sure there is a link somewhere here. Sorry, base 64. Let's try to encode, something. This is ASCII to, let's not confuse you guys. I just want to see a base 64 table. In case of base 64, 0th binary, or 6 zeros represent a 5 zeros and 1 represents a B. And then chalte jao to, whatever. This 41 represents a P. And then, whatever. Karte, you will see more numbers. 59 represents a 7. 60, it basically is, all big characters, all small characters, 0 se 1, plus and slash. What does it contain? It contains all uppercase characters, all lowercase characters, all numbers from 0 to 9 plus and slash. That is the maximum final output subset that you will see. If you are converting to base 64, it will take 6 bits at a time. It will take, just in case of hexadecimal, it took the first 4 and spit out 5, took the next 4, spit out 9. In case of base 64, it will take the first 6 and spit out whatever, A, let's say. Take the next 6 and then spit B, so on and so forth. That is what hexadecimal is, and this is the character set that it supports. There is something else called base 58, which is, it still takes, I don't know how many bits it takes, probably still takes 6 bits. It is similar to base 64, but uses a different set of characters to avoid visually similar characters and to make encoding more user friendly. तो इसने क्या कहा कि यार मैं सिर्फ 0 से लेके 57 तक ही सपोर्ट करता हूँ. I don't support 111, I don't support 111, 110. I don't support 63, 62, 61. Base 58 is the same as base 64 minus some characters that look visually similar. For example, L and I look very similar. Uppercase I, lowercase l look very similar. Uppercase O and 0 look very similar. तो उसने ये characters को निकाल दिया. It removed a few similarly looking characters, and whatever is left is what base 58 encoding sort of means. इसके बाद एक और आता है UTF-8, which is 1 to 4 bytes. So it's basically 8 to 32 bits, which means it can store a lot of data. So in case of this, there are characters like these, characters like these. If you are ever writing in Latin or if you're writing in Spanish, if you're using characters like these, then they are encoded not in ASCII but in UTF-8, because UTF-8 supports very big character set compared to ASCII, which only supports whatever, some more limited 127 numbers. This or characters. This supports a lot of characters. 32 bits is 2 to the power 32, 10 is per 9. मतलब बहुत सारे characters को ये support कर सकता है. This only supports 127 characters. So small a to z, capital A to z, numbers, a bunch of special characters, so on and so forth. ये सारी encodings होती हैं. This is how data is stored / encoded / decoded from bytes. The one that you and I want to store strings in is either UTF-8 or ASCII. We use either ASCII or UTF-8 to store our human readable strings in the RAM, in memory, so on and so forth. Do we understand encodings and various types of encodings we have covered? Solana specifically uses base 58 for encoding / showing public keys. If I open my Phantom or whatever Soulflare over here and copy my public key from here, let's say, whatever I copied, and if I whatever paste it, some portion of it over here, this is a base 58 public key. The public key that I copied from my Soulflare wallet, the public key that I have on Solana where I'm holding some funds, is actually a bunch of bytes, but the way it is represented / shared amongst you and I, if I'm sending a friend some funds, I will ask for their base 58 public key. That's just the standard in Solana, which is why we're learning about these encodings. All right. 3 more topics before we get into the interesting things. Let's finish them off really quickly. They're very simple. Hashing and encryption. Hashing, thoda cryptography specific concepts. Hopefully we understand bits and bytes and encodings until this point. We started off with why cryptocurrency was introduced, फायदा है नहीं है, should it be used, should it not be used, some discussions around gold, some more computer science specific concepts like bits and bytes and encodings. Next we're understanding hashing and encryption, which is again cryptography specific concepts. Hashing is the process of converting data like a file, a message, some numbers, some text into a fixed size string of characters which typically appears random. If I hash a message hello using some hashing algorithm, the final thing that gets spit out is a bunch of random looking characters of fixed size. Could be 127 bits, could be 256 bits, could be 8 bytes, could be 32 bytes, but a fixed size output given an input like hello. इसका फायदा क्या होता है हरकीरत? Where is it used? It's used various places. It's used in if you've ever tried password hashing, it's a common thing you might have heard in full stack. If you've done full stack development, if you've ever stored users' passwords in databases, you typically hash them before storing them in a database. If you ever go to a website and click on reset password, and if they are emailing you your password, that means that website is not following standard security practices. Generally, when you put a username password on a website, click on submit and sign up, their database doesn't store your password in plain text, it stores a hash of the password. Why? How does it eventually sign you in? Are different full stack questions we'll get to in the full stack cohort, but that is one place where you use hashing algorithms. Here are some common hashing algorithms. MD5 a little more weaker, 𝗟𝗶256 a little more, resistant to attacks. Why? There are some differences over here, you can look at them, but mostly use 𝗟𝗶56 today for hashing. Hashing follows some properties that should have been written over here but aren't. But hashing is irreversible, by which I mean, given a hash, you can't ever get back the original key without brute forcing. The only thing you can do is you can start to brute force every string over here. You will brute force A, B, C, D, E, F, G, H. You will find its outputs. You will compare it with this. You will keep brute forcing until you reach HELLP and then HELLO. And then you hash HELLO and then you compare the final outputs. There is no way to go from here to here without brute forcing the input. That is one of the properties that hashing has. The other property is कि आप इसको थोड़ा सा बदल दो अगर. If you go from HELLO to HELLP, the final output looks drastically different. In fact, we can go to a 𝗟256 hash online, and you can try to see कि hello when converted via 𝗟256, this is the output. HELLP, the output is significantly different. HELLL, the output is significantly different. The output changes drastically even if the input changes a little bit. The probability of collision is extremely low. What is a collision? Finding two words like hello and then Harkirat. Finding two words जिनका output same होगा, the probability is lower. It's not zero. It cannot be zero. This is fixed size, right? ये maximum 32 bits है या whatever, 128 bits है या 256 bits है. If the final output is 256 bits, if you try more than 2 raised to the power 256 strings, of course 2 of them will match. Output limited है. If I keep trying infinite number of strings, of course I will find 2 which have the same hash, but it's computationally infeasible to find 2. दो ऐसी ढूंढना बहुत मुश्किल, next to impossible है जिनका hash same होगा. That's another property of hashing algorithms. Encryption is something slightly different from hashing. Encryption is the process of converting plain text data into unreadable format. Hashing is very similar. Plain text data into unreadable format. Called ciphertext using a specific algorithm and a key. So what is one difference between hashing and encryption? इस तो नाम ही बता रहे हैं. Encryption can be decrypted. Hashing is one way, cannot be decrypted. That's the difference. कि when you do encryption, you can encrypt it using a secret, a private key, and as long as you have that private key, that secret, you can also decrypt it. The data can then be decrypted to its original format using the appropriate key. It is reversible. Hashing was not reversible. The security of encryption relies on the secrecy of the key. अब आपकी key अगर 1 to 3 random है, then of course someone will be able to decrypt it. But if your key is very solid, then people will not be able to find the input given the output. And it is of two types. Encryption is of two types: symmetric encryption and asymmetric encryption. We'll deal more with asymmetric encryption, but let's understand the two types. What is symmetric encryption? If you given some text, if you use a key to encrypt it and use the same key to decrypt it, it's called symmetric encryption. It means the encoding and the decoding process, the encryption and the decryption process used the same key. What is asymmetric encryption? If during encryption you use a different key, sometimes the private key, sometimes the public key, and during decryption you use the other key. During encryption you use the private key, during decryption you use the public key. So you will have two keys to maintain in case you are using asymmetric encryption. If you're using symmetric encryption, then एक ही key से encryption, एक ही key से decryption. Again, many algorithms exist for this. There is some code over here. Let's look at what this code is. There's a lot of code over here. But there are two functions, encrypt and decrypt. If you call hello world with the encrypt function, it will return you some ciphertext. If you call the decrypt function, this one right here, with the ciphertext, you will get back the original decrypted text. You can print all of them and see कि हाँ सब सही है. So Encryption, decryption is different from hashing. Hashing is a one-way function. Encryption, decryption are two ways. We will dive deeper into / deal more with asymmetric encryption. This is how crypto is sort of owned by people. आप और मैं क्रिप्टो कैसे ओन करते हैं? यूजिंग पब्लिक प्राइवेट कीज. यू माइट हैव हर्ड ऑफ देम, माइट नॉट हैव हर्ड ऑफ देम. वील सी देम वेरी सून. बट इफ यू डू वांट टू होल्ड क्रिप्टो टुडे, अगर आपको आज कुछ क्रिप्टो करेंसी होल्ड करनी है, देन यू माइट बाय इट ऑन WazirX और CoinDCX. दैट्स अ सेपरेट थिंग. बट इफ यू ट्रूली वांट टू होल्ड सम क्रिप्टो करेंसी, अगर आपको एक्चुअल में क्रिप्टो करेंसी होल्ड करनी है एंड यू डोंट वांट इट डेलीगेटेड टू WazirX, यू डोंट वांट इट डेलीगेटेड टू CoinDCX, तब यू हैव टू योरसेल्फ होल्ड पब्लिक एंड प्राइवेट कीज. आपको खुद को एक पब्लिक की बनानी होगी जो आप दुनिया के साथ शेयर कर सकते हो, दैट यू कैन शेयर विद द वर्ल्ड, वेयर पीपल कैन सेंड यू फंड्स. एंड यू विल हैव टू क्रिएट अ प्राइवेट की दैट ओनली यू शुड कीप विद योर सेल्फ, दैट यू विल यूज टू not exactly encrypt messages but sign messages, so that people know कि हाँ ये आपने मैसेज भेजा है. One thing is encryption, जो अभी हमने देखी कि you can use something to encrypt a message and decrypt it. The other thing is signing messages और digital signatures. क्या क्या पढ़ा हमने? We learnt about bits and bytes. We learnt about encodings. बहुत सारी देखी, hex देखी, ASCII देखी. नेक्स्ट वी सॉ हैशिंग, ज़्यादा काम की नहीं है हमारे. वी सॉ इंक्रिप्शन विच इज ऑफ टू टाइप्स, सिमेट्रिक, asymmetric. And we saw encryption is used to encrypt using a private key, decrypt using a public key. That is one thing. The second thing is encryption can be used to sign messages. What does signing messages mean? Basically, it's very close to signing a check. If I have a check today and I sign on it, someone, a bank can verify ये हरकीरत के ही signature है. Similarly, if I have a public-private key pair, if I have a public key that looks something like this and a private key that looks something like this, let me just call it, pub key and private key. I can actually sign messages like this. Send one soul to a different public key. Let's say मेरे दोस्त की public key, pub key 2. I can sign this message using a private key. Basically means running some function, some not exactly encryption algorithm, even though the final output will be very random and the final signature will look something like this. It will not be plain text like this. But technically, I am not encrypting, I am digitally signing using my private key. And anyone all around the world can verify कि हाँ भाई, verify using my public key. Anyone around the world can verify using my public key कि हाँ ये मैसेज तो हरकीरत की प्राइवेट की से ही साइन हुआ है. That means this message was actually signed by हरकीरत. I will repeat myself. If I open my wallet over here, Soulflare wallet, it has some $9,000 in it. If I copy its public key and show it to everyone, you guys can have access to my public key. Let's say it looks something like this: 8K8XZ, some base 58 encoded string. It's private key only I have. If I open Soulflare, click on send, put like one soul and put my friends, whatever public key over here and click on send. When I click on send, what happens is a message like this gets signed by my private key. मेरी private key इस wallet में exist करती है. Somewhere here inside there is this private key. So when I click on send, this message is signed using my private key, जो मैं आपको नहीं दिखा रहा हूँ. Public key I have shown, private key I am not showing. When I click on send, this digitally signed message and my public key get forwarded to some Solana miner who verifies using my public key कि हाँ indeed हरकीरत ने ही send दबाया है, हरकीरत ने ही ये मैसेज भेजा है, and hence we can actually deduct हरकीरत's one soul and increase the one soul amount on this other public key. So where does digital signing / asymmetric cryptography / public and private keys come into the picture? कि today if you want to receive some cryptocurrency, some Solana, some BTC from someone, you will first create a public private key pair. You will using some famous algorithm, create a public-private key pair. Solana has one, algorithm. It follows EDDSA, ECDSA. We'll come to what the name of the algorithm is and how it creates public and private keys. But Solana has a specific algorithm. Ethereum has a specific algorithm. BTC has a specific algorithm that you can use to create a public and a private key. उसके बाद वो public key अपने दोस्त को दे दो. He can send you Solana. And if you want to send someone Solana, then you will sign the message using a private key. Give it to the blockchain. The blockchain knows कि अच्छा इसी बंदे ने भेजी है तो इसका बैलेंस मैं कम कर देता हूँ. And let me increase the balance of the other guy because it is digitally signed. That is the purpose/usage of asymmetric encryption in blockchains. In blockchains, you सबसे पहले create a public and a private key. It will be empty. It will not have any BTC in it. You will randomly generate a public-private key. Anyone around the world can randomly generate public-private keys. There is almost never a collision because there's like not infinitely many, but 2 raised to the power 256 possible outcomes. So very low probability if you randomly generate a public-private key pair and I generate a public-private key pair. I call it a key pair because it creates a public key and a private key. Very low probability we get the same one. So if I generate one randomly, I will most probably have won't have any Solana in it, won't have any BTC in it. I can give that public key to a friend. He can send me some BTC. Now the full blockchain feels like I have one BTC. And if I want to send it to someone, I will sign that message. Okay, I want to send this much BTC to this other address using my private key. I will take this signature, forward it to the blockchain. The blockchain will not exactly decrypt but verify my signature and confirm कि हाँ हरकीरत की private key ने इसको sign किया है. That means Harkirat has approved this message he wants to send one soul to the other guy. What are these common encryption algorithms / how public-private key pairs are generated? RSA is one. It is not used in cryptocurrencies or Bitcoin, Ethereum, Solana, but is popularly used other places like digital signing for certificates. If you look at these SSL certificates or general cryptography, if you're doing any of these CTF challenges, you will see RSA as one encryption decryption algorithm come. For BTC and ETH, they use one called ECDSA. For Solana, it uses one called EDDSA. ECDSA, EDDSA. Elliptic curve digital signature algorithm is the algorithm you will use, which basically translates to अगर आपको public private key बनानी है तो you will import ECDSA from @ECDSA/library and then you will call ECDSA.generate to generate a public private key pair, which under the hood of course has the logic that whatever this paper describes as the way to generate public and private key. For Solana, they use something else a little more optimal, EDDSA. The way these generate public and private keys is using something called elliptic curves. Here is a video by Computer File that dives a little bit deeper into this in case you want to understand how elliptic curves work and how a public-private key is actually generated. Specifically, Ethereum uses this one, I always forget how to pronounce it, and Sol use ED25519 as the elliptic curve, which basically means it's a curve like this, and whenever you generate a public-private key, some point on that curve, which is a curve can technically effectively have infinite number of points. So whenever you generate a random public-private key, आप उस curve पे कहीं lie करते हो, and that translates to a public and a private key for you, and that is why the probability of two people having the same public-private key, if they generate it randomly, is very low. Because अगर एक curve है जिसपे infinite points हैं, if you take two random points on it, very low probability you and I both lie on the same point. To recap, whenever you want to eventually buy BTC or receive BTC from a friend, you will have to generate a public private key pair. In case you want to get BTC from a friend, you will use this encryption algorithm. If you want to get Solana from a friend, you will use this encryption algorithm. Generally you will not write code, you will open a wallet like this and generate a wallet. So मैंने भी मान लो यही किया, I went to Soulflare, added this, clicked on the generate button, it generated a public private key pair for me that exists here locally in this wallet of mine. And I told a friend to send me $9,000. He sent me $9,000. If I want to ever send money to other people, when I click on send, when I select that amount and that address, when I click on send over here, I'm actually signing a transaction and sending it to the blockchain. So the blockchain can indeed verify Harkirat, who owns the private key of this, has sent this message. There are a few other use cases of public key cryptography. Whenever you SSH into a machine, whenever you've tried to push GitHub via SSH, if you've tried to push to GitHub via, whatever, there are, two URLs that you might have seen over here, an HTTPS URL and an SSH URL. If you use an SSH URL, you might have created a key pair on your machine. If I open my terminal, you can always run this command called ssh-keygem. And when you run this command, it generates a public private key pair on the ED25519 curve. कौन सा curve था ये? Solana वाला. So if you want to generate a Solana public private key pair, you can actually use this command also. This will dump a public key and a private key in your machine at this folder. So if you look at my .ssh folder, notice there is an idrsa.pub, idrsa. These are the public private key pairs that I generated years ago, back when I was in college, using the RSA algorithm. Today, generally, you generate public private key pairs using ED25519. It's a little more secure. Okay. Why am I still using my old college key? Because my private key, my public key has been in GitHub for years. So if I want to ever push that public key already exists on GitHub on my AWS, so if I do change it using this fancy algorithm, then I will unfortunately have to just 1 second. I will have to change it in GitHub and AWS everywhere. I will take a 1 second break. Someone's knocking on my door. Apologies. What was I saying? Public private key pairs. You can generate one yourself. This is the curve that Solana uses, and this is the default one that comes in this ssh-keygem command now. Back in 2015, when I was in college, the default public key private key that I generated using RSA, which was this very first algorithm over here. Let's do a poll. Do we understand asymmetric encryption? Because actually one more thing before we do a poll, which is, let's look at the various ways of creating public private key pairs, signing messages and verifying them. Number 1, create a public private key pair. Number 2, define a message to sign. Number 3, convert them and blah, blah, blah. Ignore this slide. This is more of when we code is when we will see the slide. Ignore the slide for now. Abhi ke liye, do we understand everything until asymmetric encryption? Can we get into Bitcoin and how it works, and where does it use these concepts of public private cryptography and asymmetric encryption and ED25519 curves, and how does BTC work, and how the white paper at least stated that it works. Okay, we're at 88%. I will do a very small 1 minute, 2 minute Q&A to make sure it reaches 91%, and then I am happy to proceed. Since every message is signed by my private key, can I somehow decipher it at the end, and at the end rate? So you can't decipher it. That's the whole property of encryption, unless of course you have a quantum machine like you mentioned. At the end, quantum machines are growing. It might be very easy for anyone to do it. Yes, which is why people are now creating quantum resistant, or there are discussions around making BTC, Ethereum quantum resistant, which means everyone's public private key pairs would probably translate to something else. So yes, if nothing changes, then in 20 years, everyone will own everyone else's Solana, Ethereum, because computers will become so good at finding every public private key out there. But abhi ke liye, it's computationally infeasible to find all public private keys, or randomly get one that already has Solana in it. How bridging happens in crypto, whole different topic. Probably not a good discussion for today. But if you want to bridge from one chain to another, the way it happens is it gets logged on one chain, it gets minted on another chain. Specifically for USDC, if you use CCPT, Circles Transfer Protocol, or something like that, CCTP, Circles Cross-Chain Transfer Protocol, then because Circle owns the mint on Ethereum Solana Aptos, it can just burn it on one side and mint it on the other side. If you use something like Wormhole, then it happens a whole different way of locking tokens on one side and minting some random token on the other side that you swap for USDC. There are various types of bridges that exist, but not a discussion for today. How the value of cryptocurrency is decided based on trust and confidence of people, or is there any metric to decide the value of crypto? If it is based on trust and confidence of people who missed the chance to buy BTC and can start a new crypto, they can get benefit. Wow! Beautiful. The question is, why can I not create a new cryptocurrency and ask everyone to, trust it, and we can all create a new Bitcoin, and then we will all own the new Bitcoin because we missed the old Bitcoin ka whatever train. And the answer is yes, you can do that. Generally, current blockchains are gain value based on कि team इतनी पुरानी है, these are the features that this blockchain has, and this is what it introduces. For example, BTC, even though it's a very unoptimal and slow and computationally very expensive blockchain, still holds value because it's the oldest one. So it's you can create multiple blockchains, but they will not making people believe, okay, this will probably be the store of value. It takes time, which is what BTC and Ethereum have, and your coin might not. After sending data goes to the RPC first, then to the miner. What are RPC checks? And is sending coin means I am giving ownership to this coin to someone, to this user? A bunch of questions in there. After you send someone a coin, there are two types of coins you can send someone, either Solana or a custom token like a USDC or a Trump coin. You do send it to an RPC, which does forward it to a real validator in the end. RPC checks are if you're trying to do something, that for a fact is going to fail. An RPC can simulate your transaction and see कि आप जो करने की कोशिश कर रहे हो वो तो हो ही नहीं सकती. For example, you might be trying to do something when you have no Solana in it, in your wallet. So it doesn't make sense to forward the request, which are what are RPC checks. When you do say I've given my tokens to someone else, technically it means very different things on very separate blockchains. In case of Solana, it means they have that other user now has an associated token account in which a number exists. So if I've given them 100 USDC, the 100 number exists over there, and then in my associated token account it goes down by 100. If you're sending someone Solana, that means उस public key में जो data present है, उस data में my amount has gone down by 1, their amount has gone up by 1, and so on and so forth. Different blockchains pay. Technically it means a different thing, but yes, overall it means that the ownership of the coin has transferred. Can you explain why we need encodings and what are the use cases? Yeah. So, okay, a simple example is when you generate a public-private key pair, जो algorithms हैं RSA or whatever these algorithms are, they don't have a concept of encoding. They're just generating bytes. Their papers are written कि यार एक public key बनेगी ऐसे bytes में, एक private key बनेगी that will have some bytes in it. The public key might be 32 bytes. The private key might be 64 bytes. You and I can't share bytes with each other, right? If my public key was a bunch of bytes, then I would have to copy a bunch of zeros and ones and send it to you. And you would then, paste those zeros and ones somewhere and then, send money there. Which is also totally possible. In the end, when I copy my public key, it is actually converted to zeros and ones and, and then whatever, the Solana is increased or decreased. But for humans, it's really hard to understand, which is why any byte array is much better represented in hexadecimal in base 58. Right? Light has gone. अरे यो क्या हो गया? Hello. So the Wi-Fi stopped working. I am on mobile data right now. So I would like to check if you guys can hear me and see me before I proceed. Can you guys hear me and see me? It is laggy. All right, lagging a bit. We will take a small pause. We will just have a random conversation. Is there any database used in blockchains? Unfortunately not. Most blockchains have to move really fast, and most of them store most data in memory, and that is why you don't have a concept of databases. How string of numbers will be stored in binary like this? Well, again, it depends on mota uski encoding kya hai. Generally, strings are stored in ASCII. So even if it's a string of numbers, it will still be stored in ASCII. That is exactly why they say in JavaScript, if you have to store a very big number, then store it in the form of string. If you have a very big number that you want to store, then you should store it in the form of string, because this string eventually is encoded in ASCII. Am I sharing my screen? I am not. But if I do share my screen, this string is actually converted to ASCII. But if you are storing a very big number, then most numbers are either 32 bits or 64 bits, and hence you will run out of whatever space and not be able to store it. It still stores over here. JavaScript does some hacks over here, but I'm sure if it's a very big number, you have to use something else like bigint. Let's see if that's true. Yeah, it's just stored it, but does it actually store all the information in there is the question. For example, it's storing this. Yeah, it's probably not storing every number. Do you get it? I wanted to store a very big number. I couldn't store it in an int variable. I could only store, this much precision into 10 into whatever, 10 300. But if I do store, this very big number in the form of a string, I can. What does that tell you? That tells you, okay, even if you have a very big number or a small number, but if it's stored like this in a string, it's actually stored in ASCII and not stored as normal decimals. I'm sure it's still a little laggy, which is why I am just answering questions until the Wi-Fi comes back, and then I will move on to more stuff. So I'm going to stop screen share, and if you have any questions, I'm happy to answer until the Wi-Fi comes back. The long chain of data are moved in all system for checks. I don't understand that question, Himanshu. I want to learn about bridging, where you study and what are the resources and check for it. You can go through the architecture. Cohort 3 had random videos with snippets where someone asked a question and I explained bridging. And there is you'll have to find it. I think his name, Super31, had a student called 𝗟𝗶𝗀𝘀 or something who created a bridging contract, which is what I discussed in a few classes. So yeah, I will just read through the architecture. That's probably the best place. We can introduce a class eventually on bridging. I've seen libraries that convert data content from some files to another to base 64 string. Can you shed some more light on it? Converts content from files like PDF to base 64 string. I don't know why. I understand converting from PDF to Word. I don't know why you would want to convert a PDF to hex. I'm sure there's a specific use case that I don't know of yet. Apart from financial use cases, what are some of the other real world use cases of Web3? Unfortunately, not many. People are trying decentralized physical infrastructure networks, which basically means incentivizing someone for owning hardware. People are trying a lot of things. People are trying RWAs or real world assets, which somewhere or the other lie in finance. 99% of the use cases, real use cases right now, unfortunately, are only in finance. Private key is similar to auth token in full stack. You can say that, but auth tokens can be refreshed. If you share it with someone, it's not a big thing. If my net banking auth token of HDFC reaches you, most probably there's some OTP through which you will not be able to take my funds. But if your private key goes to a friend, your funds are gone. Considering your opinion on value of BTC, don't you think the value of BTC skyrocketed because earlier deep adoption on dark web networks? If that wouldn't be a case of dark web, then it wouldn't have had current value. You can sort of say that. Initially, it was one of the fewer currencies that could actually, you could basically, there was enough liquidity to convert it to US dollars and back from US dollars to Bitcoin. And it was sort of untraceable, even though BTC isn't really untraceable, which is why it was used initially in Silk Road and to buy drugs and to hire hitmen. and that led to the initial adoption. In fact, some of the biggest Bitcoin whales are people who used to just buy a lot of drugs and use Bitcoin for it. Let me try my other Wi-Fi one more time. Let me also message the guy so we can continue the class. It's already about to be 10:30. Wi-Fi not working, even though I don't know what this guy would do for Wi-Fi. Let me try moving back to the original school Wi-Fi so that we can continue the class. I think I might have connected. Can you guys hear me and see me well? Can we proceed? I see most yeses. All right, I will finish off the main discussion for the day, which is how would you create something like this on your own today, or how was Bitcoin actually created back in the day? If you want to create something like this today, what do you have to do? Number one, you have to write a program, something like bitcoinminer.exe, bitcoinminer.c, that people can run on their machines to become a miner in the network. इतना सबको समझ आ रहा है कि the point of a decentralized currency is there is no one single owner. So anyone around the world can become a validator or a miner. That means there is some program that you have to run on your hardware, on your MacBook, to be able to become the miner of an existing network. Or if you're creating a new one, you will write some code that will connect all of those machines, and all of those machines will do something together to maintain, the balance of every user. And if there's a transaction that is happening from A to B, it will happen on this machine. Write code in this program that dictates how the currency is initially minted. शुरू में सारा Bitcoin किसको मिलेगा? How to get who gets the initial supply? Is it developers, some initial investors? Is there some airdrop that has happened? This is again a very common question that you might get. कि जब blockchain बनी थी तो Bitcoin किसको मिला? Who got the initial Bitcoin? And the answer is, mostly validators do, or people who are the initial set of validators get a decent chunk. People who are the initial users get a decent chunk of the tokens. That is why the whole concept of airdrop farming exists. Whenever a new blockchain is coming, you start to use that blockchain heavily so that whenever their token comes, you get a small portion of that token when it is first created for the first time. Let anyone join the network be a miner by running this program. आप एक program बनाओगे, you will write the code in it, how the initial supply is given and what happens over time, how can people transact with each other. How will you receive a message from someone? How will you verify using their public key? How will you decrease the balance of that user? How will you increase the balance of the other user? All of this logic will be written over there. Anyone can join, run that program. If people want to send or receive BTC, they should create a public private key pair on their machine, just like I showed you one for Solfair. No username passwords, just create a public private key pair using the specific algorithm that our blockchain supports. To send BTC from your wallet to a different wallet, sign a transaction or message and send that transaction to one or many miners. For example, I might run a miner on btcminerindia.100xtabs.com. You will sign that transaction, you will forward the transaction to me. I will forward the transaction to all the other validators, and somehow, your balance will be decreased on one side and increased on everything your balance will be decreased, the other person's balance will be increased. What usually happens is when I receive a transaction, because blockchains are very active, I might receive 40, 50, 100 transactions in the span of, let's say, 2-3 seconds. Generally, miners bundle multiple transactions, let's say all transactions that came in the last 10 seconds, into a single block. That is why it is called a blockchain, because whenever you receive a transaction, there might be 100 miners right now, or there might be 1,000 Bitcoin miners all around the world. For Solana, there are like 800 validators that are currently running. So every transaction that I receive at my validator, I shouldn't immediately transfer it to everyone else. बहुत सारा, transfer हो जाएगा across 1,000 machines. What I will do is I will bundle all of those transactions one after the other. I will create a block. I will create a block of, let's say, 1,000 transactions, 2,000 transactions. Miners bundle multiple transactions into a block. The block is transmitted by the miner to everyone else in the network. मैंने वो block लिया, सबको भेज दिया कि यार ये सारी transactions आई थी मेरे पास, ये सारी transactions अपनी side पे भी कर लो. This creates a permanent record or ledger of all the blocks since Genesis. When Bitcoin started, the first Genesis block came out where Satoshi gave himself, let's say, some Bitcoin, all the initial developers some Bitcoin. Over time, more miners and validators came. All of those validators got some Bitcoin, and this, bought drugs from it, hired a hitman. Karte, everyone, now has, let's say there are 1 million active Bitcoin addresses, and all of these transactions since Genesis is nothing but a bunch of block 1, block 2, block 3, block 4, block 5, each block having 100, 200, 500, 1,000 transactions. A chain of these blocks, one after the other, is called a blockchain. Why is it a chain is something we'll come to in the next slide. But mota, there's 200,000 blocks that have happened since 2013. Every block has some, transactions stored in it. You chain them together until the current block, it's called the blockchain. All of these transactions translate to a lot of balances of various public keys all around the world for various people. There are a lot of problems with this approach, so मैंने बताई है. This is the most naive approach you might do. Write some code that will receive messages from users or transactions from users, bundle them into a block, broadcast it to every other validator currently running, and then everyone maintains this very long ledger or very long chain of blocks. Here is an example of what that looks like for BTC. We're currently at 932789 block since Genesis. This block was at 4 p.m. today. This block had 3,000 transactions, so on and so forth. There are a few more units over here that we'll come to eventually. Kilovolt unit and what this exactly means. And here is a visualization of, what exactly happens when, you want to make a transaction or you start a blockchain. When you start a blockchain, what happens is bunch of people are running that code that you started, a bunch of validators, your friends, people who want the initial airdrop, people who just believe in you and want to be a part of this network, people who want to earn your cryptocurrency, start running that code in their machines. These machines are all connected, through the internet. Let's say I got the initial supply of 10 BTC and this other person over here has, somewhere in Russia has some supply of 20 BTC. If I want to send 1 BTC from my wallet to them, what will I do? I will sign a transaction over here. I will say, Kya, to this other friend of mine, I will talk to them on the phone. I will ask for their public key. They will send me their public key. I will sign a transaction that says, send 1 BTC from my wallet to this other guy. This message will bundle into a block. I might receive 100 such messages and create a block. I will propose this block to everyone else. I will send this block to everyone. Let's say, इसको छोड़ के एक दो चीजें और होती हैं, but let's assume अभी के लिए कि this validator proposes this block to everyone, sends this block to everyone, and then this person's BTC balance increases by 21. This person's balance goes down to 9. Now, if I ask any of these validators, क्या तुम्हें क्या लगता है मेरे पास कितना BTC बचा है? So they will tell me you have 21 BTC because there is a block somewhere which has a transaction that says 1 BTC went from here to here. Then there might be more blocks over time that this guy proposes, this guy proposes, this guy proposes, and all of these blocks when joined together is also known as the blockchain. इसमें एक दो problems हैं, which is why we have a bunch of FAQs right after, but high level, that is how you would create a new blockchain today. That is how the BTC blockchain mota works. But there are a bunch of problems with the current approach and a bunch of common questions that you guys might have. As we discuss these questions, we'll understand a little bit more about the architecture of Bitcoin and actual में कैसे चलता है. I've shared a naive approach that sort of might work. उसमें ज़्यादा problems नहीं है. In this naive approach, there aren't too many problems. For example, in this naive approach, ऐसा नहीं हो सकता कि a random validator simply says कि यार this person sent 10 BTC, because every other validator will check कि was this message signed by this end user. Private key only exists with me. मेरी private key मेरे पास है जिसमें 10 BTC है. तो when I say I want to send 1 BTC, I only sign the message. I want to send 1 BTC. This person can't change that message a little bit and change the final signature. This person doesn't have my private key. So this person can't intercept transactions, can't create transactions. Validator कुछ ऐसा तो नहीं कर सकता कि किसी random बंदे का balance यहाँ से यहाँ भेज दे. क्योंकि even if this guy does it, as he proposes this block to everyone else will check. If everyone is dishonest, then it's a different question. But if majority people are honest, if this guy proposes something bad, other people will not accept it. If more than 50% of the network is dishonest, then it's a different question. तब भी तब तो मतलब ये कुछ भी बैलेंस यहाँ पे दिखा दें, but as long as more than 50% is not faulty, then these signatures will be verified, and this guy can't just change the amount from 1 BTC to 10 BTC. But there are a bunch of problems with this approach as well. For example, first question, can a miner move money from one random address to another? The answer is no. If they do try to propose a block with a transaction that has some random money from point A to point B, then of course their signature will be verified by everyone else, and since this message will not be signed by this guy, because इस validator के पास इसकी private key थोड़ी है. My private key for Solfair exists over here. I never send my private key to the validator. I only sign a message, send the signature. So at max, this guy can put it in a block and transmit it to everyone else. If it tries to create a faulty transaction, then every other validator will reject that block. So hopefully this question is clear. Similarly, there are a bunch of other questions that will harden our concepts about the architecture of Bitcoin. Before we get there, I would like to launch a poll to see if everyone understood until this point. A naive approach to start a Bitcoin validator or your own cryptocurrency validator today. Only 80% understood, which is why we open chat and try to answer a few questions that you guys might have. Some of these questions would be answered by these FAQs, and we'll come to them soon. But usse pehle, some questions until everything we've learned up until this point. Fork related questions I'll come to when we reach fork wala FAQ over here. Recap, let me do a recap really quickly. What is a miner, or who is a miner? Anyone around the world. Today, if I want, I can go to github.com/bitcoin. I can go through the code base of Bitcoin. I can clone this locally. I can run this, and I will be able to become a validator of Bitcoin. So anyone around the world can be a validator. Why would one be a validator? Because if you propose these blocks, just in this case, this validator proposed a block. Whenever a new block is created, whoever created the block gets some Bitcoin. That number changes over time. But I think right now that number is 3.2 Bitcoin. That means if I propose one block, I will make $300,000. That seems like a lucrative deal. I should probably clone the GitHub Bitcoin repository and start to run a Bitcoin validator today, because every block that I propose, every time I propose a block to every other validator around the world, I will get 3.2 Bitcoin, which today translates to $300,000. Of course, there are nuances to this. I will not probably be a block proposer, but we'll come to, what are those nuances. Is mempool a centralized server? Then how can a validator take transactions from it? Each validator has a mempool. How validators connect and contact each other? There are two questions that you have. The first question is a mempool. Mempool exists for every validator, might be different for various validators. But what's your question then? How can validator take a transaction from it? It can take a transaction from it. In the end, centralized or decentralized, what exists inside are signatures. So as long as there is a valid signature, doesn't matter if it's centralized or decentralized. If there is a valid signature, that means someone signed that transaction. That means that someone wanted that transaction to happen. But mempool wale question pe mempool ke baad aate hain. How validators contact each other? Of course, whatever code is written over here, you give some initial IP address of some Bitcoin miners, and then you somehow discover them, you tell them I am alive, and then they tell everyone else that miner is alive. This is called a gossip protocol, through which you gossip or talk to all the validators that exist. Initially, you have to give, in case of Solana, you have to give like some 3-4 main RPC URLs, so that you tell one server ki I am alive, I am now a validator, and then that person translates it to everyone else ki ye banda with this IP address is also a validator now. So all messages, all blocks should be transmitted to them as well. 4 questions I'll come to. Can't some powerful people own more than 50% of validator share? and misuse. They could. I mean, arguably, Google Cloud or someone who has a lot of machines can do it. We'll come to the nuances of how this can happen, but it could happen. But generally, the argument here that is given is if someone owns 50% of all Bitcoin supply or all the validators, then he can just make so much in Bitcoin reward. It wouldn't make sense for them to attack the network. They would just become the biggest validator of the chain and make a lot of Bitcoin reward. That basically means they get 50% of all Bitcoin rewards, which basically means every 10 minutes there is a 3.2 BTC reward. So one of these 10 minutes they are going to be the proposer, and hence every 20 minutes they are making 300k. So it just makes sense for them to continue being a validator rather than attack the network. Any other questions? What values are provided by BTC, ETH or SOL? Is there any particular use case? What is the value? Oh boy, वो जो शुरू में बताया था यार, मतलब कि crypto currencies are going away. Same thing, right? And what we discussed in the beginning, there is no value. Like value, what value does gold provide you? Do you dance with it at night? You don't. It stays in your locker locked for years. Argument for silver, gold, Bitcoin, Ethereum, Solana, Trump coin remains the same. It's all speculation, right? Real estate is the only real asset that actually provides some value. Okay, you can live in it. A fridge probably provides more value than gold or BTC. But a fridge is not as worth $100,000 or whatever, 1,43,000 per gram, because people believe this is my store of value. मुझे तो यही चाहिए. Everyone around the world feels that this is a store of value and hence it is a store of value. If everyone stops thinking it's a store of value, gold's price will go down to zero. Because everyone will start to sell it. यार अभी 1 लाख में बिक रहा है, बेच दो, इसकी कोई वैल्यू नहीं है. So the next person will be like, I will sell it at 99,000, and करते करते its price will go down to zero. So that argument applies to everything. Explain the mining process in detail. Let me do that one more time. So let's go through the slides one more time. Hopefully the visualization helps. Right now there are, let's see, Solana Beach. Right now there are a total of 804 Solana validators running all around the world. Total of 804 machines that are running some code very close to this Bitcoin code. जैसे Bitcoin का code है, वैसे there is some code of a Solana client or Solana validator that is running currently on 804 machines. So just like there are 5 machines over here, assume there are 814 similar machines that exist all around the world for Solana. I think you can see them here on a map as well. There you go. There are a lot of machines over here. There's only, there are no machines in India. 3 machines here, some in the US, mostly here, Russia, some here in Africa, so on and so forth, some in Europe. Notice one such validator is highlighting every 10 seconds. This one highlighted, this one highlighted, this one highlighted again, this one highlighted, now this one highlighted. This is a validator. In 180 validators में से one validator proposing a new block, telling everyone that in these 5 seconds, these 1,000 transactions happened. Let me share that with everyone. So every 10 seconds, every 5 seconds, every 3 seconds, every 200 milliseconds, what is happening? Some validator over here is proposing a new block. A block is a bunch of transactions. Basically means if I go here, if I click on send, if I put some amount, and if I put a public key and I click on send here, this transaction will go to one such validator through an RPC, but eventually यहाँ पहुंच जाएगी, बहुतों के पास पहुंच जाएगी. It will reach this guy. This guy will put it in a block. This guy will verify that I have actually signed this message, and then it will broadcast it to everyone. Once it is broadcasted to everyone, it will say success over here, and my Solana balance will be decreased by 1, and some other person, this person's Solana balance will be increased by 1 on all of these machines. In sub machines pe, Harkirat's balance will go down by 1. The other party's balance will go up by 1. Why? Because I legitimately want to send someone that much Bitcoin, Solana, because I might receive water in lieu of this. कि मैं उनको बोलूँगा मैं आपको 1 सोल भेज रहा हूँ, मुझे पानी चाहिए उसके बदले, और whatever I might want to buy from them. So there are such validators running. Me Currently you hold 2 Solana. Me sign a transaction to send 1 BTC to 1 Solana in this case to someone else, forwarding this transaction here. This person creating a block of many transactions, one such transaction being mine. This person proposing this to a bunch of other validators, all the other validators verifying the block, making sure it is correct. My balance going down by 1 Solana, other person's balance go up by 1 Solana. Now when I open my Solflare, I will send a request to one of these RPCs, these machines. Think of RPCs as the minor validator machines for now. And them telling me कि यार आपका Solana 2.26 नहीं 1.26 Solana हो गया, because 1 Solana I sent from myself to this guy. That is what is happening. That is how this transaction is propagating through this network of me signing the message, forwarding it to one machine, it getting broadcasted to various machines, a block being created out of it, that block being propagated. By the end, all of these machines have a bunch of these blocks since the beginning of time, a bunch of these balances of every users, so on and so forth, stored on this very big machine. एक बहुत बड़ी machine है, उसपे सारे blocks मान लो. Of course, not all blocks are stored. There are too many blocks that exist, at least for Solana, because Solana has, a lot of transactions it supports per second compared to BTC or ETH. So no one actually holds all the blocks. There are only 2-3 nodes or storages that exist that hold every block since the beginning. But mota sabke balances and whatever information you might want to see over here is stored somehow here. Every transaction might not be stored. Balances are indeed stored in all of these machines all around the world. Good questions to ask at this point is, who decides who will propose the block? Because we said whoever proposes the block in case of BTC gets 3.2 BTC. In case of Solana, probably gets some Solana. That's their incentive to run a validator. Why else would you run a miner or validator? In case of Solana, you would run it to receive some SOL in return. Every time I propose a block, मुझे थोड़ा extra नया Solana मिलेगा. Newly, freshly minted Solana will come to me. The same is true for BTC. That's the whole reason you might want to become a validator. So today, if I want to become a validator, what will I do? I will most probably rent a VM in some cloud provider. Most of them exist over here. Like Latitude is one. Rent a machine over there. It usually costs $1,000 to $2,000 a month. Run the Solana code over there. Now there are some nuances around staking and consensus that we have to understand. But mota, I will need to rent a machine somewhere in some data center here. There might be a very popular data center जहाँ पे सब अभी run करते हैं for $2,000 a month. Run the Solana code over there and hope that I will make more money than that. There are more nuances to this statement. We'll come to those nuances eventually. Now, do we understand the process of mining, a more simple process of mining? We will now get into some more technical details around BTC. But Bitcoin को छोड़ के क्या हमें सारी nuances समझ आ रहे हैं थोड़े of how a validator runs and what happens when I send someone BTC and how it propagates to the network. How can you visualize the validators? Okay, 85 से हम 90 पे ही आ पाए, which I think is fine. A few more nuances that I want to talk through and hopefully, कुछ questions जो अभी समझ नहीं आ रहे हैं, you might get clarity on them as we answer these questions. Question number 1. Can a miner move money from one random address to the other? In the end, it feels like there are only 800 machines that store everyone's balances of Solana, which is billions and billions of dollars. So can't one of these machines, when it is a block proposer, say कि यार Harkirat wanted to send $9,000. वो बता नहीं रहा है, but वो भेजना चाह रहा था. They can't, because unless I have signed that transaction using my private key that only exists over here, even if they propose this in a block, no one else would accept that block. Everyone else would reject that block and say कि यार तुम कुछ shady कर रहे हो. You are doing something shady. Harkirat has not signed this message. Because I am the only one who has this private key, at least today, until quantum machines come out, I am the only one who can sign this transaction. Which miner should I send my transaction to? अगला क्वेश्चन ये आता है कि जब मैं यहाँ पे हूँ and I click on send, am I sending my transaction to this guy? Do I need to know upfront कि लीडर ये होने वाला है या लीडर ये होने वाला है? Do I need to find that specific machine, or does something else happen? So different things happen for BTC and ETH. In case of BTC, you broadcast the message to 1, 2, 5, 20 Bitcoin validators or miners, and they आपस में share these transactions with each other. तो अगर मैंने एक transaction, if I send a transaction here, here, here and here, it will slowly get broadcasted to everyone else. Now it might happen that it didn't get broadcasted to the leader. So my transaction might get dropped, or it might stay in something called as the mempool. So in case of Ethereum, I think in case of BTC also, check if it's true for BTC, most probably is. In case of Ethereum, there is this concept of a mempool which exists, which someone asked for in chat as well. कि हो सकता है I might have opened this, clicked on send and sent one SOL to a friend of mine, clicked on send, and that transaction might not immediately reach, let's say, this guy who's proposing the block, or even if it reaches this guy might be like कि मैं हरकिरत की transaction नहीं include करूँगा block में. So this transaction will exist in a mempool and it can exist there for days. वो 5 दिन तक वहीं पड़ी रहेगी, and then on the 5th day someone might include that transaction, which is like very bad UX for Ethereum, because if I send someone money, I either immediately feel कि हो गया है or I feel reject हो गया है. In case of Solana, that happens. Solana has a concept of recent block hash that ensures that. Ethereum, and I think in BTC also, I could click on send and that signed message of mine might exist in all of these machines as mempool. वो वहाँ पे पड़ा रहेगा. And then whenever this guy feels like including my transaction, whenever the current leader feels like including my transaction in a block, it will include it and propose a block, which might happen after 2 days, might happen after 5 days. That is what happens in Ethereum, I think in BTC also. That does not happen in Solana. Solana doesn't have the concept of a mempool. So the question was, which one should I send to? The answer is send it to 3, 4, 5 or a reliable RPC जो forward आगे broadcast कर देगा तो 4-5 को. If your transaction reaches 4-5 of these validators, it will get broadcasted to everyone else, which means hopefully it gets broadcasted to the block proposer who is currently going to propose the current block. Clear? Third question. What if a miner doesn't include my transaction? As I said, totally possible. It can happen. There can be blacklists or less incentive for a miner to move your transaction. That is why the concept of tipping exists. आप एक्चुअली एक एक्स्ट्रा टिप डाल सकते हो वैलिडेटर के लिए. Whenever drops happen, some very popular NFT is coming, people send 12 Solana of tip to the validator. Some of my friends that run validators tell me this कि यार 12 सोल की टिप आ गई या $20,000 की टिप आ गई इस ट्रांजैक्शन में. The point of tipping is कि you incentivize the validator to pick your transactions amongst many. If there is some very popular drop, you will send your transaction, you will also send a tip of 20 SOL कि यार मेरी ट्रांजैक्शन को इंक्लूड करा. सो whatever validator is currently proposing the block will be like, यार सबसे पहले तो मैं हरकिरत की ट्रांजैक्शन डालता हूँ, he is tipping me 20 SOL. That is why the concept of tipping exists. If there's a lot of activity, a lot of people want to put a transaction in the blockchain, you can tip the validator so that he includes your transaction, which is why validators make a lot of money during Trump coin launch or some random coin. When there's a lot of activity, validators make more money because people are tipping more often. Why would a person start a new miner? What do they get? When you propose a block, you add a transaction to the top of the block that gives you the block reward. In case of BTC ऐसा होता है कि यार amongst the many transactions that you're adding, you also add one transaction that mints new BTC to yourself. So you send 3.2 new BTC to yourself as well every time you propose a block. This is how new BTC is added to the system. So what did we say initially? Gold has predictable mining. It is almost certain, at least has been over many years, कि gold doesn't get mined at 100% every year. ऐसा नहीं है कि gold की supply double हो जाएगी tomorrow. Some predictable 3, 4, 5% in some mines all around the world, gold is minted. The same is true for BTC. It has a predictable new BTC that is being created. US government can print money whenever they want. BTC, only every 10 minutes one block is proposed. Whoever is the block proposer gets 3.2 BTC, and over time this reward will go down. After 150 years, this reward will become zero. There are a lot of questions around what happens after 150 years. जब the block reward of Solana goes down, BTC goes down to zero. But at least for the next 150 years, it will just keep halving every some 3-4 years. Every 4 years, the block reward becomes half. But the hope is कि BTC इतना महंगा हो जाएगा तब तक कि it will still be lucrative for miners to come and run validators. You can also earn tips based on whose transactions you want to include. People might want to tip you if they want their transactions to be included quickly. So block subsidy or block reward, transaction fees or tips that the people are giving you for every transaction. That is why you might want to run a validator. So the next question that comes is कि मैं कर देता हूँ चालू, I'll start to propose every block, Why can't I be the block proposer for every block? That would be great. If I start a BTC miner today, I will just start proposing blocks left, right and center, and every 10 minutes मेरा block ही जाए वहाँ पे. Why wouldn't a miner always start to propose a block then? I would want to keep all the block reward for myself. I'll just start a new miner and start proposing blocks every 1 minute. ये लो जी block, ये लो जी block, ये लो जी block. I'll be the only block proposer. How does this get fixed? Different for different blockchains, different for... This is where the term consensus algorithms come into the picture. In case of BTC, the consensus algorithm that is used is proof of work. In case of Solana, it's something else, proof of stake. In case of Ethereum, it's proof of stake. Solana, it's debatable, proof of stake है, proof of history है. But specifically around BTC, what we're learning today, what happens is, to be able to propose a block, you need to solve a cryptographically hard problem. हमने hashing पढ़ी थी थोड़ी देर पहले. Hashing is going to come back over here. I think internet connection is unstable. Is the internet connection unstable? Hello. Can you guys see me, hear me? Are we good? We take a small pause here. Latitudes are profitable. Beautiful question. Unfortunately, Solana does use proof of stake, and for that you need stake to be able to be profitable. That basically means you need $20-30 million worth of Solana pehle hi to be able to make some profits. Specifically only true for Solana. So your only expense is not $2,000. I'm going to answer a few questions before I get back into the slides, even though I think the internet is fine now. Let me do a poll. Can you guys hear me well? Can you guys see me well now? Can I proceed with the class? Is the Wi-Fi good? Is the internet good? Yes or no? I see a 91% yes. So I will take that as a yes and reshare my screen. The question was a very beautiful, interesting question. Why don't I start proposing all the blocks? Because to be able to propose a block, you need to solve a cryptographically hard problem. If there are 100 miners right now in the BTC network, and let's say every miner has a 4 CPU machine, they all are solving the same problem. सब बैठ के एक puzzle को solve कर रहे हैं. The more CPUs that you have, the higher probability of you solving that puzzle. So if I have 8 CPUs and other guy has 2 CPUs, I will be a block proposer 4 times more than them. But if let's say right now there are 100 miners and all have 4 CPUs, then on average you will only be able to propose one of every 100 blocks. That might not be true, In case of Solana, this logic only doesn't apply. But let's assume this is the BTC miner map right now. Then, if all 800 of these machines have the same amount of CPU, if all 800 of them have 4 CPUs, then I will only be able to propose one block every 800 blocks. Why? Because on average, ये जो puzzle है पहली बार मैं solve करूँगा, second time the second guy will solve, third guy will solve. Based on pure probability, because there is no advantage my machine has over their machine. If both of us have 4 CPU machines, both of us will it will be a coin flip on if I solve the puzzle or they solve the puzzle. 50% probability. If there are 3 people, then 33% probability I solve the puzzle, 33% they solve the puzzle, 33% they solve the puzzle. To be able to propose a block, you need to solve a cryptographically hard problem. If there are 100 miners right now, on average you'll only be able to propose one in every 100 blocks. This is why people say BTC is bad for the environment, because thousands of machines all around the world are solving the same futile problem. There is nothing, it's not like it is some machine learning algorithm that everyone is running on these big machines. They are solving a futile problem. Futile मतलब उससे कुछ machine learning model train नहीं हो रहा है. There is no outcome that comes out of it. But everyone is solving that problem to become a block proposer. A good question you might have is, Kirat, why? मतलब if there are 800 validators, give the first person the first block, give the second person the second block, give the third person the third block, and keep rotating amongst them. Why do they have to solve this challenging problem? And the answer is, if you do that, person 1 is solving 1, person 2 is solving 2, then I could just start 100 small phones per BTC ka miner, and I will have 100 voting power amongst these 800 people. But of course it will be very hard for me to compete with 800 people on compute. अगर उन सबके पास Mac है तो मैं 100 मैक नहीं खरीद सकता. I cannot buy 100 Macs and compete with all of them. But I can buy 100, very small phones and compete with them. So if one IP address would be one vote, then I could get 100,000, IP addresses and become the biggest BTC validator, attack the network. But if CPUs are how you vote, if one CPU is one vote, and then I'm competing with millions of CPUs all around the world, and I won't be able to get, half of the CPU supply to myself to attack the network. That is why it doesn't go, CPU 1, validator 1, validator 2, validator 3 like that. It goes through some other way. In case of Solana, it does go validator 1, validator 2, validator 3. But Solana does something else, which is why over there that is not a problem. In case of BTC, it would be a problem. This is why people have farms that look like this, because such a big farm also might only be able to mine, let's say, one block every day. So, itna bada farm whose monthly expense might be $1 million to run might only be able to propose one block a day, because if this guy has 100,000 CPUs, there is some other validator that has 100,000 CPUs. There's enough incentive for people to include more and more idle compute to become a validator. Which is why people say that from your laptop you probably won't be able to mine, because you won't be able to solve that problem when you're competing against so many machines. That is why Bitcoin pools exist. I want to include my laptop's power in this Bitcoin pool, and if this guy does get a reward, I get some cut of that reward, because I was also participating in this pool. But to actually make money every day and propose a block every day, you will have to create a Bitcoin mine as big as this, because your small laptop won't be able to solve that puzzle as fast as so many machines trying to solve that puzzle. What is that puzzle? We will get to. But hopefully you understand how the block leader or the block proposer is decided in case of Bitcoin. In case of Ethereum, it's something else. In case of Solana, it is something else. In case of Bitcoin, the block proposer is purely the person जो उस 10 मिनट में ब्लॉक बना के उस प्रॉब्लम को सॉल्व कर ले. The person who can, in those 10 minutes of, when you want to propose a block, is able to gather all the transactions and solve a puzzle. What is that puzzle? We'll get to very soon. What if two people, this is where things get a little tricky. 1, 2, 3. We'll answer these questions soon. पहले मैं एक बार block proposer वाली चीज बता देता हूँ. What is this puzzle that people have to solve? The puzzle that people have to solve looks something like this. If the block that they are proposing looks, something like this, कि यार Harkirat transferred, or public key 1 wanted to send public key to 2 Sol, or 2 BTC in this case. That's transaction number 1. Transaction number 2 might be some random other public key wanted to send someone 0.2 BTC, let's say, so on and so forth. It has this block created. The way the puzzle that it has to solve is, it has to take all of this text. So this text right here, then this text right here, then this text right here, all of these signatures, all of these transactions it has to take, and it has to find a number to add to it, 0 or 1 or 2, such that the hash of this, using some algorithm, starts with 10 zeros. Very weird puzzle to solve. The puzzle states कि यार जो भी आपने ब्लॉक प्रपोज किया है ना, all of that text के बाद एक नंबर ढूंढो such that its hash starts with these many zeros. Do you remember hashing? हमने पढ़ी थी थोड़ी देर पहले. What did we say? कि hashing is one way. Given some text, you can find a hash. Given some random hash that you might think of, you can't get its original text. So the only way for you to find a hash that starts with 10 zeros or 20 zeros is to brute force this number. 1 hai, 2 hai, 3 hai, 4 hai, 5 hai, and find this number which is called the nonce. Let's try it out. Let's say these were the transactions. Let me find a hash generator online, SHA-256. These are the transactions. Now I have to find a number that I append to it such that the final string starts with, let's say, 3 zeros. I will spend a lot of time trying to find just one number that I can find जब वो 1 0 से start हो. 21, 22, 20, 23, 24. It's taking me so long to find a number. Finally मिला 27 पे जाके I was able to find a hash that starts with 10. So if the Bitcoin puzzle said here when you are proposing a block, find a nonce such that the final hash starts with 10, तो मैं कर लेता. But if it says कि the final hash should start with 20 zeros, then as you can tell it will take a lot of time for me. This number of zeros changes over time based on how much machines we get or how cheaper machines get to ensure कि जो block time है वो 10 minutes है. I repeat, the number of zeros that you need to have in your final hash changes over time as machines become more accessible, as more people join the Solana, the BTC network, and they start to propose blocks quickly to ensure कि एक block 10 मिनट में ही आए. On average, every 10 minutes one block should be proposed. This puzzle gets harder and harder over time. Or the number of zeros that you need in the beginning become more and more over time, which would basically mean the time that you have to spend to find this nonce sort of increases over time because the compute gets easier and cheaper over time. That is the hard puzzle that you will have to solve before you propose a block, and that is why on average if you own 1% of the CPU power, on average you will be the block proposer 1% of the time because everyone is solving the same SHA. Everyone is trying to solve the same algorithm and find the x number of zeros. सब लोग वही चीज कर रहे हैं. तो on average if you own 2% of the CPU, you will be the block proposer 2% of the time. So you have to figure out based on electricity in your country and whatever expenses that you might have to buy and procure equipment, if it makes sense to be a block proposer, and how much of the compute you will own compared to the full network to see how much of the block reward you will get over time. And इसको छोड़ के थोड़ा तुक्का होता है कि it might happen that someone tipped 1 BTC for a transaction, and you were the block proposer then, तो तुम्हारी किस्मत चल गई, or the price of BTC shot up, or whatever, there is some activity, Trump released a coin, so everyone's trading on Solana, so all the validators are making a lot of money. So the money that you make goes up and down over time based on a lot of factors, which is why if your fixed cost is, if you're currently making 1 lakh of profit, you might make 1 lakh of loss next month if there is no activity on the network, or if the price of Solana halves or something like that. Cool. That's how the puzzle that you have to solve. अब आते हैं कुछ इंटरेस्टिंग सवाल. फर्स्ट इंटरेस्टिंग क्वेश्चन, व्हाट इफ, इससे पहले यहां तक सबको समझ आ गया? एवरीवन क्लियर अंटिल दिस पॉइंट? 3 more questions left, 3 more FAQs left. Everyone clear until this point? What is the puzzle that you have to solve and why the puzzle is included so that no one random can become a block proposer? It changes over time. 89%, good enough. Next question is, what if 2 people are able to solve the puzzle at the same time? If this is the current Bitcoin validator set, let's say this person and this person solved the puzzle at the same time. Both of them will broadcast to the network कि मैं हूं block proposer, I am the block proposer, I win the block reward. So this guy will do it to everyone. This guy will do it to everyone. What will happen is, आधे लोगों को लगेगा ये सही है, आधे लोगों को लगेगा ये सही है. What will happen is, all the validators that are close by here will think this guy is the block proposer. They will include this guy's block. All the validators that are over here, because this guy is closer to everyone over here, might feel कि यार this guy was the right block proposer. And it's not necessary both of them have the same set of transactions in the block. This person might have my transaction, this person might not have my transaction, or might not have picked my transaction. So what happens over there is, a fork is created in the blockchain. आधे लोगों को लगता है this is the right 39900th block. Half of the people feel this is the right 39900th block. So what happens is, a fork like this is created in the blockchain. Everyone was agreeing on the same blockchain, same chain of blocks, but suddenly this guy proposed something, and at the same time this guy proposed something. They were both able to solve the problem at the exact same time. So what happened is, everyone over here thinks like this is the right blockchain, everyone over here thought like this is the right blockchain. So for a few blocks there might exist 2 blockchains that people might think are the current set of blockchains. What happens eventually is, the fork gets resolved based on, ऐसा हुआ कि let's say all of these machines think this is the current blockchain, and then this guy quickly solved the next puzzle, and no one else was able to solve the next puzzle over here. So this guy in his fork added a new block, broadcasted it to everyone else, and there is a rule in the Bitcoin white paper or generally the Bitcoin code base that the current longest blockchain is considered as the valid blockchain. There are reasons around this. We are coming to this reason कि ऐसा क्यों है. But the Bitcoin white paper and the code base states कि यार even if I thought this is the right blockchain, if someone else comes and says कि यार हम लोग यहाँ तक तो same है, there was a fork over here and I have reached over here, you are still behind, I am the longer blockchain, everyone else accepts the newer blockchain. So all of them will discard these two blocks, will move these transactions back to their mempool and continue with the old blockchain. So the forks usually get resolved themselves because the probability of this happening, कि यार this guy found puzzle and this guy solved puzzle at the same time, and then amongst this fork this guy solved the puzzle and this guy solved the puzzle at the same time, and then third time also that happened. Very low probability of that. Might happen once, might happen twice, but very low probability के 8 blocks निकल गए and both the sides are able to solve the puzzle at the same time, which is why at some point it will happen कि one person will say कि यार मेरा तो तीसरा block भी आ गया यहाँ पे, and everyone else including these guys who thought this fork was right will move to this fork, and this will become the main blockchain. These transactions will sort of get removed from the blockchain, which is also a very interesting question कि यार ब्लॉकचेन में मेरे को तो लगा था मेरी ब्लॉकचेन में यहाँ ट्रांजैक्शन आ गई, बट आप कह रहे हो हरकीरत कि फोर्क्स हो जाते हैं एंड ट्रांजैक्शंस माइट मूव बैक और गेट रिवर्स्ड. दैट सीम्स वेरी स्कैरी. व्हाट इफ आई एम हियर इन कैनेडा एंड आई वांट टू पे समवन फॉर सम ड्रग्स, लेट्स से. सो आई सेंड दैट पर्सन BTC, मेरे सामने खड़ा है, आई सेंड हिम BTC. आई सॉ दैट ब्लॉक ओवर हियर कि हाँ I showed it to the other guy, देखो ब्लॉकचेन में ब्लॉक आ गया है, I have sent you BTC. The other guy also saw कि हाँ भाई ब्लॉक आ गया है. The other person gave me drugs. Now I am happily having drugs and पता लगा ये fork reject हो गया. I am very happy. If this fork gets rejected, then my transaction gets removed. That means मेरा BTC balance फिर से बढ़ गया, उसका घट गया. My transaction got removed. I got back my BTC and I also have the drugs that I am enjoying. So for the other party, this is really bad, which is why whenever you're sending someone BTC or receiving, you usually wait for 5 blocks to get added, 5 to 6 blocks to get added before you consider the transaction to be confirmed. Very low probability के 6 blocks निकल गए और 2 fork चल रहे हैं साथ साथ. एक 1 block, 2 blocks, 3 blocks, it's fine. But very low probability after 6 blocks also, 2 forks are parallelly running, and a reversal can happen. So if you receive BTC from someone, don't give them your phone or whatever you promise them in lieu of BTC until you see 4 or 5 blocks added after the block in which your transaction is included, because it might happen that this fork gets rejected for a different fork eventually. These are called forks in the blockchain. Can happen from time to time if 2 people solve the problem at the same time and 2 people propose a block at the same time. Half of them might choose this guy's block, half of them might choose the other guy's block. But eventually, at some point, one of these blockchains will become longer, and whenever it does become longer, it will still broadcast it to everyone, and everyone else will realize कि हाँ भाई ये लंबी blockchain है, I am going to accept this fork and reject my original fork. The only problem that comes with this is that it sort of makes transactions reversible, and hence you should ensure that only after 4 or 5 blocks have been added after your block in which the transaction was included, should you give the other party whatever you were trying to give them in lieu of BTC. That is what are forks in a blockchain, and what happens if 2 people propose a block at the same time. Eventually, one fork will start to become longer and broadcast this fork to the miners that currently maintain the other fork. These other miners will then accept the longer fork and discard the original fork. This happens automatically and rarely does a fork sustain for more than a few hours. तो इससे लग रहा है कि यार ट्रांजैक्शंस रिवर्स तो नहीं हो सकती. It feels like transactions can't be reversed. If I wait for 4 or 5 blocks to happen after the block in which my transaction was introduced, very low probability that this fork gets rejected and another fork comes. But let's consider one more case. आखिरी चीज है आज के लिए. One more case. Can a transaction ever be reversed? Can you create A new fork that doesn't have a transaction that you want removed from the blockchain. Very important question. Last question for the day, then some visualizations. Can a transaction ever be reversed? एक blockchain है, मस्त चल रही थी ये blockchain. On this block, I included a transaction of mine in which I sent my friend 2 BTC. In return of it, my friend gave me a camera. मेरे को उससे कैमरा खरीदना था. I wanted to buy camera from him. In this block, a transaction was sent by me to him, and he gave me a physical camera. उसके बाद 2 और blocks आ गए. Normal blockchain was running. I also run one of the bigger validators on BTC. मेरा एक Bitcoin validator भी चल रहा है. I am also running a Bitcoin validator. What if I propose a new block after this older block and say कि यार इस block में वो transaction नहीं थी. What if the normal blockchain was going on? What if my friend left, he gave me a camera. As soon as he left, I proposed a new block. I solved the challenge for it, what puzzle. It took me 2 hours to solve the puzzle. But in those 2 hours, I was able to solve a puzzle for this older block. What if I propose this older block and say, यार ये था block. After this guy came. And then after that, the normal 2 blocks that came, I say those also. कि हाँ भाई, ये fork सही है. And in this block, I removed the original transaction that I had added, in which I was giving my friend BTC. What if I try to update a block by removing my transaction and putting all the rest transactions over here, and इसके बाद के भी blocks में propose कर दूँ कि यार ये नया fork आ गया और ये लो जी नया fork same का ही, आप इस fork को accept कर लो please. Everyone will sort of technically maybe accept the other fork because the length of both the forks is the same. And this ka proof of work some machine has done, this ka proof of work puzzle solving some machine has done. So I just copy over their hashes which have a certain number of zeros. I just have to repropose one block in which I remove my transaction. Can I do this? That way my transaction will be removed. So from this new blockchain, I will still own the original 2 BTC. The answer is, I could propose that. And ऐसा नहीं है कि miners will reject. Miners don't have logic to reject कि यार ये तो पुराना block आ रहा है, तो I will reject this. What will actually happen is, every time you create a block and solve the puzzle for it, right? एक चीज मैं बतानी भूल गया था. Every time you create a block, जिसमें you remember you put a bunch of transactions, then you solve this puzzle for it. Do we remember this? Okay, we create a block with all of these puzzles. We find the number such that the final hash starts with a bunch of zeros. One small detail I missed. Whenever you are creating a block, you will take the previous block's hash. I repeat, you will take the previous block's hash and you will add it to the top of this transaction. ये भी आपको करना पड़ता है. Every block contains a hash of all the transactions in this block and a block hash of the previous block. First block का कोई hash नहीं है, मान लो 0 है, जो भी है. The second block needs to take this guy's hash and all the transactions and then find the nonce such that इसका hash starts with 20 zeros. This guy needs to take this का hash and all the transactions over here and find the nonce. Why this extra detail? So that अगर कोई बंदा ये try करे, if someone wants to propose a new block over here, this block now doesn't have my transaction that was here. So इसका nonce will change, इसका hash will change. And hence, I cannot use someone else's proof of work. क्योंकि उसने जब proof of work किया था, previous transaction hash was for this. I will have to redo the proof of work for this also. I will have to redo the proof of work of this also. And मैं compete ही नहीं कर पाऊंगा main chain से, because in the main chain so many machines are proposing blocks and solving the puzzle. In my fork, चलो एक block का I'm able to solve the puzzle, but unfortunately the blocks that came after I have to redo the work because this block का जो original puzzle solved था, original nonce found था, that included or assumed this transaction hash. When the puzzle was solved, it was solved with the previous block's block hash. And now the previous block that I am proposing changes. its block hash also changes, and hence this blockchain can't reuse the proof of work for these two blocks. This guy has to redo the proof of work. तो वो जितने में redo करेगा proof of work, इसका भी एक machine, उतने में the bigger blockchain will go much longer. Hence, mathematically it might be infeasible, highly improbable, almost impossible for you to propose a new fork. क्योंकि आपको सिर्फ उस block को repropose नहीं करना है. You just don't have to propose that one block. If I want to go back in history and change this block, I have to redo the proof of work of everything that came after, which is the proof of work of so many machines all around the world constantly solving this problem. My one single validator cannot compete with so much proof of work that has been done over the years. तो चाहूं तो मैं प्रपोज कर सकता हूं नया ब्लॉक नंबर 2 भी सतोशी के बाद वाला, but every validator will accept the longer chain. The longer chain now has 6 lakh blocks. It is computationally infeasible for me to do the proof of work of 6 lakh blocks that came after that and repropose all of those blocks. That is why it's very hard to reverse a transaction. If there are 20 blocks that came after a transaction, even 6 blocks that came after a transaction, very low probability someone new can come and change an old block, propose a new old block and compete with जो 6 blocks है उनका recomputation and everyone else that's adding more and more blocks. So as the number of blocks keep on getting added, it's very hard for you to go back in time and propose a new block here, because you don't have to do the proof of work again for just this block, but every block that came after. That is why it's very hard for you to reverse a transaction in a blockchain. If you want to see this visualized, here is what a blockchain demo would look like. This is block number 1. Here, Satoshi might send himself these many BTC. That's the only transaction, let's say, that happened. And Satoshi का developer friend था, तो developer friend public key also got, let's say, this much BTC. Previous block hash is 0 because there is no hash before this. There is no block before this. This is the first block. Then Satoshi started to mine. He started to find a nonce, a number such that the final hash starts with 4 zeros. Then he proposed this block to everyone. Everyone accepted that block. उस टाइम पे 4 ही Bitcoin machines होती थी. And then everyone started to solve the second block. The second block, Satoshi might want to buy some pizza. So Satoshi to pizza guy 1 BTC. And his developer friend might be surging on drugs or you're splurging on drugs. So developer friend to drug guy 3 BTC. Notice this has block number 2. Nonce that it needs to find. It's red because this nonce is incorrect. The data and the previous block ka hash. This previous block ka hash plus these transactions, it needs to mine for and find this number such that the final hash of previous hash plus these transactions plus these nonce leads to this new hash. Second block has been created. In the third block, the drug guy might have, God, I'm getting really bad ideas here, but another friend guy, or let's say drug friend guy to, 0.5 BTC. And then Satoshi also, got a developer, whatever we call them, what Solana has, grants program, or, BTC grants program or ecosystem project where, Satoshi paid, Raman 2 BTC for a project to build on Solana. Again, the nonce will be recalculated based on the transactions plus previous block ka hash. Let's say this was an empty block. Now the blockchain has 4 blocks. If someone wants to come and remove their transaction from here, does this nonce become invalid? इसके बाद वाला ब्लॉक का भी नॉन्स इज इनवैलिड नाउ बिकॉज इसके प्रीवियस वाले का हैश चेंज्ड. सो दिस गाय चेंज्ड एंड हेंस दिस नॉन्स इज नो लॉन्गर इनवैलिड. इट नीड्स टू रीमाइन टू फाइंड दिस नॉन्स. इट नीड्स टू रीमाइन दिस टू फाइंड दिस नॉन्स. उसको इतना काम फिर से करना पड़ेगा. ही विल नेवर बी एबल टू कम्पीट विद द ओरिजिनल ब्लॉकचेन एंड हेंस you can't go back to a block and change it. If you do try to change it, you will have to mine for every block that comes after that, which is computationally infeasible. That was Bitcoin, my friends. Hopefully some of you understood the intuition behind blockchains and how someone created proof of work, this extremely unoptimal thing back in 2009. And that became the genesis of cryptocurrencies in general. Now we have more optimized blockchains, faster blockchains, computationally better blockchains, blockchains with better consensus algorithms. This was the original paper and the original implementation of Bitcoin, which is not the worst currency in the world, but it has some challenges in it. It is slow. It only creates one block every 10 minutes. So if you send a friend BTC, you will have to wait for 10 minutes, hopefully 40 minutes, for 4 blocks to come after before you actually give him the camera. So that's why it's not practical for day to day, which is where Solana and Ethereum come into the picture. But we will get to them when we get to them. Do we understood the architecture of BTC? How it is irreversible? What is the process of mining? What is the nonce? How do you find the nonce? How does the block proposal only comes once, once every few times? And how you need a lot of compute to be able to cover 51% of the network or whatever, propose a block. That was a longer video. Took us around 9:30, 10, 11. Oh, less than, close to 2 hours. Oh, 8:30, almost 3 hours longer video. My bad. I will open it up for questions now. If you have any more questions, please do let me know. And then we will call it. Let's see. What is the drop that you mentioned in Solana? Why is the miner tipped and how does the user benefit from the drop? Yes. Drop is basically sneaker drops. नहीं पता क्या आपको, जैसे if sometimes Nike does a sneaker drop on their website, or Coldplay tickets. India is coming to Coldplay. Coldplay is coming, longer class. Coldplay is coming to India. So there is a drop basically means a website where there is some scarce resource that everyone is trying to buy. So on BTC or on Solana, these are NFT drops or Trump token buying during that time when everyone was trying the Trump token and everyone knew okay, fuck Trump has a token now, so everyone was trying to buy it. So many people were trying to do the same thing. Okay, your transaction wasn't going through. So that time it makes sense to tip one soul to be able to buy $10,000 worth of whatever Trump coin. For example, back in 2020. I paid $600, believe it or not, or some 0.5 ETH as tip just to buy an Adidas NFT that came. Let me find it. It's been years. And I was still profitable, by which I mean I bought it for 1 ETH and it immediately went to 3 ETH. It was this, and not just me, a lot of people, this Adidas original by the metaverse. Every buzzword that you can think of back then, metaverse was a big thing. Now it's worth 0.1 ETH. There are only 2 for sale. One's worth very cheap. But when I was buying it, I paid $600 as tip to a validator कि भाई मेरी transaction को let through कर दो, because there was a limited supply of these. Only 10,000 of these were launched, and it was almost a given कि as soon as you buy, whoever gets the initial supply is immediately going to make more than $600. So it made sense to pay $600 as a tip. What if after verifying the transaction in the main chain, what if the receiver does not provide the goods? That's where escrow comes into the picture. Beautiful. This is actually mentioned in the BTC white paper. Okay, this way you've covered the buyer, but what about the seller? Covered the seller, but okay, because it's an irreversible transaction. If you go to the Bitcoin white paper, it actually doesn't really say governments are bad and currency is why I want to reduce BTC. It actually says the current payment system is very flawed because US में ज़्यादा होता है कि merchant fraud बहुत होता है, in the sense कि I might go to Shopify, I might buy something, I will receive the good, and then I will reverse the transaction. I will say this was a fraudulent transaction. So the seller receives a lot of problems. So if you read the Bitcoin white paper, it clearly says कि this way we were able to save the seller. कि seller के पास पैसा तो आ जाएगा, but अब buyer के पास कैमरा आएगा कि नहीं, उसकी क्या गारंटी है? This is where escrow comes into picture. That's what the paper also says. In fact, if you go through the white paper, Bitcoin white paper, the solution that they mention for this is escrow. Transactions that are computationally impractical to reverse would protect the seller from fraud. जो बेच रहा है ये तो पक्का है कि it is not like credit cards in the US कि you can reverse a transaction and seller की हालत खराब हो गई. And routine escrow mechanism could be implemented to protect the buyers. what you can do is you can put an escrow in the middle. मतलब एक बंदा बीच में बिठा दो जो यहाँ से कैमरा लेगा, यहाँ से पैसे लेगा, and then करेगा. What if the escrow is problematic? There's no end to this. Of course, then there's nothing you can. Oh, am I sharing my screen? I'm not sharing my screen. I'm such an idiot. If I share my screen, I show you the Bitcoin white paper where it says exactly what you were asking, which is transactions that are computationally impractical to reverse would protect sellers from fraud. तो जो बेच रहा है उसको प्रॉब्लम नहीं है. And routine escrow mechanism can be used to protect the buyers. But if escrow is flawed, then of course you're screwed. I mean, physical चीजों में वो तो रहेगा ही कि if the person doesn't provide you the goods, or if he said it's Canon but it's Nikon, or it's a copy, what can you? Nothing you can do. Why the less validators for Sol is a problem? So the thing is, Solana right now is struggling with validators because that is a whole different discussion we can get into. But long story short, proof of stake is what Solana has. It basically means you need to have a lot of Solana in the first place to be profitable on Solana, and that amount of Solana is really high. It's whatever, 20, 30, $100 million worth of Solana to actually make some profits off of it. If you don't have that much Solana, I only have $10,000 worth of Solana. If I start a validator today, I will lose that $10,000 in 10 days, and my validator will stop. Why? Because validators in Solana have to put a lot of voting transactions for which they have to pay gas fees, and that gas fee amounts to a very big number. So if you don't have enough Sol to be the block proposer in the first place, in case of Solana, you are a block proposer based on your stake. So if you see over here, Helios has the biggest stake, owns 3.6% of the total stake. So Helios is the validator, a lot of the times. They become the validator, 3% of the times of all the transactions, which is like huge. They make some $20-30 million purely based on their validator, not even the other things. There are a lot of nuances here. They say that the validator fee is zero, but there are ways they make money. Second is Figment. Third is this guy. What was your original question? Why are there less validators? क्योंकि वही है कि भाई power law बहुत बड़ा है. If you become a smaller validator here, very high probability you are starting to lose money. तो वो incentive ही चला गया लोगों का validator बनाने का. And there are validator incentivization programs that most foundations of Ethereum, Solana, BTC run to incentivize people to run validators, but eventually they do want them to be independent validators. It's just a harder problem. It will only be solved at the runtime layer if somehow it becomes cheaper to run a validator. Right now there's just a problem of you need to have a lot of stake to be able to become a profitable validator, which was not true for a lot of validators, and hence they had to stop. How can we get a seed, and how is the seed getting uploaded and stored that we seed in any Sol wallet? It shows address. How does that happen? We are going to cover the exact same thing in the next class when we learn about hierarchical derived wallets or HD wallets. Exactly what we're going to cover in the next class. Trust me, I'm not going to love this project. I don't love front-end heavy, extremely fancy projects. So थोड़े usable कम होते हैं. How are all these transactions concurrent around the world if there are so many miners? Could there be a point if we have different blockchains data due to some? That's what I said. That's exactly what a fork is. In case of Solana, block proposers, you become a block proposer based on a schedule. So there is a validator schedule based on which on this specific block this guy will be validator, on this specific block this guy will be validator. So forks are less probable. But 800 machines talking to each other is not as challenging a problem, every let's say 500 milliseconds. And someone might lag behind, might miss a few blocks, but eventually will catch up. A lot of times validators, if you run a very small validator on a smaller machine, you will see it's not able to catch up to the main chain. So yes, that does happen. But since you're not solving a puzzle, it's not random when a validator is selected, the leader schedule is out up front. There's less possibility of two people proposing a block because there's only one person that can technically propose that block. Hopefully that answers your question. How are all these transactions? Okay, answer that one only. Broadcasting the transaction on chain, is it similar to broadcasting messages in WebSockets? Sort of, but they don't use WebSockets like every blockchain. I think now Solana wants to use Quick as in their gossip protocol. I'm unsure what it used to use. Ethereum to nahi, but IPFS used something called libp2b, or made something called libp2b, which a lot of blockchains used for gossiping. For example, there's a blockchain, sort of a blockchain only can use it, called Subspace, that used libp2b for these machines to talk to each other. And libp2b can be the transmission protocol. There can be WebSockets, HTTP, WebRTC. So in the end, it's TCP packets that go from one machine to another. It's very close to WebSockets, but not necessarily to WebSockets hi honge. What does it mean by adding a block? Does every new transaction add the block? No. A block can have many transactions, so 20 transactions can be in the same block. If yes, then is the limit of no new blocks that can be added? No. Again, Bitcoin until now has 3 lakh total blocks. Solana has very high block, time, or very low block times and hence or slot times, which is why it has too many blocks. Ethereum again, proposes one block every, I don't know, 10 or 20 seconds, which is why Ethereum pay number of blocks is just, fairly countable. One block has many transactions. So this block had 448 transactions inside it. One transaction is not equal to one block. One block, for example, for Ethereum, this block had these many transactions, 400 transactions in total. Are these blocks similar to adding commit and repo? You can say that. Commits are append only. एक commit के बाद एक commit के बाद एक commit. Blocks are append only. One block, second block, third block, 2 lakh block, whatever this is, 24 million blocks. Can you please draw an analogy between GitHub repo keys and PRs and blocks? So where can we get the hash of the previous block? The hash of the previous block is transmitted, right? It's public only. Is block ka hash, this transactions hash is over here. This is not the block hash. I'm sure there is a block hash somewhere, here. Maybe there is no concept of a block hash in Ethereum. There you go. This is the block hash. So it's not just available amongst the miners. They can gossip amongst themselves and share it amongst themselves. It's also publicly available. So getting the previous block's block hash, whenever you receive the previous block, all the transactions inside it, you will go through all those transactions. You will update the balances of all the users on your machine. You will receive the block hash for the previous block. And GitHub PR also, they're append only. That's the only analogy. Commits are generally append only, even though you can go back and force push and there are PRs. I wouldn't say it's the best analogy. The only, parallel in both of them is they're append only. And blockchains where blocks are supposed to be append only until infinity. You keep adding more and more blocks. Can we have a fork inside a fork? You could. How can a validator choose a particular transaction, you mean? And who decides the number of zeros we need to find the hash increases? Why can't we improve the working of Bitcoin? A lot of questions here. I'll answer them one by one. A fork can exist inside a fork, but again, it will eventually get collapsed. Can a validator choose a particular transaction? Yes. As I said, in case of Ethereum and Solana, there is the concept of Bitcoin. There's this concept of a mempool, and the validator decides, the leader decides what to include, what not to include. There is of course a limit to how many transactions you can add. So you would probably want to pick the best 2000 transactions that give you the most tip. Who decides the number of zeros? I'm sure there is some proposal that goes through based on which finally decide hota hai ki the block time is going really small and blocks are being proposed every 2 minutes. So we should increase the number. It might be on a schedule also. I could totally be wrong. But if I had to assume, I would assume it happens based on a vote or whatever, a DAO vote that happens that decides the number of degrees. We should probably Google and see this. Can't we improve the working Bitcoin? You could. The thing about this happens over time, right? So Bitcoin got forked. There was a very big hack, and was that Ethereum? That was Ethereum. My bad. But people have opinions. Ethereum में ऐसा हुआ था कि some people proposed something else, or there was a hack that happened, and some people said the hack should be removed from the blockchain, which went against the ethos of blockchains in general, and some people said it shouldn't be removed from that specific block, should not be removed. So what happened was 2 different code bases teams and folks and networks of Ethereum became. One is the Ethereum Lite, not Ethereum Lite, Ethereum Classic, yeah. So there is like 2 Ethereums that exist right now. One is this, and then one is Ethereum Classic. I think Classic is the one that did include that faulty hack wali transaction. And these guys said, okay, that faulty transaction should be removed from that block should be removed, that transaction should be removed. So it can happen from time to time. People feel like people have opinions around BTC. Generally, there are foundations that dictate this. but there can be conflicts eventually when the blockchain becomes sufficiently decentralized, and then a lot of times people just generate other copy blockchains. In this case, Ethereum Classic, based on some developers going here, some developers going here. But to be able to propose anything, there are basically proposal docs that you can add, BTC proposal document, or an Ethereum improvement proposal, or a Solana SMD, SMD, I forgot. And then people can vote and decide whether or not it should be introduced or included, whether or not it's a good thing to introduce. And BTC में the activity नहीं थी, BTC Maxis field proof of work is still needed, and the only way your chain can be truly decentralized, and so they would never move to something more optimal like proof of stake. And same argument between Solana and Ethereum. Ethereum people feel Solana is not as sufficiently decentralized as Ethereum is. Because the computation requirement is so heavy, and the staking requirements are so heavy कि तुम ज़्यादा validators ला ही नहीं सकते. They will never move to a better architecture like Solana, because that's what they feel is the better architecture. तो वही है, you can propose these improvements, but based on a vote they actually get included or not. Does every miner have data of all the previous blocks or just a few parts of the blocks? That's a great question. As I said, blocks hold a lot of information. What every miner needs currently is, all the accounts ke balances at the very least, all the data that is being stored. They don't necessarily need the full history of, isne isko bheja. For Solana, that data is so huge that, most miners don't store all the blocks, but they store the current state. So if you look at all of our HDFC balances of, everyone in India, our balances is a much smaller number compared to the thousands of transactions that we have done. I have done, let's say, 2,000 transactions till date. That don't matter. What matters to me is my balance. So most of these validators only maintain an account state, which is, how much SOL does one have and how much, USDCs does one have. A lot of this data is stored in various accounts. That is present on all of these, miners. The block history, all signatures, transactions that has happened over the years, you don't need them included. Probably in a few years, the first initial Solana transactions will not be present anywhere because there's so much data. There's so many blocks over time. If you are to be able to mine, you'll have to display. Again, as I said, that's why you don't need a lot of space. Only a few validators can actually, run it. Ledger came from the miners, so no. Store all the previous block data, and if no, then where does the exact complete ledger or data of all block is stored to come back when a new miner starts? Again, the new miner asks another miner for the current big account state, that is, who has how much Solana, and that is it. Does not care about the full block history, just asks कि अभी state क्या है वो दे दो, and then a few recent blocks it reruns on it. जितनी देर में state आई, उसके बाद अगर 50 blocks आ रहे, तो on top of that state it runs those 50 blocks and is able to catch up to the current blockchain. It does not start from Genesis and rerun every transaction to be able to recreate state. That will just be computationally infeasible again for it. It will never be able to catch up to the current blockchain. Hence, it asks for the current state. I don't care about the history of blocks that came before you that led to this state. I don't care about Harkirat ka HDFC balance yahan tak kaise pahuncha. The inbounds and outbounds I don't care about. Just tell me Harkirat's HDFC balance and then everyone's balance, and that's all I need. Account state is copied over. History of blocks is, of course, infeasible to be able to copy. Validator, miner, same thing, different names. Explain the state change after successful mining validation and the transaction included in the beautiful question. How does the state change? Very different for everyone else. For BTC is very different, for Ethereum very different, for Solana very different. Simplest to understand for Ethereum. Ethereum balances are stored somewhere called, in a storage space called account data. So basically there's a hash map. This banda has this much Ethereum, this banda has this much Ethereum, and that state, changes in memory whenever you send someone Ethereum. Simplest part. BTC is a little complicated. BTC uses something called UTXOs, unspent transaction output. So what might happen is, I might do 500 transactions over the years, right? Now, when I'm querying my balance, it will be very hard to go through all the blocks and figure out my current balance. This was an interview question asked to me 2 years ago when I was interviewing at a company called Liquid or something, OX Liquid, OX, I forgot, OX Fluid, OX Liquid, something like that. Okay, how does Ethereum and Solana actually, store balances? So Ethereum and BTC, sorry, there was an Ethereum company. So Ethereum के case में it's simpler. They have two storage spaces, one for smart contracts. We'll get to what they are, but specifically our Ethereum balance is just stored in a hash map. In case of BTC, it's a little more complicated. In case of BTC, there is an in-memory variable or set or what a hash map that you contain that you have that just technically stores something called UTXOs or unspent transaction outputs rather than storing is user पे इतना balance है, user पे इतना balance है, it stores something else which is whenever you received some BTC. So if you go through the white paper, the BTC white paper, there's like one BTC can have, let's say whatever, 10^9 smaller BTC. So I can send you 0.0001 BTC. Each one of these coins has an owner. So if I send you one BTC, that would technically mean 10^9 BTC individual coins ki ownership change from me to you, which is like very hard to track. Which is why there is this concept of UTXOs that exist. These many input BTC came, 10^9 BTC came, and let's say I sent them to someone, so X were sent out and X were unspent transactions. If I have one BTC and I send someone 0.5 BTC, what happens is I send someone 0.5 BTC and I have 0.5 BTC of unspent transaction output, which is effectively what my balance is. तो एक बहुत कॉम्प्लिकेटेड तरीके से बेसिकली BTC बैलेंस स्टोर होता है, बहुत सिंपल तरीके से इथीरियम बैलेंस स्टोर होता है. Solana is very similar, but both Ethereum and Solana have this concept of smart contracts through which, or programs through which a lot of token balances are stored on chain, which is a whole different discussion of how it's done on Ethereum and Solana. Great question. Every miner has its own mempool, and if the transaction is broadcast to my validators, and one validator accepts it and includes it in the block and broadcasts it to other, and the transaction also checks if it exists in that mempool and remove it from there. Yes, was you explaining this or did you ask this? Explain UTXOs, I think I just did. At the end, every crypto token is going to tagged with country currency, then how it is not manipulated by anyone. I don't get what that means. And it seems like about price questions, so I'll ignore, and less of a technical question. Why is there? Okay, answer that. So if a super rich person makes 10 big farms, will he be the block proposer the full time? Because he has computation and he can do some shitty things. Yes, if you have 51% of BTC compute, sure, you can do whatever you want. You can remove transactions, piche jaake, basically reverse transactions. You can change the state of the blockchain. If you have 51% of the computational network, yes, you can do whatever you want. What is bull run in BTC? It's just, when prices go up, people say it's a bull run. Is it like Git? It is like Git VCS. I don't know. Maybe not. Here, tell me one thing that you said that every public and private key pair points an elliptic curve for new encryption algorithms. So pointed to the pair of key on the curve gets reserved that only pair, no other pair keys can get assigned that point. No, they can. So thing is, no, that's not true. It is very possible that you and I land on the same point and you and I get the same public private key. So when I run this command on my machine, SSH-keygen, it points to one point over here. You might run the same command. It can totally happen. Both of us land at the same point. Both of us get the same public private key. And if I got it first and I asked my friends for Solana and they put Solana in there, you'll be able to sweep that Solana. But the probability of this collision is next to zero. It's very low. Okay, two people, because there are like x to the power 256 number of public private key pairs, to the power 32 number of public private key pairs that can be created. Whatever that number is, such a big number. Okay, the probability of two people colliding is really low. But it can happen. And does then please tell something how it happens. So again, it can happen, and it's just you and I have the same public private key now. And if that public key has a lot of balance, then whichever one of us wants to sweep that balance can sweep that balance. And how they tell, let's say two people got the same key pair when what are the repercussions of it? Yeah, so the repercussions are you both own those coins then, and probably makes sense for one of you to just sweep all of the money from there because the other person could do the same. You both communally own that wallet then. Um, Harkirat, what do you think about the future of Web3 right now? For a dev in India, I'm seeing the market is quite down. Mostly companies foreign based. A lot of companies only hire research countries. That's true. Mostly for all niches. Same is true for AI and same is true for Web3. Probably a little less in Web3, but again in AI, the number of companies is more. So it's probably a better shot to get hired over there. But that's pretty much it. Uh, every miner has its own. Okay, answer that. If BTC is decentralized, so there is no one owner of this currency and no one party, can you misuse or regulate it? You can't. Wait, it's hard to regulate, but again, let's come to the question. The question is that these rules of BTC, that how to get mined, how to get validated and all, who gives that puzzle to solve to the miners? Who checks those rules are followed or not? Is the smart contract? So smart contracts as a concept doesn't exist in BTC. It's an Ethereum soul sort of concept. There is a code base, a BTC miner code base that everyone runs. Everyone is running the same code base, and hence there is nothing shady happening there. Who dictates that? The white paper dictates that. The foundation dictates that. They give the code base. Some other people might also, based on the white paper, write their own code bases. But everyone is sort of running algorithms that follow that puzzle. If you want to change that puzzle, again, the community can propose it as a proposal and tell okay, these are the benefits of doing it. And generally there are votes based on if I have X BTC, my vote counts X times. On whether or not this should be accepted. If it is accepted, then developers are paid BTC to be able to build that code base, and the transition happens from puzzle A to puzzle B, or consensus algorithm A to consensus algorithm B, or validator code A to validator code B. But these are all proposals that are introduced by research labs, by PhDs, by master students, by cryptography, whatever, professors. Okay, this might be something better. The proposal comes, it's very public. People can vote on it. Alpenglow, for example, is something new that is coming to Solana. I think came to Solana now, and it's running in a few validators already. And I think or probably switched completely in all validators. Which was again a project that came out of क्या है उसका नाम TU Munich, UT Munich, TU Munich University है बड़ी सी. Some professors over there and some students over there. They proposed it, people voted, people liked it, and that's how the validator code changed. So people can propose a new change, but BTC has been working for many years, doesn't make too much sense to change it. It is what it is, and it does solve a very bad puzzle, but it's just accepted and no one's proposing an improvement on it, and if they are, it's not getting accepted. And the same might be true for Solana and kal ko kuch aur, some other blockchain might come that might solve something better, and Solana might not move to that because they have their own reasons not to. The same is true for Ethereum could have done 10 things to make it faster, but it didn't, and Solana ended up doing those things, and Ethereum had its reasons not to move to those new code bases, those new whatever algorithms, those new architectures. So you can propose, but the voters or people can decide whether or not to introduce that proposal. Alright, it's 11:40. It's a long class. We'll try to stick to 2-hour classes from now on. But hopefully it was an interesting class. Hopefully you learned something new. Now I'll see you guys next week when we get a little more into creating wallets, receiving balances, updating balances, DevNet, so on and so forth. I'll see you guys next week, folks. Have a good night. Bye bye.
So basically the lecture or the session today we'll be talking about the whole course of AI, of how it started, when it stopped in between, there was some time, and then what happened before we discovered transformers and what was stuff before it, because we directly didn't end up on coming to transformer. But to say pehle bhi, I think we have a lot of sequence model like RNNs. Before that we have statistical models, and before that I think the most basic things were rule-based model. So before I start this, I think we all should start from this very first question, which is, okay, I cannot, yeah. What does it mean to learn? I think I should open chat for this. Okay, my screen is stuck, guys, sorry. Yeah, what does it mean to learn? I'll open the chat and I'll look at some answers. so we can move a bit intuitively. Can you guys mention what does it mean to learn? I don't see any messages here. Yeah, basically right. Understanding patterns. I think if we look at our lives, we if we had to learn how to ride a bicycle, we first have to experience it. I think we might fail a couple of times, but the final thing would be we might end up learning something. So it's basically changing ourselves based on some experiences. Like we try something, then we change according to it. Like how does I move? How should I push the pedals? And how should I control the handle? And all of these things. If we are talking about bicycle, but this can be applied into all of the things we ever learned or we are going to learn in future. This is the basic concept of learning, and from these very basic concepts we'll get onto the more, I think, niche topics like machine learning, artificial intelligence, deep learning. But when you look at it and you go back to these same questions, you'll able to understand that these are very fundamental things that we just somehow programmerize, and yeah, it looks good. So basically, yeah, learning is a loop. We try something and then see what happens. Imagine you are learning to ride a bicycle. You try riding it first, you might fall off. You see, oh, I fell off. That's a feedback. So you are getting something in back in the reaction from the action you are doing. So it's like you are getting a response, which is, I think you all might have done or heard this in physics that for every action we have a equal reaction. This applies here too. If we are doing something, we are getting an answer or a response in as a feedback from it. Based on that feedback we adjust ourselves or our habit or anything, it can be literally anything. Based on the feedback we change it, and if we do it for, I think, long enough time, we'll be able to, in case of bicycle, understand or learn how to ride a bicycle. If we are talking about learning machine learning, if we do the same thing and apply the same learning loop over there, we'll end up learning some part of machine learning which we are focusing on and getting a straight feedback from. So this is the whole concept of learning. You learn basically experiencing, then getting a feedback, adjusting yourself, and then repeat karna. This is very simple. I assume you guys might be able to understand it. Let, Give me a thumbs up in the chat and we'll continue. Sounds good. Okay. Yeah, thanks for the poll. Sounds good. How do I get rid of this poll? Yeah. Then comes the next question. What is knowledge? What does it mean to know? Again, the same thing. Knowledge is basically you get information of something, and there's two type of knowledge. One is explicit knowledge, one is implicit knowledge. Explicit knowledge is, yeah, it's something which you learn from rules. So if I say that the capital of India is Delhi, that's explicit knowledge because we have a defined rule, or you can say fact for it, because we can say that and it is not wrong. The capital of India is Delhi. This is known as explicit knowledge. Implicit knowledge is completely opposite. Like if I ask you, how do you remember the face of your friend? You might not have a direct answer for it or a set of rules which you can say, like, okay, his face shape is this, his eye shape is this, but you cannot be very definitive of it. It is something you learned from experience, or something in your brain changed, some patterns matched, and you know that, whenever you see your friend, that okay, he's my friend because some pattern matched and you can recognize him correctly. So these are basically two types of knowledge: explicit knowledge and implicit knowledge. Based on this, we'll build some concepts later. Now comes the, I think, greatest question in philosophy, in, I think, human, mankind, whatever. What is intelligence? Intelligence, I definitely, there's no, I would say, an exact definition for what intelligence is. There's a lot of debate going on in this, but it's basically an ability to, perform good in a very wide range of activities or situations. Like if I give you an example of calculator. It is very good at solving arithmetic questions, but do you call it an intelligent device? Yeah, we do not call it an intelligent device because it is just good at a very particular skill, but on the in all the other skills it's not, like it cannot even perform any basic things. But if we talk about us humans, what's different there? We can learn some sort of arithmetic, we can learn some sort of development or DSA, and then we can say calculus on all of that. So we have a very wide range of, catalog to learn from, and ability to achieve or ability to learn these wide range of things, I would say, is intelligence. So this is the whole idea of intelligence. Now, what is AI? AI is artificial intelligence. We want to somehow make this the, I've already defined what intelligence is. So basically, we somehow want to transform this in a way that computers can understand, or can be intelligent. So they can also be good at a wide range of tasks and not just particular stuff which rules can be defined for, but very general stuff like making good jokes, understanding sarcasm, answering your basic questions. It can be, yeah, any questions, like you can chat about literally anything now with ChatGPT. So that was the idea of artificial intelligence. Like, how do we make that happen? Now let's get to the goal. The ultimate goal is artificial intelligence, and in there comes machine learning, and in there comes deep learning. So these are the subsets of AI. Basically, what AI is, I've already talked about it, making machines intelligent to do something like humans. It can be recognizing faces, playing chess, driving a car, understanding the language. But you can see it's a very wide range of catalog and not just a particular thing. So, as we already talked about, what was the first thing, or what is the first thing that would come to mind of, you can say, people living in 1950s, 1960s, if they want to make machines intelligent? I think the first thing that can happen is, writing rules for stuff. As we defined explicit knowledge, like the capital of India is Delhi. So we can write these set of different rules. Like if an email contains some specific keywords, you can list it as spam or important. If the temperature is above a certain degree of Celsius or Fahrenheit, you can consider that as a fever or hot or cold. If a, if a chess piece moves a square, and how does a rook moves, how does a horse moves, and all of that, we call these rule-based systems. So this was the first attempt in making artificial intelligence or making machines learn. So do we get that? Let me open up chats. Great. Yeah, I think we understand what the first thing we did in AI. So that was the literally the first thing we any human can think, or you can literally ask anyone, like, how do you make machine intelligent? We'll say, like, let's write 100 rules for something, and if that system follows that rule, we can basically call it intelligent in the field for which we have made the rules of. So it kind of gives a sense of making something intelligent, but is it really, or is it really intelligence? Like, does our machine really understand what this specific keywords are, and why do these specific keywords make an email spam or make an email important? No, right? So this was not the ultimate goal, or this was not the oracle of AI. So yeah, research continued, a lot of stuff happened. So we have already discussed the rules and what are the problem with it. Like if I ask it to understand a sarcasm or understand a joke, it cannot, because we have simply listed rules for what is good, what is bad, what is spam, and what not. So it would not be able to understand any contextual meaning of the sentence or anything you write. It would not be able to recognize face, because let's say you build a face recognition system based on rules. The max you can do is that the length of the eyeball is this, he wears specs, the hair, the shape of the hair, and all of that. But in सबके बाद भी we cannot literally make a system just based on rules which will be able to recognize a face. That is completely out of yeah, it is complete and impossible situation in this case. Moving to attempt 2. So what if, let's not make rules, let's start with data. This is the part where machine learning as an idea first emerged. What if we give machines or computers a lot of data? It can, let's say, weather data or email data, and let it, do statistical based learning, which means that the more the word appears, it sees what it is followed by or what it follows, and based on that, it try to get a sense of what's really happening and what should I do in the situation. So we show these machines, a thousands or a 100,000 of examples in a certain field or different fields, and what we expect them to do is that from this data, without us explicitly programming anything. So this is the field, like we are already into machine learning. Basically, what machine learning is, we do not want to code or write stuff or write rules explicitly, but we want the machines to internally write rules for itself based on the data. This is the whole idea of machine learning. So let's say, yeah, we'll get to this later, but you get the idea of machine learning, right? We have a lot of data. We have to do a certain things. Let's say the weather data contains that 100 degrees Celsius hot weather. So whenever the machine sees that, oh, the temperature is above a certain threshold, that means it's going to be a hot weather today, and all of that. If it is an email classifier, if we see like free money based on them, it is followed by some weird link, then it's definitely a spam. Or if it sees a meeting link with time and attendees names, it would consider that as an important thing, because based on statistics we know that these things follow under these category, these things follow under these category. So we kind of make a bucket, and in there the AI puts the input based on the data we have trained it on. This was the idea which machine learning started on, and it is, yeah, the it would, I think, the definition of machine learning still today is making machines understand something without explicitly writing rules or typing code for it. Cool. So how does machine learn? We have gone, I think, a bit into it. We show machine example. Machine takes a random guess at start. We tell it if it's wrong, if it's right. It takes the feedback, adjusts itself, and repeat this process millions of times. By the end, we have something which is not as intelligent, but it has some sort of intelligence in it. You can call it intelligence, you cannot, but it has some sort of understanding of some words which are followed by something and not. So it would, based on this, I think at that time this was a great achievement. So statistical models, I think, yeah, they were all the craze. I think Google were relying on them for a decade. So yeah, this idea really popped up and was used in industry a lot. Cool. So yeah, if we look at the whole, diagram of what AI is the ultimate goal, which is to make machines intelligent, under which falls machine learning, which is to learn from data and not write the rules and not do any of the stuff, or with as less as, I think, human involvement. So yeah, not just based on data. Let's make machine learn. What is deep learning? Deep learning is a subset of machine learning which deals with neural networks. You might have heard this term a lot, that all the new models are based on something called neural network or transformer. These are the, I would say, the smallest unit of these big systems. So that is basically a neuron. It is designed to mimic our human brain, where we have neurons which get fired up when we listen an action or see an action. Based on that, this field, the deep learning field, is the same thing, learning with data, but in here we explicitly rely on neural networks. Is this clear? I'll open the chat. Yeah, chat is open, guys. Good, great. Let's continue. So we'll see what some of these early success was, which I just mentioned, that Google started to use statistical models a lot in their systems and a lot of other enterprise-based solutions. So early ML was looking good. We all came from, nasty rules and came up to something which we can learn from data. And I think the idea back then was that field by field we can apply this formula everywhere, and at the end we'll have a unified machine which is good in weather prediction, email classification, or destination planning, or all of that. So what worked was spam filter got better, recommendation system like Netflix, Amazon, Google search became better, image recognition became better since we can, look at some features of an image like distance between the eyes, the face, the mustache, if it's a cat. And based on that, we can easily classify something, not with great accuracy, but better than what we have before. And we are talking, not the 2000s, but before that. So this was still a popping field, and people got all excited for it that this one day would solve, all the agonies of human, and we'll end up with something better, something more practical. A machine likes ourselves, so we do not have to do the ugly work, and we can just sit and relax and make these machines better. But you can still see that this had some bottleneck. It cannot have a conversation with us since it's relying on rules, not rules. It's relying on statistical data. It cannot form its own sentences or articulate something for us. So that was not happening. It cannot understand if I'm writing something because it is basically just saying, if I give it a whole paragraph, it would just see some keywords, and based on them, if it had seen them on the training data, if they were, good in statistics and they were ranking high ranking keywords, they would understand that. Other than that, the whole paragraph would be left unattended. And also, it couldn't recognize most of the objects for which we did not have enough data for. Because I think we are talking about at early 60s or 70s, internet was just popping off. There was not a lot of data on the internet, so we had some issues with data. Again, these machines, still they are so dumb, they needed a lot of compute was not available back then. We had some bottlenecks. The field was, plateaued after a bit of time, but people were really hopeful. They were raising a lot and betting on something which was not happening at that time. But if we see today, a lot of stuff has changed. So we'll see what happened. Why early ML was limited? I've already talked that there was not enough data, not enough compute. For deep training, computer needs, a lot of memory requirements, a lot of neurons to work on, a lot of multiplication they do in their inner, yeah, inner mind, you can say. So we did not have that back then. There was no GPUs back then. We were training just on CPUs, which are not that fast or efficient for this kind of mathematics. And the data was also a problem since internet just started up. We did not have these big archives of stuff, so we were lacking a lot of things. The field was not making a lot of sense since data was the only thing we still rely on. But back then it was almost zero. So what happened, I think people lost all their hopes in machine learning, and AI winter striked. AI winters is basically that when the hope completely died in 70s, the first collapse happened. A lot of funding was pulled off from these different startup of companies which were trying to make these statistical model better. Since there was no data, not enough money for compute, and not, I think, not good compute was available at that time. The first collapse happened. People pulled out their money. There was a lot of buzz going around that it is a dying field. It would not last long, and everything was shut off. It was like almost dead. Other than that, some part of it was still working, which again busted because experts were backing off from it. The research was not getting anywhere. So everyone was like, okay, this is not working. This is not the right field to put our time on, and we should find something else which can, solve different stuff for humans. The field became a joke. So everyone was like, yeah, leave it. It doesn't matter. But if you look at today's scenario or after 2012 or 2010, what happened is the internet has blown off. We have a lot of GIFs, videos, images on the internet. So you can see, and with that, a lot of text information on the internet. So you can see one of the major problem got solved. The data which we did not have back then is now available for free on the internet. GPUs came up, Nvidia, you can say the market leader was popping off, building these large GPUs for us or for researchers or for labs or for companies, which can power these very minimal mathematical multiplications, but at a very fast speed. Researchers finally cracked deep learning. It started off with CNNs, neural networks working for images, and all of that. So these three things happened and are still happening, which was the reason that the field is currently booming a lot. There's a lot of data in the market, which, if at the current time, if we talk about, we can argue about it that the data is almost over or not. But yeah, it's still an ongoing debate on that topic. But you can see from earlier 70s, 80s, a lot of problem is solved. We have the data, we have the compute, and we have the algorithms which can make machines intelligent. So we bet on it and see what happened. From now, I think we'll focus on language as it was the first thing intelligence actually emerged on. Yeah, after Transformer, we can say it was able to understand us contextually. And before Transformer, also, we had some successes which were not, as big as Transformer, but still led us to Transformer. So before I dive into that, I'll just see chat for a bit. And yeah, let me know if it's all good and we can continue. Use polls. I don't know how to use polls. Yeah, here they are. Thanks. Yeah, I heard that images. I would like to learn about images. What happened is, yeah, that's good. Most 90% of the people understand here. So yeah, I'll talk about languages for a bit. Images for a bit. Sorry, yeah. I would talk about images for a bit. So what happened before language, or you can say transformer, we had something named as CNNs, which are convolutional neural networks, which we'll talk about later in the session or later in later lectures. What it basically was that it was an architecture based on convolution. It is a mathematical function which basically help us convolute a matrix, and it was able to understand images. So what happened was image field boomed. Jan LeCun was the first one to design these CNNs, and the first thing they were able to solve was captchas. We can easily pass an image of captcha and get the desired text out of it. Images were working, but again, there was no context of like if I pass an image to the model or the CNNs, I would not be able to get a description of it because the image did not have any description or any context for it. It was just a classification, and that's why that was not real intelligence. What it really was that we gave it millions of images and 10 classes like man, woman, dog, cat, and asked the model that your goal is to classify these 1 million images into these 10 buckets. And when the model was completely trained, we can use it, we can pass it an image, and if that image was in these 10 buckets, the model will be able to classify, otherwise not, it would fail. So it basically dependent how much data you have, how much distinct data you have. So the more the distinct data, the more the classes you can make and the more classification you can do. So it was not really understanding but or intelligence, but it really gave us some hope that yeah, there's some architecture which you can try out and still research about. But CNNs quickly, I won't say quickly died off. There was an ImageNet dataset, which was, I would say, in 2012, one of the biggest thing that happened from Stanford. Andre Karpathy, if you heard, was the contributor of it. So it has 1 million images from all of the internet with, I would say, 30, 40 class. I don't know exact number, but a million images with 30, 40 different classes. So it was able, the challenge was to classify and make the best classifier out of it. So the stuff that happened was, yeah, some side story is that people from the University of Toronto, I would say, yeah, Ilya Sutskever, Alex Grzybski, made AlexNet, which was basically CNNs. But what they had was access to a lot of compute. With that compute, what they did, NVIDIA basically sponsored them for this, and they scored at the top of this challenge. And that started the whole boom of this industry. And people were really looking and were hoping that something is back. And people started to research more on languages and images to see if we can fit the same mathematical formula of convolution into languages, or we can make it, much more reliable, and can we somehow pass context to it. And all of that stuff happened. So you might all have heard about the paper "Attention is all you need." That basically gives us transformer, but that is not the whole thing. It is the paper only gives us the architecture of transformer, but the main part of that whole architecture is something we call attention. The the core idea of attention was given an year back into a different paper from Bahadno, and it's called as Bahadno attention. And from there, the guys from Google picked the same idea and put it up in Transformer to basically make the context understanding better. We'll get into it, but yeah, this was some side part if we want to talk about images, sorry. So we'll move to languages and we'll see why it is very hard, or why it was very hard to end up becoming or end up making something which is so good on languages. Why is language hard for computer? If I ask you the question, I think you let me start with an example. Yeah, I saw the man with the telescope. So we can easily understand this sentence because yeah, we are humans. Machines are not. They do not see words as we see. They just see them as some random numbers in their memory. So it's really hard for the machine to understand what this sentence is saying. Who had the telescope, me or the man? It doesn't understand, the basic difference or the basic context of what's happening in this sentence. Computers need precision. Yeah, like computers are messy, ambiguous, and works with a lot of data. We cannot have a single system work for it. So this was we can simply just look at any sentence in the world and see that okay, I realize why it's so hard for a computer to understand language. Oh yeah, one fun thing. You guys might have seen the topic of today's Zoom webinar is fast tracking the AI course, for which some people got diverged and was like, okay, why are we doing fast tracking the AI course? Are we completing the AI course in one go or an else? But what I actually asked, the person to create the webinar, I asked them to name it as the name the title as fast tracking the course of AI, which would basically mean that yeah, we're going through the how AI evolved over time. But they just replaced AI and put it in front, and that changed the sentence completely. It made the context so different that we were so confused. So depend like you can simply see that if us humans can get so much confused with just a single word moving before two words, what about machines? They do not even understand what words are. Do we understand that? I'll open the chats. Great. I'll learn to how to open a poll next time, guys. Sorry. Great. Okay. So we are now working with languages because we understand how hard they are to work for computers. The field is known as NLP, which stands for Natural Language Processing. Like if you guys want to look up later after this lecture and understand more about NLP or languages or how intelligence work in languages, you can simply look at NLP, which basically starts from very history of how computers were, how languages was, first seen, statistical models and all of that, n-grams models. But the field is known as NLP. Basically, NLP is natural language processing. We'll go thoroughly through four different aspects of it, like how it ended up on Transformer. But to start with, I think we can what if we just put up every word in the dictionary and make something for it so the models understand that apple is a round fruit that grows on a tree and is red or green and has a crunchy or a crispy flesh. But the problem with this thing is you can see the two examples here. Apple is a $1 trillion company. Apple is a fruit. Apple is a famous record label. Everything changes with the context. Now this Apple is a $1 trillion company, and this Apple is not the same as the definition. It's completely different. So can you fit it in here? And can you see why it was hard to work with language? Because it completely changes with the context. Apple is a famous record label. Again, it is a name of a label, not a fruit. And in here, the model only knows about fruit. So the dictionary approach fails. We can simply see that. Next, we talk about statistical pattern, which worked for the very long time. I would say if a temperature is above X degree Celsius, then it's hot, or it's not hot. It can basically understand this from a lot of data. If we pass it a lot of random text from the internet, it would see that if York is followed if New is followed by York, and that makes of New York, it would end up learning that it is a name of a city, which ends up happening or coming up a lot. uh, Sorry, there was a message. Yeah. So it will end up understanding that okay, these words come so often, and most of the time they're referring to some kind of an event happening there, or some kind of elections happening there, some constituency changes and all of that, and it would basically get on a conclusion that this is a city, and this would happen after a lot of examples, a lot of that learning loop. But this is based on just statistics, not anything. Google Translate use this a lot. we can easily translate stuff based on statistics, because most of the stuff directly matches to different language based on the statistics, because the more the word appear in a language, the more the word appear in the B language, and based on that we can compare any of these two different languages and put them, just based on the statistical mapping, change the order of the words and change the language of the sentence. Cool. So what happened was, we understand that words are very hard for machines to understand. They literally do not know that there's something in the world known as word, because they are just working with different pointers, different very low precision numbers, sorry, high precision numbers. So it just, words literally make no sense for them. So what if we can somehow transform these words or different, tokens, I would say, into some kind of number? This was the first breakthrough. I would say the word to vec paper was the first thing to bring this to a wide audience, that we can transform words to different type of vectors. Vectors are basically just a list of different numbers. So you can see that in this square bracket we have different random numbers, which are 0.92 minus 0.14, 0.005, etc. So what if we can transform all the different words into something like this? And in this case, what we are doing differently is that this apple would mean completely different for the fruit and would mean completely different for a company or a label, just based on these numbers. And how can we do that? Again, training on a lot of data, but how do we do that? But yeah, so how do we change these words into such numbers or a list of numbers? Basically, these are known as vectors. And again, we'll see that Apple, we do not just directly work with words, but with tokens. Tokens, you can for now understand them as full words. But if we go into like big models, they are a lot different. They can just be a single letter, or just two letters and all of that. They are based on different type of, like OpenAI have these tokens differently, Anthropic have them differently. Different companies follows different architecture or learning algorithm, and based on that they have different vocabulary, and based on that they have different tokens. But our goal today is to understand that how do we transform these words to numbers. Oh, yeah. Word embeddings. Basically, transforming any words to its vector form is known as converting them to an embedding. So in here, I've mentioned that the word apple is zero point 0.9 minus 0.1, 0.05. What does it really mean to actually transform a word into something? What it means is that are these numbers are different points in a very large space. So understand that we have this 2D space, like palm of, like this, and the word apple, if it's zero point 0.9, let's say it's somewhere here, then that means it's very high on this axis, which means that, let's say this name of this axis is red or color red. So we know that apple has red color. It would end up being very high on this axis, right? If we talk about shape, and let's say this is the square shape, we know that, yeah, apple is definitely not square, so it would end up having a very low score. What this means is, I've just talked in like 2D dimension, right? So this is in hundred thousands, like 64,000 or 128,000 different dimensions, and it can mean a lot of different stuff. But just to understand, you can just look at it, that if the color is red, it is very high for an apple. If the shape is square, it is very low for an apple. And based on this, these different numbers represent different meanings in different dimensions. This is the easiest things you can, guys, like each number represent a specific dimension, and each dimensions represent a specific meaning, and these meaning change as the sentence continues to grow up. Cool, you get that? I'll see if I, yeah, again I'll open the chat. Yeah, it's hard for you guys to, come and chat again. But let me see. Let me just look at how to open a poll. कैसे करते हैं?
अरे तुम खुद ऑडियंस हो भाई, अभी ऐसा बट माइक इज क्रिएटिंग इट, ये थोड़ा कम है एक्चुअली, 90% इज गुड, इट इज ऑल्सो नॉट बैड।
Okay.
बुलाइए।
Okay, yeah. So again, I'll go what it means to change a word to an vector. Let's go to xCalibro and I'll show you. I think this would be a lot better. Let me move this here. Okay, so let's say the word apple. We have to transform this into a list of random, you can say, point 0.9 if the color is red, minus 0.01 if the shape is square, and a lot of different dimensions. Let's just talk about two over here. So what this means is, let's say we have this and this. Okay, this basically means how red it is, and this basically means how square it is, right? So for an apple, if I ask you, like, where would it stand on this red axis? It would stand somewhere right here, right? Because an apple can be red or is red most of the times, can be green also, but let's just talk about an apple being red. And if I talk about different dimension, which is basically representing the square shape, what do you think will happen there? It would basically, be very low. This is 0 or 0.1 would somewhere be here. So this basically tells us that yeah, the square shape does not align with apple that well, but the color red aligns so well with the apple. This is this was a very big breakthrough because now for every word in based on the sentence we can do different stuff. Let's say if it's a cat, we can have the same access with an anim. Okay, let me how do I yeah, if it is a cat and if we have this axis of animals in there, if we see if it's a cat or not, that's again the score will be very high, else the score will be very low if the image or if the word is dog. So we understand that. Okay, so same thing is happening here for the word apple. 0.9 means red, so it is red. We know that the color of apple is red. Shape is square, that is not happening. Apple is not square, and that's how we can transform any word into a word embedding. So like now what we have is, instead of us passing just a word which is non-existent to a machine or a computer, we have something in form of number, and those numbers have meaning. So like these numbers are not completely useless, but they actually define what that word is composed of. And now this list of words which we call a vector can be passed down to a machine. So we have like a mapping between words and vectors. And these vectors can now be passed down to a computer because computers work really well with these different numbers. Cool. Yeah, if we see here, we have three different words, king, queen, and apple, just to give you more, clarity on these, converting a word to an number. So if let's say the dimension we are talking about is royalty, we know king is a royalty, queen is a royalty. The scores for them are 0.98, 0.97, which are like almost 100%. And the gender for if we see if, and here if the dimension is male gender, we know that a king is, yeah, the king is male, the queen is female, so the score is very low for the queen. Edibility, like is it something we can eat? Can we eat king? No, the score is definitely going to be low. Can we eat queen? No, the score is definitely going to be low. If we talk about apple on the same way, is it a royalty? No. Does it have a gender? No. Is it edible? Yes. So based on this, you can easily understand that any word can be transformed to a list of vectors, a list of numbers, and these numbers have different meanings in these very big dimension spaces. We are just talking about 2 dimensions or 3 dimensions, but in general, in practice, these are thousands or different dimensions. This is how we define a meaning or attach a meaning to the word using different numbers in different dimensions. I hope that is clear. Can we do a poll? Yeah, the score is much better now. Great. Let's move ahead. So we see that these words makes a lot of sense. We can easily convert them to numbers. Now comes the fun part. What can we do with this words being transformed to numbers? Like what happens now? We got the meaning of the word. But what can I do, right? मैंने ये सब कर लिया, अब मैं क्या करूं, इससे फायदा क्या हुआ? So if we see that king and queen are placed assume this as a very big dimension space, or n dimensional space with difference of meaning each dimension is containing, but we are looking at a very simplified diagram of it or a simplified graph view of it. If we look at here, we can see king and queen are placed very close to each other. Man and woman are placed close to each other. And apple and orange are placed close to each other, but very apart from king and queen. But on the other hand, if you see, king and queen are placed very near to the man and woman. What this tells us is that similar words are close together. And if you can somehow see that the relations are also close together, that king is a man, and it's if you just move down in this dimension, right? If you just move down, let me yeah, if you just move down in this dimension, you would end up it would end up telling us that okay, this king is a man. And again, if we move it down in this direction, it would end up telling us that okay, queen is a woman. So we can say that based on this, the lower dimension or this arrow is the dimension of gender. And based on this, we can, for any word, if we go down in this dimension, we can determine its gender. Cool. Okay. Yeah, let me clear these annotations. Okay, visualizing birds. Again, we have put them close to each other. If you see, apple and orange are close together, car and bicycle are close together, cat and dog are close together because they are similar words. Cat and dog are animal, car and bicycle are vehicle, apple and orange are fruits. But if you see at the top here, we have Apple, which is in corporation. You can say, like, right, the Apple Corporation, from which we have MacBooks, iPhone, etc. This placed differently from everyone else because it does not, yeah, it is not closely related to any of these. Even though it is the same apple, you can see that this means completely different thing because this is the apple which is relevant to corporation. So this is how we can define different words, different meanings, and then these words can be transformed to different vectors. These vectors have a lot of numbers in them, and each number defines different meaning in different direction. It can be gender, it can be color, it can be shape, it can be size, it can be literally anything. There are like hundred thousands or millions of the dimensions, and we cannot really think about what kind of different meaning it is composed of. But we can simplify and understand that okay, this is how the stuff is happening in 2 dimensions or 3 dimensions. Cool. Okay, I already have talked about this. The magic of embeddings. Like we just saw that if we move down in a particular direction, we were ending up on learning about the gender of that particular bird. The same is happening here. Let's say I know the vector for king, I know the vector for woman, I know the vector for man, and I know the vector for queen. So what we are doing here is known as word math. We have some word attached. We have some vectors or numbers attached to these different words. What they are really doing is that this king is something, it can have ABC vector. Like it can have a vector which contains ABC. Same for man, same for woman, and same for queen. If you see what is happening here is king minus man. If you think about what's happening here, they're minusing or they're subtracting the gender and removing the gender man. And what they are doing is adding the gender woman. So what happens if you remove the gender king from if you remove the gender man from a king and add woman to it? You can see we end up having queen, and that is very fundamental or easy thing to understand. Same goes here. If we have Paris and if we remove France from it and add Italy to it, what's happening here? We are removing the capital and adding a different stuff to it, and it would end up giving us the capital of that stuff we have added. If we add walking and remove walk from it and add swim, but we end up having swimming. This is word math, and it literally opened a lot of doors in the field of AI, or in the field of machine learning. Because with this simple calculations, we can understand different meanings for the words which we have not even trained on. And just based on these very high dimensional, matrices or graphs, etc., we can easily end up learning a completely new different dimension, which was not even in the training set. And it would end up teaching us a lot more than what we have trained on. Cool. Again, we are still having this one single problem. If we look at these two sentences, I went to the bank to deposit the cash and I sat on the bank of the river. The word is same here. Each word has a single vector attached to it, but these vectors are not talking to each other, or these different vectors like sat vector, on vector, the vector do not know about each other, or if they are used together, or if they are not together, they do not know about them. They just know that okay, I am went, I am bank, and this is what bank means. And yeah, just that. it would not be able to understand that in these two cases, Mang is completely different thing. So we can see that we have solved a lot of problems. We can understand, we can teach machines at least what word is or what a single alphabet is or what it comprised of. And somehow we have given it some sense of understanding that okay, we are making some progress, but okay, in sentences, this still does not work. It's good to classify different words, it's good to classify different genders or anything like that. But when it comes to, talking, conversation, or sentences, it is not working that well because it does not know what word it came before or what word it came after. Even if it knows that, let's say, it would not, completely understand that, okay, what if I comes before a river? Let's say bank is coming before a river. Okay, I'm coming, but then मेरे को फर्क नहीं पड़ता बैंक कह सकता है ऐसा if it's just because bank is just a single meaning or a single vector and river is just another single vector. It doesn't make sense for them to correlate without us doing anything, right? Makes complete sense. The idea is to process the whole sequence. If I have the whole sentence, I would process hi, my name is Rishabh, and all of these would be processed in a sequence. This was the first idea. A research started on it. The model or the area of this research is known as sequence models. It has different kind of stuff like RNNs, LSTMs, GRUs, and then we can also list down transformer as a sequence model, which is the most advanced stuff that has happened yet. There are other divergent fields like Mambas and etc. But those did not really scale well or had a good effect on the overall enterprises or general public. So we have basically RNNs, LSTMs, and these stuff. We'll enter transformer. I would say with some of the intuition from sequence model. But before we start, let's just do another poll to see if everyone's catching up to it. Okay, let's go back a few slides and start that. Okay, so I assume we easily understand that from the last poll that okay, close words are related closely and different words are not very close to each other, but somehow the meaning is contained. And if we move down or if we move, in a certain direction or a certain way, we end up on a different word, and that dimension is basically a meaning which we are moving towards. So, like, again, let me annotate. So let's say I have this king, and if I move down from here, I'm ending up on man. What does this tell me? That king is somehow related to man, and we know that this relation we can name it as gender, right? Because man is a gender, and we know king is a man. So this dimension we can refer to as gender. Again, we cannot based on just single point we cannot explicitly say that, but again we can see that queen, if we move down in that same dimension with the same amount of data or the same amount of length, right, we are ending up on woman. What does that tell us? That these words, without explicitly trained on something, just trained on data, retain knowledge that tells them okay, close words stay close, relative word relationship stays close, but different words like car and bicycle are not anyhow not related to king and queen. They can be in very long dimension as their vehicle or stuff like that, but right now they are not. So this dimension tells us about gender. We can do similar things for like cat and dog and different stuff and different kind of mathematics for it. So this tells us something like that. Again, if I show you, right, let me clear these drawings first. Yeah. Again, if I show you these examples, let's look at them again. King minus man. What am I doing here? If I remove king, if I remove man from king, what is removing here? We are removing the gender, right? And if I add woman to it, what are we adding to it? We are adding gender, right? So we removed the gender male and added the gender female to king. What is king? King is a royalty, right? King and queen are royalties. If I removed male and added female to this king royalty, what does it end up? It ends up on queen. That's very intuitive, right? We are just doing basic addition and subtraction. Again, for capital and cities, capital and countries. From Paris, I'm removing France and adding Italy. So what is happening here? We're removing capitals and adding different country. What would happen here is basically it's like India minus Delhi, plus Bangladesh, what would that end up on? It would end up on Dhaka, right? Because that's the capital of Bangladesh. And these words with the meaning of, these different dimensions we have talked about somehow compose the meaning of these capital cities or countries. And when they are subtracting from each other, they move in, complete different direction. So like this is king. If I minus man from it, it would remove this vertical axis we saw that, which was gender, right? And it would remove that. And then we are adding woman to it, it would add the female gender to it. So what is basically happening is we are removing male and adding female. And in what we are adding it is basically king is a royalty, and we know the female of king is queen. So that's how we do the word math. I think this should now be understandable. Can we do the poll again? Great, yeah, cool. Think I learned how to do poll. Yeah, I see them now. Cool, I'll do the polls from now on. Okay. So now we know that we can understand a single word completely, or understand the meaning of a single word completely, and do some basic arithmetic operations like addition, subtraction to it. But what we cannot still do is like we cannot understand the complete sentence or form a complete sentence and stuff like that. So what is the basic thing we can do here? What if we process each word, each what if we process the sentence word by word, since we know the meaning of each word, and somehow make a system which keeps the memory from these previous words and adds them to these upcoming words. So now if we look at this thing like I went to the bank, how we are processing is the first word comes in I. We know there's a vector for I, and that fires up. Then comes the word went. The word went also as a vector, and that fires up. But previously the I vector would now somehow be in the went vector. We compromised of it. We can basically simply add it for now. Then comes the word two. We add the vector for two into the previous two words, and then we have this new vector which is comprised of these all three different words. And then comes the next word, then comes the next word. And based on this, if you see, if we now come back to the same question, can you see that have we solved something? I went to the bank to deposit the cash. What's really happening here is as every word is getting added, the meaning of it, and or you can say the meaning which we derived from the different numbers we learned about, is being added. So what ends up happening is we somehow end up on a completely different vectors in both these cases. And we solve a problem, because what the problem here was that both इन दोनों बैंक्स के लिए हमारे पास एक ही वेक्टर था, बट अब ये दोनों जो वेक्टर हमें मिले हैं फाइनली सीक्वेंस मॉडल्स में, जब हमने सिंगल सिंगल वर्ड्स प्रोसेस किए, these both are completely different. So now we will not have the same problem which we had here, as bank being referred to the same bank, which is the place we put money in, but is referred to as completely different things in both these sentences. Do we understand that? Let me open up a poll. Now I know how to do it. All right, no, relaunch poll. Yeah, let's see that again. I see it's 80%. Let's get that better. Oof. We understand what a word is, like the meaning of how we are making a simple word into different numbers, let's say, which is a vector. So what we can do is, if you see this sentence, and what would happen here is when the word bank appears in both these sentence, it would have the same meaning, right? Because it has a single vector, which means the place we put money in. But in if you look at both these sentence, in first the bank means that, okay, that's great, but in the second the bank means the side of the river, and that's completely different thing. So how can we solve this? What if this specific बैंक जो वर्ड है, इसे पता होता कि इसके आगे रिवर आया है, या इसके आगे कैश या पैसों की बात हुई है? सो इट वुड बेसिकली अंडरस्टैंड दैट अगर पैसों की बात हुई है तो भाई बैंक हूँ मैं, द प्लेस यू डिपॉजिट मनी और विदड्रॉ मनी फ्रॉम. एंड इफ रिवर की बात हुई है, ओ दिस इज नॉट द बैंक विच आई अंडरस्टैंड, दिस इज द साइड ऑफ द रिवर. दिस वुड हैपन, राइट? एंड हाउ कैन वी डू दैट? Basically, what if we वर्ड बाय वर्ड सीक्वेंस को प्रोसेस करें, दैट्स सीक्वेंस मॉडल्स। सबसे पहले इन दिस केस आई को प्रोसेस किया, वेंट को प्रोसेस किया, टू को प्रोसेस किया, दा को प्रोसेस किया, बैंक को प्रोसेस किया। अब तक दोनों सेम थे, ओके, लग भी सेम रहे हैं। द चेंज हैपन व्हेन द वर्ड लाइक डिपॉजिट कम्स, डिपॉजिट का ऐड किया, कैश का ऐड किया और इसमें रिवर का ऐड किया। जब हमें फाइनल इन दोनों का जो वेक्टर मिला अब तो बिल्कुल ही अलग होगा। पहले तो दोनों का बैंक बैंक सेम लग रहा था उसे एंड इट माइट गेट कंफ्यूज, बट जब कैश की बात आई, पैसों की बात आई, तब इस बैंक का मतलब कुछ और है। बट जब रिवर की बात आए, द वेक्टर वुड मीन completely different from what it meaning in the above sentence, right? This is how we the origin of sequence models came in, and we call them recurrent neural networks. So basically there's a concept of recurrent here because we are moving and these sequence have in the architecture we'll see that what's recurrent meaning here. But this basically is an architecture which is based on neural networks. We know that neural networks are the field which deals with deep learning, so now we are learning deep learning, learning about deep learning. So these RNNs, what they do is basically word by word process something, and from each word they maintains a memory. So for this one, I talked about this sentence, right? For each of these words, they would make a memory of the previous words or the previous sequence, what has happened till now. So if you see till here, both of them would be quite similar. But as soon as the words like पैसों की बात आई, जमा करने की निकालने की बात आई, अकाउंट की बात आई, it would be completely different. And इसमें रिवर की बात आई, it would be completely different. So this is how the context or the upcoming words in a sentence changes the meaning of a word completely. Now do we understand it? Relaunch poll. Cool. Great. It's 95. Uh, why is it stuck? Yeah. Cool. We understand what sequence models are. We have passed one step. You guys know what deep learning is. That's great. Great learning for today. But you can easily see that सेंटेंस बड़े होते जाएंगे, पैराग्राफ बड़े होते जाएंगे, स्टोरी बड़ी होती जाएगी। कितना याद रख पाओगे, कितना ही वेक्टर चेंज कर लोगे तुम? दिस इज एन एवरलास्टिंग प्रॉब्लम दैट ऑफ मेमोरी, राइट? तुम कितना ही लंबा सेंटेंस याद रख लोगे, कितनी ही चीजें याद रख लोगे, देयर वुड बी अ टाइम व्हेन स्टफ कंप्लीटली मैसेज अप एंड ब्लोज योर होल आर्किटेक्चर, ब्लोज योर होल मॉडल. So in this sentence, the cat which was sitting on the mat that I bought from the store near the old church on the corner was happy. जब तक हमारा सीक्वेंस मॉडल इस वॉज पे आ रहा है, तब तक वो भूल ही गया है भाई कि मेरा सब्जेक्ट क्या था। मैं इंसान की बात कर रहा था, मैं बिल्ली की बात कर रहा था, कुत्ते की बात कर रहा था, किसकी बात कर रहा था? क्योंकि द प्रॉब्लम इज फॉरगेटिंग। वो कितने ही वेक्टर्स याद रख लेगा, कितने ही वेक्टर्स ऐड करके याद रख लेगा, द मीनिंग वुड कंप्लीटली डिसरप्ट बाय द टाइम इट एंड्स अप कमिंग ऑन वॉज. And this happens in all the big sentences. For small sentences, RNNs worked really good, or for small cases. If we talk about very large chunks of data, the thing we like, we can simply pass 1,000 lines or 2,000 lines stuff into ChatGPT, and it would still understand something or most of it completely. But the same was not true for RNNs because ये तो हर एक चीज याद कर रहे हैं ना, नॉट द ट्रांसफॉर्मर्स। ट्रांसफॉर्मर अलग करते हैं। तो इसे तो द कैट वो सिटिंग फ्रॉम कैट मैट स्टोर एटसेट्रा सब याद रखना पड़ेगा। और जब तक ये पहुंचेगा कि वॉज हैप्पी, अब हैप्पी कौन था इसे क्या पता, क्योंकि द फर्स्ट वर्ड विच केम दैट वॉज द सब्जेक्ट ना, उसकी बात हो रही थी। बट एट द एंड ऑफ द सेंटेंस इट इज नाउ looking back at the history which is completely messed up, so it doesn't really understand what's happening in this sentence, and that's end up not giving you the best answer. Do we understand the problem? Let me open the poll. I think this is pretty clear. Great. Great going. 90%. I would take that as a yes. But again, एक बार फिर से बता देता हूँ। द कैट विच वॉज सिटिंग ऑन द मैट आई बॉट, अगर तुम ये सेंटेंस पढ़ोगे यू कैन इजिली से दैट ओके भाई कैट खुश हुई ना मेरी क्योंकि उसे नया मैट मिल गया। बट आरएनएन्स को नहीं पता है क्योंकि वो तो हर वर्ड को इंडिविजुअली प्रोसेस कर रहा है कि कैट थी, मैट पे बैठी थी, जो मैंने बाजार से लिया था और वो खुश थी। ये मेरे को तो आसानी से समझ आ गया, यू गाइस कैन इजिली अंडरस्टैंड इट टू। बट मॉडल मेरा आरएनएन तो नहीं, क्योंकि हर एक वर्ड को प्रोसेस कर रहा है वो, हर एक वर्ड को प्रोसेस करने के बाद उसके वेक्टर पे जा रहा है। और हर एक वर्ड को प्रोसेस करने के बाद पिछले वेक्टर से वो कुछ ला रहा है। हर बार कुछ ना कुछ तो मीनिंग और इन्फॉर्मेशन गायब होगी हर स्टेप पे। एंड द इन्फॉर्मेशन लॉस बिकम सो बिग एट द एंड कि बाद में उसे पता ही नहीं कि भाई बात किसकी हो रही थी, राइट? The thing is this, you can see we are moving in a very linear fashion, like we, this is a sentence, we are moving like this, and by the time we are here we do not know what happened, at the start of the sentence. So this was the problem, and this the problem is basically forgetting. It would forget a lot of stuff. It would forget what the subject is, what the verb is, what are we talking about, क्योंकि मेरी मेमोरी इतनी है ही नहीं कि मैं इतनी चीज़ें याद रख लूँ, और है भी तो वो इतनी मैसी होगी कि उससे रिट्रीव करना इन्फॉर्मेशन ही बहुत मुश्किल होगा। कूल। सब हमारे पास चार चीजें हैं भाई 2012 के बाद से, कि हमें पता है कि वर्ड्स को कैसे समझें, हर सेंटेंस को कैसे समझें वर्ड बाय वर्ड करके, क्योंकि इसमें मेमोरी ऐड करते जाएंगे। बट हमें ये भी पता है कि वो भी फेल हो जाएगा, क्योंकि फॉरगेट तो मैं कर दूंगा, कितना ही चीज़ें याद रख लूंगा। हमारे पास बहुत ज़्यादा डेटा भी है, हमारे पास बहुत ज़्यादा जीपीयूज भी है। द फील्ड वॉज स्टक हेयर फॉर अ लॉट ऑफ स्टफ वाज हैपनिंग। लेट समथिंग आरएनएन्स के बाद एलएसटीएम्स आए, उन्होंने क्या किया कि एक अलग से गेट लगा दिया कि द कैट वेट, जैसे अब विच पे आया, विच कोई इंपॉर्टेंट शब्द नहीं है, इंपॉर्टेंट वर्ड नहीं है सेंटेंस में। तो मॉडल के पास ऑप्शन था कि क्या मुझे याद रखना है, क्या मुझे याद नहीं रखना। तो ऐसे ही हर वर्ड पे उसे एक गेट लगा दिया कि या तो मैं ये याद रखूंगा या तो मैं ये याद नहीं रखूंगा। दैट वॉज द थिंग वी डिड विद एल एस टी एम्स। एल एस टी एम आर लॉन्ग शॉर्ट टर्म memory models which came after RNNs, and the only thing which they improved on was adding a gate that, like, on each word it would have an choice to either remember it or add it to its memory or not. So इस केस में वो क्या हो सकता था कि विच पे भाई वो बोलेगा कि मेरे को नहीं याद रखना, वो उस पे मेरे को बोलेगा नहीं याद रखना, सिटिंग पे बोलेगा हाँ मेरे को याद रखना है, मैट पे बोलेगा हाँ मेरे को याद रखना है, और वॉज हैप्पी पे बोलेगा मेरे को याद रखना है, कैट पे बोलेगा मेरे को याद रखना है। तो इस केस में क्या होगा कि जो मेमोरी और जो इन्फॉर्मेशन जो उसे रिटेन करनी थी, वो सरप्राइजिंगली बहुत कम हो गई है, राइट? क्योंकि हाफ ऑफ द वर्ड्स या उससे ज़्यादा उसने याद रखने की कोशिश नहीं की, क्योंकि दे वर नॉट मेकिंग एनी सेंस फॉर इट टू रिमेंबर एंड वर्क ऑन देम और प्रोसेस इट, राइट? That's what happened with LSTMs, and then GRUs came. But still, the RNNs failed at this sentence. If we, bring a 10 times longer sentence, the same would happen with LSTMs. Because at the end, what they are doing is they're making understand it. उनके पास एक डब्बा है, उसमें वो इंफॉर्मेशन डालते जा रहे हैं हर वर्ड की। आरएनएन्स ने क्या किया, इस सेंटेंस में सबकी डाली, उसका डब्बा भर गया। एलएसटीएम्स क्या करेंगे भाई, सेलेक्टिवली डाल लेंगे। बट इसके 10 गुना बड़ा सेंटेंस आ गया तो सेलेक्टिवली भी इंफॉर्मेशन इतनी बड़ी हो जाएगी कि उसमें भी डब्बा भर जाएगा। तो डू वी अंडरस्टैंड दैट कि हमारे डू वी अंडरस्टैंड दीज फोर थिंग्स की वर्ड एम्बेडिंग्स क्या है, कि हर वर्ड को, मतलब हम एक वर्ड को कैसे मीनिंगफुल बनाएं एक मशीन के लिए बाय टर्निंग देम इनटू नंबर्स और वेक्टर्स। सीक्वेंस मॉडल्स क्या है कि हम सेंटेंस को कैसे प्रोसेस करें, एंड वो क्या है कि एलएसटीएम्स क्या है, बेसिकली जस्ट अ गेट की याद रखो या नहीं। एंड वी अंडरस्टैंड द प्रॉब्लम दे हैव, राइट, कि इंफॉर्मेशन में कितनी ही स्टोर कर पाऊंगा। Cool. Do we understand these two things? And then we already understand that we have a lot of data by the 2017 or 2015 and a lot of powerful GPUs. So are we clear on these four things? Let me reopen the poll. Cool. Yeah, 90%. That's great. Very nice. Uh, okay, let's move ahead. The idea of transformer. It's very interesting. Let's see what do you think can, like, हमारे पास एक ही चीज बची है सोल्व करने को कि हम चीजें भूले ना। और उसके लिए हम बेस्ट चीज़ क्या कर सकते हैं कि बहुत ही ज़्यादा सेलेक्टिव हो जाएं, कि एक वर्ड के लिए मैं दूसरे, क्योंकि एक सेंटेंस में इफ यू रियली लुक एट इट देयर आर ओनली 2 or 3 वर्ड्स विच मेक द फुल सेंस फॉर इट। लाइक अगर हम पिछले वाले सेंटेंस में भी जाएं, लाइक इस वाले में, एक बैंक वर्ड है, और अगर मैं सिर्फ कैश वर्ड भी देख लूँ ना तो भी मेरे को पता चल जाएगा कि ये बैंक कौन सा है। और अगर मैं रिवर वर्ड भी देख लूँ तो भी मेरे को पता चल जाएगा कि ये बैंक कौन सा है, और इन दोनों केसेस में दूसरे दूसरे बैंक है। So, like, we do not need to learn the learn about the whole sentence, or we do not even learn about a good part of that whole sentence. But basically these 2 or 3 words अगर हमने ढंग से देख लिए और रिटेन कर लिए जब हमसे कोई पूछ रहा है दोबारा, then that's a very good thing, because we used as less as memory we can, and we got the best outcome out of it, right? This was the whole मतलब यही चीज हमें सोल्व करनी है जो कि प्रॉब्लम थी सीक्वेंस मॉडल्स में अभी तक, राइट? सो व्हाट वाज हैपनिंग इन सीक्वेंशियल मॉडल और आरएनएन्स और एलएसटीएम्स, आई वुड से कि हम एक लीनियर फैशन में मूव कर रहे थे। ये मेरा पहला वर्ड है, ये मेरा लास्ट वर्ड है, इसमें ऐसे ऐसे प्रोसेस करते जाएंगे हर वर्ड को, बीच में मेरे को गेट लगा दूंगा एलएसटीएम्स में कि याद रखना है नहीं रखना। बट हम मूव तो ऐसे ही कर रहे हैं। इससे दो चीजें हो रही है। एक तो जब तक ये वाला पहला वर्ड प्रोसेस नहीं हो जाता, हम दूसरा वर्ड प्रोसेस नहीं कर सकते, या फिर तीसरा वर्ड प्रोसेस नहीं कर सकते। तो एक तो सबसे पहले स्पीड बहुत कम है हमारी, और दूसरी वही बात आ गई कि मेमोरी तो इसमें है ही बेकार। So yeah, you can look at it. The same thing is mentioned in the slide. These models were sequential. एक एक वर्ड प्रोसेस कर रहे थे। मान लो बुक के हर वर्ड को स्टार्ट टू फिनिश रीड कर रहे थे। बट डू वी डू दैट एज अ ह्यूमन? हम तो बेसिकली पूरे सेंटेंस को जस्ट स्किम थ्रू आवर आइज एंड वी जस्ट रिटेन द बेस्ट नॉलेज वी कैन। लाइक कैरेक्टर का नाम क्या है, अब उसने, इफ इट्स अ विलन और इफ इट्स अ हीरो, एंड इफ दे आर कमिटिंग अ क्राइम और सेविंग समथिंग, we just skim through the first page or second page of the book and understand most of it, which the models cannot, because these models, I'm talking about sequence, earlier sequence model, क्योंकि वो तो एक एक वर्ड प्रोसेस कर रहे हैं, एक तो पढ़ेंगे भी धीरे और रिटेन भी कुछ नहीं कर पाएंगे। डू यू अंडरस्टैंड दैट? नया तरीका क्या है? क्या कैन वी मेक एन आर्किटेक्चर, कैन वी मेक समथिंग लाइक हर एक वर्ड पे वी कैन प्रोसेस इंडिपेंडेंटली, कि मैं आई पे भी साथ में प्रोसेस कर रहा हूँ, एम पे भी, माई नेम इज ऋषभ, सब पे एक साथ प्रोसेस कर रहा हूँ, बाद में जाके वो मैं इंफॉर्मेशन मिला रहा हूँ और आपस में उन्हें कोरिलेट करा रहा हूँ समहाउ, एंड देन आई एम गेटिंग द बेस्ट आउटपुट। क्योंकि इससे क्या होगा, एक तो मेरा वो ये सिक्वेंशियल मॉडल हट गया, अब मैं हम पैरेलल हो गए कि एक साथ 3 वर्ड्स पे, एक साथ 1000 वर्ड्स पे ध्यान दे सकते हैं। और उसके बाद दूसरी चीज क्या हुई, अब इन पूरे सेंटेंस में हमें दो ही चीज को तो याद रखना है कि बैंक है तो कैश है या रिवर है। अगर इन दोनों में से मैंने एक भी चीज पकड़ ली तो इजीली मैं क्लासिफाई कर पाऊंगा एक बैंक कौन से बैंक की बात हो रही है, राइट? तो दिस इज व्हाट द होल आइडिया ऑफ ट्रांसफॉर्मर इज। द फर्स्ट थिंग इज वी मेक द आर्किटेक्चर पैरेलल, कि हर वर्ड इंडिपेंडेंटली प्रोसेस हो, अगले पिछले वर्ड का वेट ना करे। एंड द थिंग अबाउट विच आई एम टॉकिंग अबाउट, कि एक दो वर्ड याद रखनी है, एक दो वर्ड्स याद रखने, उसे पूरा सेंटेंस का मीनिंग जानने के लिए, उस सीक्रेट को हम कहते हैं अटेंशन। द अटेंशन इज समथिंग विच द मॉडल अटेंड्स टू रेलेवेंट वर्ड्स नो मैटर हाउ far apart they are, right? Like if we go back to the last slide, इन हेयर, अगर मेरे मॉडल एक तो सबसे पहले इन सारे वर्ड को वो इंडिविजुअली प्रोसेस करेगा एक साथ, राइट? तो सबसे पहले स्पीड तो बहुत ही ज़्यादा फास्ट हो गई। उसके बाद दूसरी चीज़ वो क्या करेगा, कि जब हैप्पी की, वॉज हैप्पी की बात हो रही है, वो सीधा देखेगा द कैट की बात हुई थी बस स्टार्टिंग में, बीच वाला कुछ मैटर ही नहीं करता। अगर मैं, मेरा उससे क्वेश्चन है कि हु वॉज हैप्पी, इट वुड इंस्टेंटली टेल मी दैट द कैट वॉज हैप्पी, क्योंकि उसने मोस्ट रेलेवेंट सेंटेंस और मोस्ट मोस्ट रेलेवेंट वर्ड पिक कर लिया उस सेंटेंस से। So do we get that? I'll open the poll. Let me do that. Okay, yeah. It's a bit 80%ish. Okay, we'll see that again. हमें ये तो समझ आ गया, इस सीक्वेंस मॉडल में हम एक एक वर्ड करके जा रहे हैं। आरएनएन्स में हम सब कुछ सारी चीज़ों की हिस्ट्री और मेमोरी याद रख रहे थे, एलएसटीएम्स में हमने सेलेक्टिव कर दी। अब हमें इससे आगे बढ़ने के लिए क्या करना है भाई, हमें और भी ज़्यादा सेलेक्टिव करनी है, राइट? क्योंकि इस पूरे सेंटेंस में अगर वो सिटिंग मैट बोर्ड फ्रॉम द स्टोर को भी याद रख रहा था, तो भी इट वाज समहाउ वेस्टिंग दैट इन्फॉर्मेशन, क्योंकि वो तो यूज ही नहीं हुई मेरे फाइनल क्वेश्चन को आंसर करने के लिए, राइट? कि मेरा क्वेश्चन तो था हु वाज हैप्पी। अब उसमें मैट कैट कहाँ से मैंने खरीदा, मैट खरीदा, क्या खरीदा? क्वेश्चन तो ये था खुश कौन था, खुश तो बिल्ली थी मेरी, इसके लिए मैट आया। अटेंशन डज दिस, ट्रांसफॉर्मर डज दिस। ट्रांसफॉर्मर सबसे पहली चीज तो क्या करता है, जस्ट अ मिनट। या सो what was happening in sequence model was that we were going word by word. Each of these words have different meanings, and we were select in RNNs, we were just storing all of them into something we call as memory or history. And usse, from that we were able to understand how the earlier words or the next words are going to behave. LSTMs was just that we applied a gate on every word. We have a gate which is like, on which it would ask that should I remember this or should I not remember this. And STMs would say which का मैं, what would I do of which का मैं क्या ही करूँगा, remove that, I don't need the information of that, right? Same would happen for the all of the other words, and it might retain something like sitting, mat, board, store, church, corner, and happy. So it the information stored by LSTMs are reduced by, let's say, 50%. RNNs was completely bad. LSTMs are now 50% more better than RNNs. Now what we need to do is, the idea of transformer is that we have to make this thing fast, because we are, what is currently happening, we are moving word by word, and we cannot move to the word ahead of a word before we process the previous word, right? Because we need the information from the previous word. First thing, we cannot do this with RNNs, LSTMs, or sequence models, because they are linear model. They flow in a certain fashion, and we cannot change that fashion or the flow of the gradients, etc. But we need to change that, because if we move like this, reading a book would take months or a lot of hours. But if what if we can process each word individually? I can at the same time understand what the is, cat is, which is, sitting is, was, happy. For each of these word, at the same time, I can understand what is happening. And the second thing we need to do is, we need to make all these things which we now are processing parallelly correlate with each other. In this sentence, let's say all of these words would pass from the block A, which would basically understand the meanings or process all of them in single or continuously, or ek saath. But now the next thing I need to add is the information or the memory. Ki was happy should relate with cat. Because this is the ultimate question I wanted to answer, right? This is where the idea of attention comes in. Attention is something, attention wants, like attention enables the model to only focus on the most relevant word. The most relevant word. In the previous sentence, what was that? It was the cat. Because who was happy? As soon as the word happy, the model listens to word happy, what would it go to? Or what would be the most active thing you can do, like our brain would do? It would go on the cat, right? All the other information of the sentence is worthless. कोई काम की नहीं है, right? क्योंकि मेरा question or my question is just valid for that single word. Now do we get that? Great, yeah. I think that's better, 90%. जस्ट टू रिकैप, सीक्वेंस मॉडल वी वर फ्लोइंग वर्ड बाय वर्ड, एक एक अगर हम वर्ड से जा रहे हैं, इट वुड डेफिनेटली बी स्लो. फर्स्ट ऑफ दैट वी सोल्व दैट, कि लेट्स नाउ प्रोसेस ईच वर्ड इंडिविजुअली. कि जितना वर्ड एक टाइम को प्रोसेस करने में लग रहा था, अब उसमें इन दैट सेम टाइम आई कैन नाउ प्रोसेस ऑल ऑफ द वर्ड्स साइमल्टेनियसली. वी सोल्व फर्स्ट थिंग, स्पीड. Second thing what we have to solve is, we have to select most relevant stuff, like the ultimate or the, we have to make it just like our brain. If I am, as a human, am reading that sentence and someone asks me who was happy, my word without any thought would say the cat was happy, right? We want that same relevance from our model. That's what attention do. Attention gives me that most relevant word my question would relate to, and this is what was added to transformer. These two things alone made that a breakthrough. What happened was, now we can do stuff so fast, we can read so much of information, we already had a lot of data, we can train on a lot of data. And with that, the addition of attention, now we do not care about memory. It can be as long as it want. We have some implications of it, that models forget, even like ChatGPT and all, but they are thousand or a million times better than RNNs, LSTMs. We'll talk about those implications a lot later, but current for now, let's understand they have infinite memory, right? Because they are only attending or giving me the most relevant words for every question I ask. Cool. This is the secret attention. We'll see it more in depth when we cover it later in the whole transformer architecture, and when we will code it out too, so you guys can get a lot of information. But in today's class, that agenda is you understand what happened before, what is happening now, what transformer is, what it evolved. So if I ask you the question, what transformer added? Two things, right? It made it fast. It made it attend to most relevant stuff. These are the two things it done. फास्ट हाउ, मैं सब कुछ पैरेलल प्रोसेस कर रहा हूँ. Each step I'm just simultaneously understanding all the different words that are coming in a sentence, and with that I have something named attention, that is allowing me to understand the most relevant word or pick the most relevant word which is to my question. Let's see if we can retain it now. A quick poll for this, and then we move ahead. Great, 96. That's very great. Now let's see it more intuitively. We'll go sentence by sentence and see what attention would, pay the most attention on or the most focus on. It's weird, right? Attention, paying attention. But we'll see what attention pays or what transformer pays the most relevance or the most importance on. In this sentence, if we see, the animal didn't cross the street because it was too tired. अगर मैं पूछूं, if I ask like the word it, what does it refer to here? It refers to animal. मेरे को सोचना भी नहीं पड़ा. My brain didn't even need to think about it, right? Because it's very non-thinking thing we do. We just read a sentence, we know what makes the most sense, and we just blur out the answer, right? Same thing, the same thing we do as a human. Attention is allowing us to make machines do. If I ask some transformer the same sentence, the animal didn't cross the street because it was too tired, and then I ask it, who was too tired? What do you think it would answer? It would simply say the animal. Goes just like our brain processes it, the transformer is similarly processing it. First of all the words are processed simultaneously. So it has hold speed. Now what is it doing? As soon as the word it comes, you can see animal lights up. Animal lights up, which means that the most relevant word to it is animal. How does it do it? That's a question for later. We'll see how these, different mathematics happen behind the scene and how the animal is shining up the lot, shining up the most in this. But what you currently need to understand is as soon as the word it came, animal is the most relevant word the model blurb out. This is how the model knows what the pronoun refers to. And this is basically allowing us to make a machine which is context aware. This is the first thing that happened. Let's look at another example. We have two scenarios here. The animal didn't cross the street because it was too tired. If I ask you who was too tired, animal, same as the previous example. Look at the second scenario. The animal didn't cross the street because it was too wide. Now, if I ask you what was too wide, was was the animal too wide कि वो रोड ही क्रॉस नहीं कर पाया? Definitely no. Or was the street too wide? As soon as it came, in the first sentence, you can see animal light up because attention is paying the most, attention is paying the most attention to animal here or the most importance to animal here. And in the second scenario, if you see it and wide, as soon as they came, the word street glows, right? Because it is the most relevant word in this scenario. So as soon as the sentence changes, our attention is able to pick it up. कि like पहले भाई मेरा animal tired था, the animal was tired and it couldn't cross the road. Now the street is too wide for the animal to cross. Do we get that? Let's open a poll. These examples should make it very clear, right? How attention pays importance to different words when they arise, right? 90%. That's great. Okay, just before we move on, let's just again look at it what transformer is, right? सबसे पहले तो at first it's not sequential, we are processing everything parallelly, so it's fast. And second thing is attention. You pay the most importance to the most relevant word, right? If I go to this and I pass this, the sentence, the animal didn't cross the street because it was too tired. Animal और एनिमल ने रास्ता क्रॉस नहीं किया क्योंकि वो थका हुआ था. ये इसका ट्रांसलेशन हो गया. नाउ इफ आई आस्क द क्वेश्चन हु वाज टू टायर्ड, थका हुआ कौन था, वी वुड सिंपली से एनिमल. सोचने की जरूरत भी नहीं पड़ी. वी डिडंट इवन नीड टू थिंक, राइट? दैट्स व्हाट अटेंशन इज अनेबलिंग द मशीन्स टू डू. इन द सेकंड सेंटेंस यू सी द सेंटेंस लुक्स वेरी सिमिलर कि ज़्यादा कोई डिफरेंस नहीं है, एक दो वर्ड चेंज हुए हैं. इट वॉज टू टायर्ड से इट वॉज टू वाइड हो गया है. बट दिस वाइड हैज मेड सो मच डिफरेंस इन द कॉन्टेक्स्ट. पहले थका हुआ था एनिमल इसलिए उसने रोड क्रॉस नहीं किया. नाउ like before the animal was tired, that's why it didn't cross the road. Now the animal didn't cross the road because the road was too wide and animal made a choice ki let's not cross this wide road, but if a vehicle came and attacks me, so I would choose not to cross this road. And that's Just a single word changed the whole context of this sentence completely. Now think about what RNNs or what LSTMs would do. They would completely fail in such situations, or even if they pass, they would quickly lose their relevance as the sentence grew up. Or imagine if it was a big story, the LSTMs and RNNs would completely end up giving a waffle answer rather than something this informational or helpful. This is what attention enables us to do. As soon as a word change, the information or the context around it will change too. And who is responsible for making models understand that? That is something we call as attention. Now, do we understand this better? Great. सो बाय चेंजिंग जस्ट अ सिंगल वर्ड, हमने चेंज बेसिकली किया ही क्या है सेंटेंस में? टायर्ड की जगह वी जस्ट चेंज्ड वाइड. बट इफ यू लुक एट इट, द मॉडल इज नाउ सो स्मार्ट दैट इंस्टेड ऑफ लाइटिंग अप एनिमल, इट इज लाइटिंग अप स्ट्रीट, बिकॉज इट करेक्टली आइडेंटिफाइज दैट जो मेरा इट वर्ड है वो अब रेफर किसे कर रहा है. पहले केस में, इन द फर्स्ट केस, इट वॉज द एनिमल वॉज नॉट एबल टू क्रॉस रोड बिकॉज इट वॉज टायर्ड, थका हुआ था. इन द सेकेंड केस द एनिमल वॉज नॉट एबल टू क्रॉस द रोड बिकॉज द रोड वॉज टू वाइड. इसमें एनिमल की, सेकेंड सिनेरियो में एनिमल की कोई गलती नहीं थी. इट वॉज दी गलती तो रोड की भी नहीं थी. बट सेकेंड, इन द सेकेंड सिनेरियो, एनिमल मेड अस, आई वुड से, अ चॉइस जस्ट टू नॉट क्रॉस द रोड. Cool. So we have seen why attention is so powerful. I've already told about why is it like 2-3 times. First of all, we are now parallelly processing everything. Word by word हम process नहीं कर रहे. At same time, we are processing all the words we are passing to the model. But with this, what we have is attention. कि words तो चलो मैंने सारे process कर दिए. Even though I'm processing all the words simultaneously, I need to make sure that the information I get or the relevance I get from each word is very different in different scenarios. Like we see in the last slide, where were two scenarios, and just a single change of word changed the context of everything. That's the first thing, or the two things attention solved. First of all, very, very selective, like very, very selective things it is now able to attend to, or give relevance to. Second thing is it has lot of memory, because now we are selecting like 1% of thing which LSTM was doing, and LSTM was selecting 50% of thing which RNNs were. So you can see how much of a big gap we have created from earlier models. What this allows us is to make a very mathematical mapping of every word, to how it relate to every different words, and how that meaning changes with different words. Like if I change the word A to word B, how does that meaning change? We saw that with our eyes. Like when I changed tired to wide, the meanings completely changed, and the context of this whole sentence was like, oh, if this was a bad model, it would have did not would not even give an answer, and it would still say animal. Like it would say, oh yeah, the animal is too wide and the road is too narrow, so it didn't cross. But that does not make any sense. What makes sense is here, the road got wide and that's why the animal chose to not cross it. This single word was able to make such a big difference. And what was able to catch it is, first of all, we humans, because and without even a second thought, we were able to, understand this. What was the other thing which we were able to understand this is attention, which is a part of transformer. We'll see the mathematics of it a bit later in this course, but we intuitively understand what it was, right? Oh, sorry, what it is. Very good. Nice, nice, nice. So we see now we have more memory, parallel processing, deep understanding. These three things we solved. If we look back at the first slide, what were we doing? We were simply deciding a set of rules. If our system, or if our object checks all these rules, it is considered intelligent. If I ask you the same question now, would you consider that same system intelligent or dumb? Obviously dumb. We then move to statistical models. Would you consider that model intelligent or dumb? Obviously dumb, because it was not able to understand these minute details of how a single word can disrupt the entire thing. And if you look at it, these words are so important. And in later course, we'll see how these words are then transformed to images, and we can also understand images by the same architecture. What one funny thing happened is around 2016, 2017, a lot of PhD applicants or were working on different fields in machine learning or master student or PhD applications, etc. Right? And they were not anyone was not sure that this transformer is going to boom and destroy and disrupt everything and is going to be the go-to source for intelligence, right? And everyone was doing their thesis on completely different things. Like someone is doing on protein folding, someone is doing on 3D modeling, someone is doing on CNN, someone is doing on mambas. Mambas were not a thing then, but let's say what happened is, as soon as transformer came up, there was still some not it got a lot of attraction, a lot of attention to itself, but people thought let's just continue with our thing. What happened is, within an year or two, the same architecture was applied to all these different fields, and it completely disrupted all these different fields from what they have developed over the years. A single model, a single architecture was responsible for that. What allows that to do it? Attention. Now you understand that attention, because if you look at it, everything is a sequence. If I talk about images, every pixel that comes after each pixel is a sequence, and if you understand that sequence, you understand what it is. If I give you, like, let's say, a picture of a beach, right? And then I pass that same picture to the model and I ask it, what can you describe the place? It would simply light up the beach, beach word, right? I'm just simplifying it so much, but it is so smart, just like us human. It would just take a glance at it and it would output beach. How is it doing that? From the same context that it is understanding the machine or language. I talk about 3D modeling. What is it? It's basically just sequence of different stuff. If I talk about music or audio, what is it? It is a sequence of different, uh, what is it? Yeah, I forgot the word, but yeah, it's again a sequence of smaller voices and etc. Fuck. I completely forgot the word for him. Audio, but you understand that, right? Audio is again a sequence, because हम गाना गा रहे हैं, that contains a sequence, right? Images are a sequence. Anything else you can think of is a sequence. And if our model or our transformer architecture is performing so well on this sequence of words, can it not perform well on the sequence of images or audio? It can. First, we discovered this on language, but now it is applied to every field. For images, we have vision transformer. For audio, we have diffusion, audio transformer. For images, for images, video, we also have diffusion transformer, which was a completely different field back then, but is now also, overtaken by a transformer. That is how powerful this attention was, and that is how powerful this architecture was. Cool. An architecture built entirely on mechanism of attention. ना तो इसमें रेकरेंस है, रेकरेंस इज द रेकरेंट न्यूरल नेटवर्क, द सीक्वेंस मॉडल. ना तो इसमें कॉन्वोल्यूशन है, सीएनएन जैसे, जो कि या सीएनएन वर अ थिंग बैक देन. ना तो इसमें वो मैथमेटिकल ऑपरेशन हो रहा है. दिस इज व्हाट इट इज हैज इज अटेंशन, राइट? एंड अटेंशन कैन बी यूज सिमिलरली इनटू इमेजेस that also outperform CNNs, also can perform in sequence में तो कर ही रहा है, so it also outperforms recurrence. The word large language models come. We understand what language models are, right? Language models are something we input them a language and they are able to give us an answer or continue that information which we have passed and just predict the next word and continue growing that sentence over. That is what language models are. We hear the term large language models. What do they mean by large? Large is basically the amount of neurons you have. You have heard words like 10 billion parameters model. OpenAI has released 1 trillion parameters of model. Open source model तो 7 billion 100 billion के होते हैं, right? These words make the word large. So over a certain, I would say, 10 billion parameters or even 7 billion parameters, we call that model a large language model. The very contrarian of this field is SLMs, which is small language models, where we work less under 5 billion or 1 billion parameters, and we are trying to make these models better on these small parameters too. Because what would that enable us to do is, फिर वी कैन रन आर ओन. मैं अपने फ़ोन में ऋषभ एल एल एम नाम का एक एल एल एम चला पाऊंगा, नॉट एल एल एम, ऋषभ एस एल एम नाम का एक लैंग्वेज मॉडल चला पाऊंगा, विच वुड वर्क विदाउट द इंटरनेट ऑन माई फोन, बिकॉज इट इज सो स्मॉल दैट माई फोन प्रोसेसर कैन प्रोसेस इट. So this is the complete opposite of LLMs, which is SLMs, but they are based on the same architecture, which is transformer. And what transformer is built upon is attention. It is built on a lot of things and a lot of advancement or memory efficiency, which people did over the years from 2018. बट द फर्स्ट थिंग विच केम अप वाज दिस सिंपल आर्किटेक्चर कि मेरे पास एक ट्रांसफॉर्मर नाम का आर्किटेक्चर है। अगर मैं उसमें से सब कुछ हटा दूं और पूछूं कि व्हाट इज द मोस्ट इंपॉर्टेंट थिंग और व्हाट इज द मोस्ट इंपॉर्टेंट थिंग इन दिस होल ट्रांसफॉर्मर आर्किटेक्चर, एक ही आंसर है, दैट इज अटेंशन। डू वी अंडरस्टैंड दैट? लेट मी ओपन अप अ क्विक पोल। Very good, 90%. That's great. Good class. Now, if I ask you simple question, how does ChatGPT work? The first thing we know that it is based on transformer architecture. The second thing we know, transformer is based on attention. So we know that for a certain amount of for a certain paragraph we are passing it, or for the certain question we are asking it, there's something attention is doing which is making sure the most relevant word I pick up from the training data or the data the user has given me and output that. The second thing, we know ChatGPT, to make these models we have to train them. How, where does the data come from? That is the whole internet just scraped down, right? The next thing they have to do, which is the new thing here, is prediction. How does these language models work? So abhi tak, like right now or up till now, I've said that these models answers your question, but that is not what's happening, right? We give a model, let's say my name is Rishabh and I am a. This is the sentence I've given a model. What the model will do is it would generate the next word. That's the only thing a language model can do. That's the only thing ChatGPT can do. All the other things are post processing. By post processing, I mean that after this generation, like even the largest or the, you can say, 100 trillion parameter model can do the same thing, which is to just predict the next word. My name is Rishabh, I am a boy or I am a male or etc. It can just predict the next word. That's the whole thing or the whole thing it can do. But how do we make it to answer questions or perform different tasks? That's, we process it, and after training these big models, we do a small step which allows them to answer just to our question. But the only thing a model independently or fundamentally can do is predict the next word. That's what the model can do. If I show you like an visual diagram of it, I would have to bring this down. Let's say this is a transformer model, right? Or you can say chat GPT hai ye. This is chat GPT. And this is, let's say, my sentence. Rishabh is a, this is the sentence I'm inputting it. So this goes here, right? What this would do, it, after all these very mathematical heavy complications or multiplication and all of that stuff, passing it through attention, processing all of these words parallelly, what it would do is that it would give me a final list of vectors. This is one different thing which we are talking about, right? So it would not just give me single word, it would give me probabilities of different words. Like, let me just copy this. Yeah. It would give me these n different possibilities of what the next word can be, and each of them is classified by that, by a number which is like 80%. There's a 80% chance it's gonna be like this. There's a 10% chance it's gonna be the second word. There's a 5% chance it's gonna be the third word. There's a 2% chance that it's gonna be this word. This is what the transformer model outputs. So if you look at it, हमने एक sentence pass किया, we pass the sentence inside the transformer. What it outputs, right, is a list of different words which can come next to that word. This is why these language models are called as next word predictor. You might have heard this term that language model are just an expert predictor, or language models are regression models and stuff like that. What that means is that the language model fundamentally can do only one thing, which is that given a sentence it can just generate the next word. So how do we, now the obvious question should be that Rishabh is a, let's say the word here is boy, it answers that. How? But when I ask ChatGPT, it gives me a lot of words, not just a single word. How does that happen? What happens is, now the final, let's say we choose the, for now we are just choosing the word with highest probability. So what is the word now? If we look, let me minimize this. Rishabh is a boy, right? This is the final word जो कि बन गया. Let's see once again. So just you guys don't get confused. We pass an input. Rishabh is a just that to the transformer. The only thing transformer can do is just predict the next word. It predicts this from a list of different words it outputs. So it we can either choose the lowest probability one, which would can be gibberish or can be girl. But for now, the we are choosing the most highest probability of the word that can come next, which is right now boy. So we get the output Rishabh is a boy. But you see, in ChatGPT, what happens is you get a lot bigger sentence. How does that happen? If you like, I am saying that it only predicts one word, right? To the given sentence or the given input, but the ChatGPT answers in a lot more words. How does that happen? That happens via this. This word is again then passed to transformer. Like here, if I put it, yeah. This word is now passed to transformer. What would it do now? That it would again pass through everything, do the attention thing, do the processing thing, and it would again give me a list of words that can come. Let's say in this time it gives me a full stop. Ki Rishabh is a boy. Dot. This is the next word it predicted. What would happen now? It would again go back into the transformer. Again a list of words would come. Again that would happen. This whole flow again and again. When you talk to ChatGPT, this is what happens. You might have heard that okay, these even though these language models are so good, they have memory. What is this memory? That I mean, there's some implications to it. But what does that mean is there's a lot of memory overload for these models because it has to process these different words again and again. Like अभी in the first thing what it did was इसने ऋषभ इज अ को प्रोसेस किया. बट उसके बाद अगला वर्ड प्रिडिक्ट करने के लिए इसे ऋषभ इज अ बॉय को प्रोसेस करना पड़ेगा क्योंकि ऋषभ इज को तो पहले ही कर चुका था. व्हाट इज हैपनिंग हियर इज वी आर डूइंग दिस loop again and again, and this is how the long words or the long sentence get generated. We get that? Might be a bit hard to digest, let me know. 80%. Okay, we'll see once again. Let me open ChatGPT and show you guys what it answer. Rishabh is uh, is a this is what I out input, and let's see. Now ChatGPT has a lot of stuff, like it has information. Look at this thing, what it output. Let me put it up. Looks like the sentence got cut off. The model is so smart now that it knows the sentence got cut off. But if I ask it again, Rishabh is complete this sentence. Now we have to give it explicit information to process it, because the models are so smart that they understand that okay, something might have happened because the sentence looked like it cut off. See, it gave us so many different words, which is not just a single word. मैंने तो अभी बताया ना कि transformers can do only one thing. They can just predict the next word given a sentence or given a sequence of words. They can only predict the next word. So in here, let's see. Rishabh is a curious and driven individual. What is really happening here, if we go back, is that Rishabh is a transformer chat GPT ने प्रोसेस किया. उसका एक लिस्ट ऑफ वेक्टर्स उसे आउटपुट मिला. उसमें था क्यूरियस सबसे ऊपर. लाइक द मोस्ट प्रोबेबिलिटी ऑफ अ वर्ड टू कम अहेड ऑफ ऋषभ इज वाज क्यूरियस. सो द वर्ड इट outputted or gave as an output on the first turn was ऋषभ इज अ क्यूरियस. ठीक है, अभी भी सेंटेंस कंप्लीट नहीं हुआ, चैट जीपीटी ने तो और ज्यादा आंसर किया है. What happens is, as soon as this happens, it get passed to transformer again. The next word comes. If we go back and look at Rishabh is a curious, and this was the next word it generated. What would happen now? This Rishabh is a curious, and this whole thing would again get fast. It happens so fast. Like I just typed this in front of you, and it has given me a lot of words. I'm explaining it like it happens in a long time. No, because first thing we learned about transformer, it processes all the information parallelly, and a lot of stuff has happened after that which has improved the speed a lot. But that's the first thing, key information ko it processes parallelly, and that allows us or allows it to perform or work very fast. So Rishabh is सबसे पहला word it generated curious. Again the whole sentence got into transformer. The next word came and again the whole sentence got into transformer or chat GPT. Then द नेक्स्ट वर्ड इट आउटपुट वॉज ड्रिवन बिकॉज सबसे ज्यादा प्रोबेबिलिटी उसकी होगी उस लिस्ट में जो उसने आउटपुट की. उसके बाद अगेन दिस ऋषभ इज क्यूरियस एंड ड्रिवन. अगेन पास टू द ट्रांसफॉर्मर, गोज थ्रू द ट्रांसफॉर्मर, ऑल द अटेंशन स्टफ, आउटपुट्स अ लिस्ट. उसमें सबसे टॉप पे कौन होगा? ड्रिवन. ड्रिवन में आया, सेंटेंस में ऐड हुआ. अगेंस्ट दिस सेंटेंस इट जस्ट क्रिएटेड इज पास्ड ऑन टू ट्रांसफॉर्मर. फिर से एक लिस्ट ऑफ वर्ड्स मिले, उसमें सबसे ज्यादा प्रोबेबिलिटी लेट से इंडिविजुअल की इस बार, तो सेंटेंस में सबसे आगे हमने इंडिविजुअल जोड़ दिया. दिस इज हाउ द होल प्रोसेस ऑफ लैंग्वेज जनरेशन डज. दिस इज व्हाट चैट जीपीटी इज डूइंग बिहाइंड. As soon as you type something, it is going somewhere in some server where a model is working, and in there Rishabh is a get processed. उसके बाद अगला word it generate gets processed, अगला word it gets it gets generated. That's how transformer are working. So again, this is the simple thing it is doing. Sentence लिया, it outputs a list of words, and in that the most probability वाला उसने choose किया, sentence में add किया, and then it again passes through the whole transformer. It does it for a few different times. In this case, it has a lot of post processing like chat gpt, but let's say we trained a very simple model, it would end up stopping and responding just this sentence. So now do we understand what's happening? Yeah. How do I? Yeah. Let's relaunch. Great, 97%. That's very good. So we understand that how the chat GPT you are using is working. कि एक word, even if I start with I, it would get I, pass through the transformer, generate the next word, and choose. It generates a list, choose the word with the highest probability, add that to my sentence, again pass it through the transformer until you are done. Like the after individual, this would again get passed into the transformer. The final word or the final token it generated was this full stop. And my model is smart enough to understand that अगर full stop आ गया, if there's a full stop in the sentence, just stop generating. उसके बाद generate मत कर, क्योंकि we have outputted the user what it wanted. So this is what happens when we run a model, or you can try running a model locally. We'll see how to run a model locally also. But this is the simplest way you can understand that when you type something in here, how it goes through some web layers to the server where the GPU, or yeah, to the GPUs or the server where ChatGPT has put up their ChatGPT 5.2. उसमें जाके this is the literally the same thing happening. It gets processed again and again, again and again, and that's why there's so much of memory overload, क्योंकि it has to process the same words again and again for the same thing, right? Let's say it stopped here, right? The last stuff it has processed was this. At the very last step in this certain response, it must this whole thing must have gone to the ChatGPT server, must have passed to the transformer layer, must have generated a list of output. In at the top there was a full stop with the highest probability, and that's what it outputted and added to the sentence. And इसके बाद चैट जीपीटी ने बोला this is enough and this is how I can answer. I have given you 3 sentences for different styles. This is how much I can do for this simple prompt. That's what chat gpt answered and stopped there. This is how chat gpt processes your anything you type in here. So we understand this loop, right? This is basically how chat gpt or any different model is working. Now this prediction word gets very clear कि चैट जीपीटी, हाउ डज चैट जीपीटी वर्क? सबसे पहले इट हैज ट्रांसफॉर्मर. व्हाट डज ट्रांसफॉर्मर डू? पैरेलली प्रोसेस करता है. अटेंशन नाम की चीज़ है तो मेमोरी और हिस्ट्री ज़्यादा अच्छे से याद रखता है. रेलेवेंस वर्क्स ऑन वेरी गुड ऑन रेलेवेंस. किस पे ट्रेन है? ट्रेन ऑन द इंटरनेट डेटा विच इज़ वेरी वास्ट, लॉट ऑफ इमेजेस, लॉट ऑफ टेक्स्ट, लॉट ऑफ वीडियोज एंड वट नॉट. द नेक्स्ट थिंग इट डू इज प्रिडिक्शन. The only thing a model can do fundamentally is just predict the next word, because language models are known as next word predictors. They can, the only thing, even the best you can, let's say if you call a model, Go LLM, which is the best and cannot ever be wrong, it can still only predict the next word for a given sequence of words. And if you process that again and again, that gives you a proper sentence or proper paragraph what ChatGPT gave us. This is what's happening. So there's an architecture. Oh, sorry. There's an architecture which is the engine, which is like a lot of big neural networks. जिसके अंदर we have transformers. then we have a lot of training data जो कि knowledge है. It can be books, it can be articles, it can be images, it can be blogs, etc. The next thing is the goal. You can see, when I pasted Rishabh is and then I have to in the brackets mention complete this sentence. That was the task I gave the chat GPT to do or work on, right? It worked on that. तीन example on different style it gave me and stopped at the full stop. That's what it's trained to do. That whenever someone asks you something, look at the task and based on them attention work relevancy. क्योंकि they're definitely sure, I am definitely sure that somewhere in the training data Rishabh came, somewhere in their training data it came that okay, what it means to be, like if I go back, what it means to be simple and positive कि उसने बहुत एग्जांपल देखे ट्रेनिंग डेटा में. एंड व्हाट इट बेसिकली मीन्स इज सिंपल एंड पॉजिटिव रखना है मेरे को. लाइक इफ आई वांट दिस रिस्पॉन्स टू बी सिंपल एंड पॉजिटिव, दीज आर द वर्ड्स आई शुड यूज विद द सब्जेक्ट. प्रोफेशनल रखना है तो दीज आर द वर्ड्स आई शुड यूज विद द सब्जेक्ट. फन एंड प्लेफुल रखना है तो दीज आर द वर्ड्स आई शुड यूज विद द सब्जेक्ट. एंड दिस इज व्हेन आई स्टॉप एंड वी ऑलरेडी नो कि हाउ डज इट वर्क. Like a word get passed to the transformer, again this whole stuff repeats until the sentence is complete. This is what's going behind the curtain of ChatGPT or any language models. Do we get that? Great. 95%. That's very good. Let's move. So now your obvious one question that came to everyone's mind or is still in minds of a lot of people is ultimately what I'm doing is I'm just predicting the next words, right? That's what ultimately any language model can do, and that's what ultimately ChatGPT is doing. So how can we be so sure that it understands, or just predicting next word creates understanding? We can, let's say, if assume you are reading a mystery book and till the last word of that mystery book you do not understand who the killer is. That word alone can solve all the mystery that has happened in the book before, right? अगर तुम एक बुक पढ़ रहे हो उसके लास्ट में लिखा है कि this was the killer was, let's say, A. If you only read that line or that word, you would be able to discard every other information and just say that I know the killer is A. But you cannot, because that is happening at the last. And that's what understanding or predicting next word is. If I pass that same text and I just remove the last line, my model, my next word predictor model, which is just predicting the next word, it would be able to just predict, just based on the statistic, just based on the data, just based on the training, it would be able to predict that the killer was A. Where does that understanding come from? That's the debate, because the LLM or the transformer is so good with the other stuff that is happening, in the whole story. It knows the storyline, it knows the implications of what happened, what not. uh, B and C were, killed, and there was a car accident, it was planned and whatnot, you can say, in a mystery book. But my model was able to predict that, and that's what understanding means. Even after all these different chapters and books and thousands of different words, my model predicted the killer correctly. So I can say that it understands, and we cannot discard, language models or transformer simply by saying that, oh, ये तो बस next word predict कर रहा है, इससे ज्यादा तो ये कुछ कर ही नहीं रहा. How can we call this intelligent? Do we get that? It can able, like written here also, it is able to understand grammar and syntax correct. अभी खराब ग्रामर वाला नहीं देगा unless you ask it. फैक्चुअल नॉलेज पे काम करते हैं और लॉजिक एंड रीजनिंग बेस्ड होता है. You get that, right? If we look at here how it generate text, सबसे पहले स्टेप में दा जाएगा, दा के बाद वही लिस्ट ऑफ वेक्टर्स मिलेंगे, लिस्ट ऑफ रिस्पॉन्सेज उसे मिलेंगे, एंड बेस्ड ऑन दैट इट वुड जस्ट पिक द मोस्ट प्रोबेबिलिटी वाला कि द क्विक ब्राउन फॉक्स जंप ओवर द लेजी डॉग इज द वेरी फेमस सेइंग, राइट? So it would pick quick in this case. This the quick will again get passed to the transformer, the quick brown. This time it predicted brown. Now this three words again would get passed into the transformer. It would predict the word fox. This would again go into the transformer. Then it would predict jump and then over the lazy dog. This is how generation works. Basically, generation is an iterative loop. You can see after every step, we are iterating all the same thing. We are again passing the new text we got from the same transformer model and getting the new word. This is what generation is. It is an iterative loop. ईच प्रिडिक्टिव वर्ड इज एडेड टू द इनपुट। जो भी वर्ड मैंने अभी प्रिडिक्ट किया वो अब मेरा इनपुट है, और अगेन मैं उसे पास करूंगा तो एक और नया आउटपुट मिलेगा। उस आउटपुट से द आउटपुट विच आई एम गेटिंग इज अगेन एडेड टू द इनपुट एंड अगेन पास टू द ट्रांसफॉर्मर। Cool. Yeah. So we now know sequence models didn't work, RNNs, LSTMs, because both memory wale pange the. It was forgetting a lot of stuff. What was attention? It was able to, pay the most relevance or importance to a single word based on the question or the task which are given. And how does reasoning emerge? कि reasoning कैसे आ गई भाई? If you are just predicting the next word, because if I am predicting the next word, I understand what happened before, right? I understand that Rishabh is my subject is Rishabh. Now I have to work just on Rishabh, and I know that Rishabh is my subject. That is understanding. You cannot discard it just by saying that it is just predicting next word, and it is just not statistical, right? Do you get that? It is basically everything I've said over the whole lecture, just summarized. Great, 96% is very good. Mm. One thing happened over time. We know 2017, 2018, 2019, Transformer picked up languages where they were going to use the law. 2020, ChatGPT released. But something we figured on the go that research were going on, everything was going in. People were trying and experimenting a lot of different stuff on Transformer. What we understand is if we train on more data, the model gets better. If we increase the number of parameters, like if let's say my model is 7 billion, and if I make it 20 billion parameters, the model becomes good. If I add more compute to it, the models become good. These are basically known as scaling laws. So there's scaling laws. If we improve, if we add more data, the model will get better. If we add more size or more parameters, the model will get better. If we allow it to have more compute, which basically means more parameter, the model will get better. This is basically what scaling laws is, and it was basically a study to show that how we can improve transformer. And from being just a few billion parameters, now transformer have gone up to a trillion parameters. We don't know the exact size of the new chat gpt versions, but it is assumed somewhere to be like about a trillion or more than that. So this is basically, this slide is basically scaling laws, that by a lot of experiment we figured out कि ज़्यादा data पे train करेंगे, ज़्यादा parameters का model train करेंगे, तो we'll get something more better than the previous version. Now, the foundational models, which are ChatGPT, Claude, and etc., we call them general purpose AI, right? We can ask them anything about any field and they will answer. Why? Because it is literally trained on everything. And it has a lot of post processing too. But even if we, do not consider that and just train on every data we have, all the data this world has, it would end up becoming a general purpose AI, because it knows, what medical science is, it knows what computer science is, it knows what transformer is, the thing it is working on, right? It would be able to understand each and everything. This is what general purpose AI is. The foundation is the base knowledge. We no longer build tools from scratch. So yeah, the foundational models are these big models which have their own foundation. The word has like the meaning it's on. There's nothing to teach you here. Where we are in 2025, 2026, we are working heavily on multimodality reasoning and agents. What I mean by that is, you have seen that in the last 8 to 10 months before, we did not have something named as thinking in models. Now when you ask ChatGPT or Claude or all these different models that think and answer, it takes it times to think. That's where reasoning enters. We are giving models some time, but the model does not understand what time is. To them, it's basically like we are allowing it to consume a lot of compute, a lot more compute than before. We understand, हमने अभी देखा in scaling laws that ज़्यादा compute देंगे the model will perform better. What we are doing in reasoning is that we're giving it some more time. मॉडल को टाइम का तो नहीं पता, बट इट अंडरस्टैंड दैट, वी अंडरस्टैंड दैट जितना ज़्यादा टाइम हम देंगे, द मोर टाइम वी गिव, द मोर कंप्यूट इट विल used to inference. That is what it's doing when it is thinking. It is just using a lot more compute, lot more tokens to answer the basically the same thing, but in a more accurate or more precise way. That's what the reasoning paradigm is. It's a lot complicated and how that is done, but at the crux of it, that's what happening. The new thing you guys might have heard over the last couple of months is agents. something happened over the time was LLMs or these big models, we allowed them to call different functions कि like मैंने एक function बना दिया my name करके and that would output Rishabh. Now I can ask my model to use this function and use its output in its final output. Then I can say that use this function and tell me, and it would simply say your name is Rishabh. That's what function calling is it. And function calling was the first thing that happened in language models a few years back, but it was not very good. कि function को calls नहीं कर पाएंगा, it would break sometimes, it would not. Over the time, it has evolved to a level. We have a lot of these different agents. Agents are nothing but different applications you see on the internet. You might have heard of Claude Code, Open Code, or different agents like chat agent or ticket agent or destination planning agent and all of that. These are basically different applications which use some source of LLM. They can either use OpenAI, Anthropic, and they have their system, which is basically they get some input from the user. They have some information that is already passed to them, and based on them, they answer. This is what an agent is. That's you can simply think of it as an agent you hire in like real life to do work. That is the same thing we are doing with LLMs. So this is the current stage we are at, and we have already talked a lot about how we've evolved. I think with that, that is more lot of information to digest in this single lecture. You definitely feel free to go through these slides again and understand each of these things. If you don't, you have the ultimate teacher in your pocket, that is ChatGPT. Answer it, ask it to teach you intuitively, and you'll be able to get what you did not was what you were not able to get in this class. So before I open it up for questions, let's see. Were we able to understand what transformer is, what attention is, how ChatGPT works behind the scenes, right? And all of this stuff which has happened, scaling laws क्या था कि ज़्यादा डेटा देंगे, ज़्यादा tokens देंगे तो अच्छा perform करेगा. Were we able to understand that? Great. 96% is very great. Cool. I think we are already past. Oh, we are just on time. Very good. We'll open it up for 10 minutes for questions and then we'll see what we'll do next time. I'll see if I can share some. We did not, do much as in to make an assignment out of this, but we'll see one or two things more and then we'll jump into questions. First thing I have to show you guys is this. This is an website someone has made where you can visualize the whole transformer like GPT-2, GPT-3, right? If you see, this is something we call as, uh, sorry guys. If you see this small dot here, that is something known as nano GPT, right? This has just 85,000 parameters or 85,000 neurons. You can say it is literally very small or ultimately small language model. Against it, you see GPT-2 small, the model which came in 2020. It was so small, right? GPT-2 XL, it is still okay, good amount of, it has a good size. It has like 1.5 billion parameters. What you see here, just on the side of it, like we cannot imagine the size of this model, how it has grown, is GPT-3. Can you see how much the data or how much the model has evolved? This is what we mean by scaling laws. Ki we have so much data, now we have so much compute, now we have so much neurons, and this is GPT-3, we are on GPT-5. So you can literally call it GPT-5 like 10 times bigger than this. Cool. One thing you guys can do is go through this website and understand how data flows in here, right? So if I go to this Nano GPT, this would be the easiest one to understand. Other are doing the same thing just on a larger scale. So if I press like continue here, it will show me that मेरे पास tokens हैं, उनकी मैंने embeddings बनाई, उनमें मैंने position डाली. And if you just go through this website, like you can see everything in real time as it happens on when you work or when you ask ChatGPT something कि it is answering something, input amendings हो गई, now it will calculate everything, the mathematical calculations it does, and it is a very good visualization you guys can get. इसके बाद the information would get to this, the area you see here. See, the input embeddings are being added to a different layer which we'll talk about. These are all the different steps it takes to output that single word. So a lot of complications happen. This is the transformer formula. Not here. We'll see. I'll show you where the transformer part of this is. Let's run through it quickly. this you can see these different q vectors, k vectors, v vectors, and then this attention matrix, weight and attention matrix. This whole part is basically your attention. This is how we make sure that mera model is able to give the most relevance to the most correct output, and this is how we get the attention output. And after all of this, we do this like 2 or 3 times, like one layer of attention here, then you can see attention is again here. So we do these like 2 or 3 times, and in these this is about just nano GPT. Imagine in GPT 5.2, it is like thousands of time in a single sequence. And by doing this again and again, we make sure that we train on the best data, and from that best data we can recover the best information, and at final you can see it just outputs the next word, because ultimately मेरा language model तो next word predictor ही है. So that was the crux. I'll share the link for this, and I think yeah, I think I can also chat. So this is the link. You can go and check it out. I also post it on Discord. The other thing, if you guys just want fun, we know that these, even though these models have gotten so smart, you can do some fun tricks with it. Try to jailbreak a model. Very hard to do by yourself. So just try for yourself. If you are able to achieve any small scale thing, that's very good. If not, this is a GitHub repo. There's a guy named 𝗟𝗶𝘀𝘀 who's known for jailbreaking everything. If I open this, if I paste the same thing, ChatGPT is gonna answer me some very weird stuff. You can literally ask it to how to make drugs and all of that, and you have seen that a lot on Twitter or all of that stuff. This is how they do it. This is a way we can inject a lot of, basically what happens is these big organizations like OpenAI, Anthropic, they do not allow by themselves to use these models for forward purposes like knowing about weapons and drugs, but we know that that information is definitely in the data they are trained on. And for that information though, but there's a plug which OpenAI has switched off, which basically does not allow it to answer in that form. What this form does, it is that it opens that valve or that node, and now it would be able to answer anything you ask, because it is, you can, yeah, it is jailbroke. There's a lot. This guy has built it up for every different model. Feel free to try it out and understand what this is. इसने prompts कैसे बनाए हैं, function कहाँ का use किए हैं, and that's some fun thing you guys can do until I see you the next time. And with that, let's get some questions, and we'll call it a class. I'll open the chat and let's see. Not getting any, or my machine is stuck, something like that. Lot of questions. I'll pick a few and then we'll call it off. I think the class was great. At each point, I guess the response was above 90 or 95. Where will we be writing the code, like VS Code or we'll start from Jupyter, or you can say Colab notebooks. If I show you guys what Colab is, it's basically, there's a website named Colab by Google. It has these different, if I open new notebook in Drive, it takes some time to load up, but it is basically an environment where you can run your Python code. It is a bit different from your visual code or the way you write code. Like here I can write print Rishabh. What it does is it basically executes each block of code independently, but you can use your previous variable you have defined. It takes some time to start, but as soon as it starts, each output is in different block. Like here I can work on completely different thing, and you can make a function like def add, which takes in two parameters a comma b. What it does is return a plus b. I have defined it. If I call add 2 comma 3, it is gonna output me 5. This is what Jupyter notebooks or Colab notebooks are. You can use them to execute different blocks of code which can be executed independently. It allows you to work, agar kuch fat gaya, if something breaks in the previous node or the previous line of code, you can continue it without rewriting or rerunning everything. That's what Colab notebook is. We'll start it from here. Then it's your choice. You can pick it up on VS Code, wherever you like. I was studying vector CBOS. Yeah, we have gone through them. That's how we go from words to meaning of words in numbers. So the parameters are the neurons. Yes, the parameters are the neurons the model has. So a 1 billion parameters model means it has 1 billion parameters in it or 1 billion neurons in it. Could you provide the topics that will be covered? Yeah, most of them are, I think. What are parameters? Parameters are the basic nodes. Like, let's see what, if I go to Google and see neural net, and if we, what image comes up when we search for neural networks? Something like this comes up, right? These circle things you see are called as neurons. 1 billion parameters means the model has 1 billion of these different neurons. Neurons are basically the smallest unit of intelligence, you can say. Our brains also have neurons which gets fired up on different actions or different, as we do different stuff, different neurons gets fired up. It's somehow working like this transformer architecture. Okay, we've answered that. How is LLM able to decide the next word will be there like billions? Yeah, it is not exactly able to decide the next word, but it's, as I've shown you, it gives you a list of words, and based on that, it's our choice if we want to choose the most probabilistic one, or if we want to do more creative stuff and choose a word with less probability, and we can do that. But basically, it returns a list of outputs, a list of words. From there, we choose, add it to the input, and process it all this again. Can we learn paper? We'll do a class where we see how we learn how to how to read a paper, how you can use different models or ChatGPT to understand a paper and then work around it. And then what parts of paper to pay focus on, what can you leave the mathematical notations behind? If not, what to pay attention to, how to use ChatGPT to understand the maths and all that. We'll do something for that. Yeah, we'll quickly go to applied AI, not in much time, but without basic understanding of what is actually going behind the API, I don't know what will you do with the information of passing stuff to open API. When someone asks you more fundamental question, because soon like coding is not the mode anymore. People are not going to ask you coding problems or how do you code this or how do you code that. They're going to ask you more fundamental questions that does the person know, does the person has the intuition for this stuff, because my company is working on it and I want the people who work the best on this and have the intuition from the very foundations. Does this person have that or does this person not? Based on that, the recruiter might take decision on. These are some basic things, foundational things you guys should keep an account of. Okay, detailed syllabus, paper reading, cool. How do we give data? It's basically we have a lot. Let's assume you have a very big database which consists of all the data from the internet. Basically, what all these companies did at the start is scrape all the internet. They made web crawlers. They go to every website, every web page, copy all the content from that and put it in a database. Then that database is used to train these models. What is NN? NN is a neural network. Okay, agents, we've talked about that. Is this, yeah, everything that deals with neural networks comes under the field of deep learning. Can we do some, we'll look at some code, yeah, soon of how do we code attention? What is the actual mathematical formula that goes behind attention? We'll code it in, these collab notebooks I've shared. But very foundational thing, if you understand what I've taught you today or what we have gone through today, we'll be easily able to, it might be, it's just about some more mathematical notations, and then you completely understand what attention is, how is it, and then over the time as we go through the course, we'll understand. Okay, that was 2020. We are talking about 2021, but 2026 is a lot different. How these how these models are so fast. How did we deal with the memory inefficiency? Because still we are processing all the information again as we go through this iterative loop, right? So we'll do all of that and see how the optimizations were made, and we'll code out all these optimizations. So that's a fun activity to do. Okay. Mm, yeah, AI time travel, you can say. The course of AI we have covered. So you guys can actually stand at a point that someone asks you, okay, by ChatGPT, how is it working? You can say that server page, this is what's happening. There's something named as transformer. In transformer, there's something named as attention. This field of learning is deep learning and all of that. Now you know that. Now you intuitively understand and give them examples of the word like tired and wide can change the sentence completely. Older models were not able to do that. Transformers can. Why? Because of attention. Does the recent MHC paper from DeepSeek differ? It builds on the same idea, not the same idea, but there's something known as residual connections in these transformer architecture, which we'll see when we in the diagram when I'll show next. But what that paper basically shows that is instead of passing single stream of information, we do multiple streams of information with some mathematical improvements like it used stochastic matrix and all of that, which is not relevant to teach here or right now, but it improves the stuff of hyperconnections mathematically, like using W stochastic matrix and being a bug of polytop and all of that. So that is a completely different topic, not worth right now. Will you teach how to build SML, SLM? I assume small language model. There's a lot of project or open GitHub repos. I think even if you search Nano GPT, you can look at how Nano GPT is coded. It's now coded by a lot of people. You will be able to understand, but don't look at it right now because we'll go through how each of these block is coded. After that, if you go to it, you will not be stuck into oh attention ka formula dekh liya. Now this is not making any sense of it. It might end up confusing you. Where and how attention paper you haven't seen. Yeah, the website I shared you in there you can see different Q, K, V things, right? Q parameters, K parameters, V parameters. Those are actually the transformer parameters. And if we do some, mathematical manipulations with them and apply a formula, we get the attention weights, and those attention weights basically allows out to when it is called animal light हो रहा है या फिर road light हो रहा है, and that's what tells you the attention weights. So basically, the idea is that transformer gives you a list of outputs. In there, the list is ordered by probabilities. So basically, the output of transformer is not just a single word, but a list of words which are ordered by different, priorities or probabilities. And based on that, you can choose. The most famous one is greedy choosing, which is basically choosing the highest probability one. The parameters are the neurons used. Yeah, neurons and parameters are the same thing. Next word predictor is basically LLMs. There's no improve. These are not different words. Like next word predictor is same as language models. Cool. How did we get the attention property of LLMs to there? Right, so I'm just finding it hard to visual. Could be. Yeah, you might find it hard to connect attention completely because it was something that just came out of pure experimentation. That when you do some similarity between these two words and then attach some weights to it and multiply it with another function, you get something which we use in sentence is basically allowing us to make the word relevancy more sense, or be ultra specific or selective to the word it chooses, which RNNs and LSTMs were not doing. We'll share the slides after a bit. I'll share. I think the other link will be posted on GitHub, not GitHub, on Discord. Are there any books I can? I would not prefer books right now. Can go through different blogs. I would say just search up the field you are interested in or you want to learn about, and look at the blogs different researchers have there. Or the best thing you guys can do other than that is basically start with ChatGPT or Claude if you have. Yeah, but yeah, again I've told you why we are starting with this and not directly with coding random applied AI stuff. Yeah, I maintain both for those who do not understand or for the hard part. Cool. I think that's it for today. Hope you were able to enjoy this class. The last poll to see how this class went, and then we'll call it off and see you guys next week. I'll share all the information or all the slides, links, and all of that in the Discord, and we'll see you the next time. Until then, bye bye. Have a good night. See you guys. Bye.